prospects and challenges for the biochemical and petrochemical sector as part of the 1 week, 1 theme program initiated by CSIR. Guided by the visionary leadership of the Honorable Minister of Science and Technology, Government of India, Dr. Jitendra Singh, CSIR has embarked on the 1 week, 1 theme initiative to showcase transformative projects across 37 constituent laboratories. With over 6 decades of pioneering research, CSIR is dedicated to reducing our nation's reliance on imported technologies and developing essential petrochemicals and biochemicals for industrial applications. Today's event provides a unique platform to highlight some of CSIR's cutting-edge capabilities, groundbreaking achievements, and innovative contributions to the national objectives of petrochemical and biochemical sectors, especially from the 4 respective labs from CSIR-IIP, CSIR-NCL, CSIR-CLRI, and CSIR-IMTech. We are honored to convene a distinguished assembly of industry leaders from top organizations. Our aim is to foster knowledge sharing, tackle current and future challenges, and explore collaborative opportunities where CSIR can be a pivotal solution provider. Your presence here today will greatly enrich our discussions, and we look forward to your invaluable participation. With this, I would like to ask Dr. Harinder Singh Bist, our director, to escort our chief guest to the dais along with Dr. Maiti and Dr. Umesh. Today, the chief guest for our event is Dr. Bipin Thapliyal, who is currently the Secretary General of the Indian Agro and Recycled Paper Mills Association in New Delhi. And before beginning the program, we would ask Dr. Bist to felicitate our chief guest with a bouquet and Angavastra. I would now like to ask Dr. Maiti to felicitate our director with a bouquet. Without taking much of your time, now I would like to call upon Dr. Umesh, who is a principal scientist here in CSIR-IIP, to give you a brief introduction about the CLP theme as well as the overall OAT, OWOT program which is being conducted by CSIR. Please, Dr. Umesh.
Thank you, Dr. Prasenjit. Honorable Chief Guest, Dr. Bipin Thapliyal, Secretary General, Indian Agro Recycled Paper Mills Association. Director Sir, our Chairman, Committee Chairman, Dr. Samir Mathi, distinguished guests from the industry, media person, as well as seniors and friends. A very good morning to all of you. It's my distinct honor and privilege to welcome you all to the Industry Meet event on R&D prospects and challenges in petrochemicals and biochemicals. Today mark a significant milestone as we gather here to celebrate innovation, collaboration, and relentless spirit to progress that will help the petrochemical and biochemical industry in India. The 1 week, 1 theme program is an initiative already said by the Dr. Prasenjit, our Honorable Minister, that is Dr. Jitendra Pradhan. And it is a 5-day program which was inaugurated on the 15th July at IICT Hyderabad. And along with the IICT Hyderabad, it is different laboratories are participating in the program, just like the CSIR Bhavnagar, CLRI Chennai, NIST Jorhat, Sikri Karaikuri, NCL Pune, NIST Trivandrum, and our IIP Dehradun. We are organizing this event in a solo manner as well as in a collaborative mode with the 2 or more laboratories. In this one, among the 37 laboratories of the CSIR, all chemical research related laboratories are participating in this event, and they also the participant for the chemical theme. That is, the chemical theme is the chemical and petrochemical, including leather theme. So it is the CLP theme, that's why. And the CLP theme is directed by our Director CLRI, Dr. Sriram, as well as our director, Dr. Bist, is the nodal for the petrochemical and biochemicals. Today is the third day of the program, focusing on the petrochemicals and biochemicals. The CLP theme was initiated just after the finish up of the 12 5-year plan, that is the 2017, and it is continuing from that time. Under the CLP theme, a number of projects have been awarded and covering the fine chemicals, bulk chemicals, polymers, biochemicals, pharmaceuticals, leather chemicals, and the petrochemicals. In the theme, we have 3 types of the projects where we focus on the low-hanging as well as the basic focused research. In the current year, we are running the 19 FTT and the FTC project. FTT means the fast-track translational and the fast-track commercialization research projects we are running, and 9 focused based research projects are ongoing at present. In this one, also we have the current budget allocated for these projects is more than 25 crores. I am thankful to the dignitaries from the industries and CSR family for accepting our invitation for this event, and having the visionaries and leaders who are shaping the future of R&D in the petrochemical and biochemical field. It's a great accomplishment to plan our future and challenges in the field. This event is more than just a gathering. It's a platform where ideas will converge, partnership will be forged, and new horizon will be explored. I wish we will engage in the insightful discussions, share valuable insights for the future R&D intervention in the petrochemical and biochemicals. The event is organized to strengthen the bond between industry and the R&D institutes like us. Event will cover different talks from the industry personals as well as the scientists from the CSIR, different CSIR labs as well as from IIP. Together, the industry and CSIR can stand at the forefront of the technologies with global competitiveness. So with this work, I would like to thank all of you, and I would like to request Director IIP for his kind words as well as the introduction to Director or Chief Guest.
Very good morning to all. Honorable Chief Guest, Dr. Bipin Thaplial, Secretary General, Indian Agro and Recycle Paper Mill Association, India. Distinguished guests from different industries, Dr. Bharat from BPCL, Dr. Jhala from IOCL, Dr. VP Joshi, Head R&D IGL, Dr. Ravind Maiti from EIL, Dr. Bhupesh Samant from Godrej Chemicals, Mr. Manish Kothari from Flowchem Pharmaceuticals, Sri Nagendra Agnihotra from HMEL. All of you are welcome here. Anuj from headquarter, my friend. Colleagues from different CSIR laboratories, my own CSIR family, friends from print and media, students, ladies and gentlemen. I feel extremely happy and honored to welcome you all to this industry meet event. This program is outcome of 1 week, 1 theme program, an initiative of our Honorable Minister of Science and Technology, Dr. Jitendra Singh, and immense encouragement and support from our Director General, Dr. N. Kalai Selvi. This is the first industrial meet after COVID-19 times at CSIR-IIP, and I'm very delighted to welcome you all here. I would like to briefly talk about the CSIR's thematic activities. CSIR research domain is broadly categorized into 8 themes, and clusters of CSIR laboratories have been made according to their thematic expertise. So from 24th to 28th June, we celebrated the EED theme, that is energy and energy devices. And from 15th to 19th July, during this week, we are celebrating the CLP, that is chemical including leather and petrochemicals theme. And the director CLRI, Dr. Sriram, is the nodal director for this theme. The celebration of CLP theme, as Umesh already told you, inaugurated at IICT Hyderabad on 15th. And this was followed by various programs during past 3 days. And today we are conducting this industry meet for this CLP theme. During the coming weeks, we will be celebrating 6 other themes, remaining themes of CSIR, that is AEIS, that is aerospace, space, electronics, instrumentation and strategic sector. CIE theme, that is civil infrastructure and engineering. E3OW, that is ecology, environment, earth, ocean sciences and water. 4M, that is mining, minerals, metals and materials. A and B, that is agri, nutri and biotech. And HTC, that is healthcare theme. So overall, all the laboratories have been clustered into these 8 themes based on their expertise, and every week we are celebrating one theme as our expertise in the entire CSIR system. So friends, I think the confluence of R&D and industry is extremely important for the translation of research from lab to the real world, and for making the scientific community aware of the problems and challenges faced by the industry, so that new research projects can be undertaken. I sincerely hope that this platform will provide an opportunity for industry personnels and the CSIR scientists to exchange their thoughts and ideas. India is the fastest growing economy in the world, and contribution of the chemical and petrochemical industry is extremely important to this growth. The current per capita consumption of chemical products in India is way below the world average. So that indicates that there is great potential for growth of this industry. There are immense value addition possibilities in chemical and petrochemical industries to cater the demand of the growing population in almost every walk of life. CSIR-IIP has been working to develop indigenous processes, intermediates and products for the chemical and petrochemical industry. And I would like to give you a glimpse of what we are doing in this sector by a brief presentation. So as I already told you that this industry meet we are celebrating for the CLP theme. And if I want to categorize the work of CSIR-IIP, I have tried to put them in 6 baskets. The baskets in green colors are more related to the CLP theme, that is chemical and petrochemicals. I think they can sit there too. You can, it will be better to sit there. And little bit I will talk about इसका pointer किधर है? आ रहा है इसमें? चलो ठीक है. So let me just give you a brief glimpse of the first 3, the non-green baskets, the fossil, renewable and alternative fuels. CSIR-IIP is working on these areas. Fossil fuel is our core research area, because we started as an institute for doing research on fossil fuels, petroleum, as the name suggests. But we added, with due course of time, we added renewables and alternative fuels into this. Renewable fuels, we are talking of biogenerated fuels. I am very happy to tell you that our SAF technology has been approved, and now MRPL has given the LOA to EIL for construction of the 9,000 ton plants. Yesterday only we got this news. So great news, and EIL person is also sitting here. So congratulations to the entire SAF team, including EIL team here, sitting here. So and alternative fuels, we are talking of fuels from waste plastic and other materials, which are not coming from fossil sources. The societal contribution, as you know, in the hilly regions, lot of forest fire happens. So what we did, we have done a pilot project in Champawat district to collect the pine needles, which are a big source of forest fire. and briquette them and provide them to the nearby industries as a biogenic fuel. So it is killing 2-3 birds in single stone. That is, first you are generating employment for the local people because they are getting 5 rupees per kg, the cost of this collected pine needles. So they are getting additional revenue. Second, you are preventing the forest fire, which is one of the biggest environmental concern for the hilly regions. And third, you are providing a cheap biogenic fuel which can replace coal to the nearby industries, which will save the environment in another sense. So a lot of efforts are going for this. So this is also one of our areas. Energy efficiency improvement, although this comes to CLP theme also, as every industry want to save energy. Energy is one of the big concern. But this we are talking of mostly like we have made our own PNG burners, which can save up to 30% or more than 25% of fuels if you are using a LPG retrofitted burners. So that kind of work we are doing in these baskets. Now for the other 3 baskets, I will come one by one. So first I will just give you a brief of one of our technology, which is we are the only technology provider in the world right now. This is the wax separation from waxy residues. This is a joint technology again with EIL and Numaligarh refinery. We set up this plant of 50,000 tons per annum capacity in NRL, Numaligarh refinery. And before putting this plant, we were a biggest importer of wax. After setting up of this plant, now NRL is exporting wax to more than 35 countries. So this kind of change in scenario can happen if indigenous technologies can see the day of commercialization. And again, you need a very good industrial partner to realize these dreams. So in this case, EIL was our engineering partner and NRL was the industrial partner, and this became a joint technology of all 3 of us. And we are very, very hopeful that in coming time, probably 3-4 Indian refineries are going to see commercialization of this plant, this process. And not only import substitution, it gave a lot of emphasis to the local employment generation also, and Assam became a hub for candle manufacturing also by this process. The second, again, this is a very, very unique, only plant running in the world with this technology is designed by IIP. So this is again benzene recovery. You know, friends, in 2015, USA changed its gasoline specification and said the benzene content in gasoline cannot be more than 0.6 to 8%. Most of the Indian refiners who are exporting to US, or any refiner who is exporting gasoline to USA, they became puzzled by this problem, that how we will export our gasoline to USA now, because benzene content is much higher in gasoline. IIP developed this technology. We have a very good separation expertise. For very long time, we have been expert of separation technology, extraction technology. So this technology was developed, then it was translated into one of the biggest refinery in the world, that is Reliance Industries Limited, Jamnagar. And Reliance became our joint industry partner in this technology. And soon we are trying to outreach to other refineries also. Wherever any refinery want to reduce the benzene content in gasoline, this technology is perfect. This is running from 2016, so long and industrial provenness is there. And what we did in this, we focused, see, gasoline or petrol is a contribution of several streams mixed together. So what we analyzed, that which is the stream which is causing maximum benzene increase to the gasoline pool. And then we analyzed that FCC hard cut naphtha is having maximum benzene. So this plant was set up to remove benzene from FCC hard cut naphtha. And you know, sometime you see big opportunities in the challenges. So what happened? There was a problem to sell the gasoline, but in this process what happened, Reliance could separate a product which was much, much expensive than petrol, that is benzene. So the benzene recovery increased the profitability of Reliance. So such kind of work we are doing in petrochemical sector. Now this is again a sweetening catalyst, big success. Now almost more than 50% of Indian market is covered by IIP. BPCL person is sitting here, so it's a joint technology. We transferred this technology to a small company, Lona, who became the world leader for making this chemical, Thoxcat. And now you will be happy to know that we are reaching out of India. Now Oman or PIC has used it. Now we are selling this to Saudi Aramco. and we are trying to increase our footfall in almost entire gamut of wherever people use this kind of sweetening catalyst, which is the process to remove sulfur from LPG without doing hydrodesulfurization. So if you see, the journey of this was started in 1994 along with BPCL, and in now slowly and slowly we have added more and more, and this is the container of our product, which is sold to different refineries who want to remove the sulfur from LPG and lighter streams. One of our another process where again EIL is our engineering partner. This we are trying to recover helium. You know, helium is a very scarce gas. Its availability is not very high in environment. Generally present in natural gas in about 300 to 500 ppm range. To bring from 300 ppm to 99.995% purity is a big challenge. But since IIP is having expertise in the separation process, which we have now made a platform technology to use for almost 7-8 different applications for gas separation. Not only helium recovery, we can do medical, I will tell you later that medical oxygen or raw biogas to PNG quality biogas, or coal bed methane to PNG quality biogas, or CO2, high purity CO2 purification. So there are so many different areas where the same technology with slight tweaking, slight operating condition changes, adsorbent changes can be applied to so many different areas. So this is one, and why, you know, why the helium is important, as you know, it's a very low molecular weight gas, lighter than air. It is very low boiling gas, so a lot of cryogenic applications it is used. Then it has very high thermal conductivity, almost 6 times more thermal conductivity than air, so for heat transfer in the inert areas. So those kind of applications we are using about 70 million meter cube, normal meter cube per annum, and costing 55,000 crores of import we are doing for this commodity. So very scarce, and we don't have any source in India. So this is a hybrid technology where we are using two approaches: the cryogenic approach to bring it to crude helium gas, and then from there to make it high purity A grade helium, our own platform technology of VPSA. So together this can be these two technology combination can be used to recover this scarce gas from natural gas. We are going to put a demo plant soon at a production site of ONGC. Again, EIL is our engineering partner for this technology. Now a little bit of about plastic. You know, no matter how we curse plastic, the plastic is going to stay, because there is no real substitute of plastic right now. If you see, all the good qualities of this material are making it almost inevitable in our every walk of life. It's cheap, it's lightweight, it's easily moldable, it has good tensile strength, it's had versatility, inertness, all the properties which you need. And if you don't use it, suppose you want to say we don't want to use plastic for polyesters and making cloth, can you imagine how much cotton you have to grow? So the load on the natural resources will be extremely important. So you cannot bypass this. Only thing is to use this product in a judicious manner, in an environmentally sensible manner. That is the only way out. Because if you say that, and you will see that most of the companies, they are increasing their polymer capacities. So it is not going to go away. If you see the consumption, we are having about 21 million metric ton per annum, and world is having about 450. Our per capita polymer consumption is much lower than the world. So there is a great potential for Indian polymer industries to grow. Now most of the polymers are PP and PE, which are mostly used for single-use plastics also. So these polymers are the biggest candidate for chemical recycling. Because if you see PET bottles, the PET bottles are almost 100% mechanically recycled. So I have classified the polymers in, actually already classified into 7 categories from 1 to 7, but I have just put them in different groups to show you in the bottom that PET is already 100% mechanically recycled. So the If you see a triangle and 3 is written in between that, that means it is PVC. PVC we don't want to use for chemical recycling because of liberation of chlorine, which is a corrosive material. So that can be used for other applications like making tiles, fire resistive materials because it's fire resistant. Then there is a category 7 which is all other kind of polymers. But our focus is on, when you see it in between the triangle written 2, 4, 5 and 6, those are the polymers which we want to recycle for chemicals and fuels. So this is the segregation of polymer is again a very big thing. So whoever want to recycle the polymers, a good technology for proper segregation of polymers is again very, very important. Now this one, we have set up a 1 ton per day plant for recycling of waste plastics, especially PPE and to some extent PS also, polystyrene also. This we are working along with GAIL. GAIL is our industrial partner in this. And what we are trying to do, I am not covering the waste plastic to fuel into this because that we have covered in EED, energy and energy devices theme. Here our focus is to chemicals and petrochemicals. So this technology again is a versatile technology based on the catalyst. First stage is the pyrolysis, which most of the plastic recyclers are doing. They are just pyrolyzing and getting a black oil which they want to use for low-end applications. We are not stopping at that stage. The plant is having a second reactor. The reactor design, the operating conditions and the catalyst is depending on what kind of product you want to get out of the plant. If you want to get gasoline, then you have to use a different catalyst. If you want to make fuels like diesel, you use different catalyst. And if you want to make BTX, that is benzene toluene, which is coming under today's discussion, that is petrochemicals, then you have to put a different catalyst into this plant. And the quality of all the products after coming out of these plants meets the specification. If you are making fuels, then our fuels which are coming out of the plant are meeting the specs of petrol and diesel, so that they can be directly used as a fuel to the, there is no further polish or refinement is needed for this one. And the beauty is that this plant does not need any hydrogen to make these modifications. It's the internal rearrangements of molecule which is making, so you don't need any extra utilities. Most of the utilities can be generated, because if you see, the gas generated in this unit can be used as a fuel for pyrolyzer. And so this technology, we are at TRL6. We are now making it more robust to when we want to launch it to the commercial scale. So we are currently we are doing study in this 1 ton per day plant for various applications, for making gasoline, for making diesel, as well as for making BTX. This is another work which we are doing with BPCL. So if you want to utilize CO2, you have to mimic nature, because you know, at ambient condition, ambient pressure and water as solvent, nature is able to convert this environmental CO2 into trees, into fruits, into so many different things. So if you want to anything, and CO2 is a very, very stable molecule. If you want to convert it into something useful, you have to put a lot of energy. So the economics is one of the major challenge, how you want to convert them into a useful product without using too much energy. The same problem is with green hydrogen also, because the amount of electricity you want to put to electrolyze water is a huge amount. So the challenge is how the nature is doing these things at such a nominal operating conditions. So to use that, what our team at CMSD is doing, they are designing photocatalysts, like similar to what is happening in photosynthesis. So these kind of photocatalysts can convert CO2 into useful chemicals like DPC, diphenyl carbonate, which is engineering plastic monomer, and it is in great demand. So, and the current routes are not environment friendly. You have to use phosgene and other toxic gases for this. HCl is generated. So those kind of things can be avoided if you use a simple addition chemistry with use of a photocatalyst to convert phenol and CO2 into this wonderful plastic monomer. Now I was talking of our separation technology for gases as a platform technology. So this is one example where during COVID time, when there was very scarcity of oxygen. Oxygen, medical grade oxygen was not available at that time. At that time, this project was envisaged uh, in June or September 2020, and from lab scale to commercial scale went in less than 1 year. That is one of the example where the translation can happen so fast, and that too even that time when COVID was at its peak. By this technology, what we have done, we have that was with the help of PM Care Fund and DRDO. We were able to put 108 these kind of medical oxygen plants across 108 plants across various government hospitals, and more than 50 plants across state and other private hospitals when there was complete scarcity of oxygen. So it was a big achievement, and I thank the entire team and our my predecessor, Dr. Anjan Ray, who was the director when this project was done. So a great team effort at the time of crisis shows that if you are determined, you can take on any challenge head on, and you can succeed also. So it's the same thing. Just to give you more slides, and that time it was in big news. So many news channels also covered this. Now another work we are doing with NTPC. You know, NTPC is trying to utilize CO2 in every possible way, and one of the ways to convert this CO2 into methanol. Again, the challenges come that the per pass conversion to be increased, the energy cost to be minimized, and you have to have an indigenous catalyst. So our LSPD, Livestock Processing Division, is working on this problem, and soon we are going to put a 10 kg per day methanol plant at NTPC Netra in Greater Noida. So this is another example of CO2 valorization, because no matter how we talk of CO2 capture, until you do something with the CO2, what you will do by capturing the CO2? We don't have enough space to put this CO2. Sequestration also, there are different other challenges. Basalt rocks, another challenges. So many challenges. Transportation of CO2 from one place to another is again adding cost to it. So until you have some big value added product out of CO2, the only capturing of CO2 is not going to solve this global warming position. So this is what we are doing in this direction, to make that CO2 into convert into valuable products. And this, once you make methanol, you can make a lot of different chemicals. You can make DME, which is a substitute of LPG also. So many outlets become open to CO2 if you can convert it into methanol. Only challenge is how to bring the cost of this methanol at parity with the methanol you produce from syngas, because that syngas methanol is cheaper to this methanol. And there may be a time when there will be CO2 taxation. At that time, this process will become economical. So we should be ready with the future scenarios also. So in that direction, this is one of the big step. And our catalyst is giving best per pass conversion. We have seen different commercial catalysts also. So this team has developed a wonderful catalyst which is giving very good conversion. This is work we are doing with Oil India Limited. You know, wax deposition in crude pipeline is another big issue. When you are operating the pipelines and the wax is depositing on the inner surface of the pipes, then the throughput reduces. So our CMSD team and this upstream wax rheology team, so these two teams have together made this flow improver additive, which is giving more than around 70% reduction in wax deposition. If you see on the right hand side, there are two cold fingers picture you can see. The picture on the left without additive is having a very thick layer of wax deposited on the outer surface, the black layer. And the right side picture, same cold finger, when you add our additive, the wax deposition reduces to about 70%. So this again going to commercialize soon. The OIL will be floating the EOI for this manufacturing of this chemical, and then it will be applied to their pipelines in Duliajan. This one is our new project where we want to have a mission mode project across entire CSIR with different laboratories, because CSIR is having Advantage that each laboratory has expertise in some particular area, and we have 37 such laboratories. So if you collectively see, the expertise of CSIR is almost every walk of scientific life, somewhere or other you will find experts available within the CSIR. So what we want to do here, we are processing about 254 million tons of crude oil, and most of it, almost 85% of it, we are importing. Huge loss to national exchequer. We are spending a lot of money, about $157 billion for importing crude oil. And there are few resources which are becoming a headache for us, like plastic, like waste biomass, which we are burning, subtle burning, other things. So why can't we design an overall process where we can use the indigenously available resources, carbon resources, and convert them as a substitute of crude oil? It is a big challenge because so many challenges are there, but we have to do a very holistic study from cradle to cradle, entire cradle to that cycle. We have to compare the economics, the CO2 emission potential, how much CO2 we are minimizing or we are increasing, what is the economics, what kind of modification in the hardware of the refineries will be needed, whether it is economical to do those. So it's a very big holistic study which we want to do to see if we want to use these surplus resources available within the country to supplement the import of crude oil, what kind of challenges we will face, whether those things will be economical or not, whether we will be able to mitigate the CO2 problem or not. So overall, all these aspects we want to cover in this project, which is a very big mission mode project, and we will invite various industries to show their uh, willingness to join hand with IIP for this project, because alone we cannot do this. We need industrial partners also for this. So this is our typically the petrochemical intensity index, that is called PII, of Indian refineries is less than 10%. That is the amount of crude we are processing, we are making less than 10%. You bar few refineries like Reliance or Naira, which are having slightly more than this. But overall, there are refineries who have claimed up to 70%, like Hengli in China. But the problem is they are targeting a very specific crude oil, very light crude oil, and mostly concentrating on paraxylene. If you want to see the amount of price difference between Brent, WTI, Dubai basket versus the other low opportunity crudes like the Venezuelan crude, like Russian crudes or the Iraqian crudes, there is a big margin difference. But the problem is why they are cheap, because they have some or the other problem. When you want to process them in the refineries, you face different challenges: asphaltene, metal, sulfur, viscosity, deposition, all those things. So what to be done to make the refineries compatible with these different cheap opportunity crudes along with the available carbon resources of the country? So this is one of the biggest challenge which we want to, I'm not saying we will be able to solve all the problems, but at least we will know what are the problems and where the effort is needed. So this is the objective of this project, that we want to holistically study the entire scenario, and if we want to go through this route, then whether it is feasible, what kind of challenges it will bring, how to solve those challenges. So a complete database at a single point where you have to tweak into the refinery configuration. Suppose you have a liberty to design a grassroots refinery. What kind of things you should keep in mind while designing a grassroots refinery, so that in future you will be able to cater to all these challenges? So that kind of work we want to do under this project, and I again request all the industry partners to show their willingness if they want to join hand with CSIR-IIP for this project. With these words, I again welcome you all to this theme and wish you a very productive discussion and a whole day of very enthusiastic interaction among all of us. Thank you very much. Thank you.
Thank you, sir, for the enriching talk showcasing our strengths and accomplishments. Now, I would like to call upon our chief guest, Dr. Bipin Tapriya, to deliver his speech. Before that, I would like to give a brief introduction about him. Can we have the feed? Dr. Bipin Thaplial holds an MSc degree, MSc, MTech and PhD in Polymers Technology. Okay, since February 2021, he has been the Secretary General of Indian Agro and Recycled Paper Mills Association. With over 31 years of administrative and research experience in pulp and paper, Dr. Thaplial served as the director at Central Pulp and Paper Research Institute, Saharanpur from August 2017 to January 2021. He began his career at CPPRI as a scientist in 1990. After 3 years of teaching and research at Delhi College of Engineering, Dr. Thaplial specializes in energy and environment management, water reuse and recycling, biotechnological applications, process simulation, chemical recovery, and paper quality assessment. He received training in computer simulation in Czechoslovakia and energy and environment management in Japan. He has visited mills in Finland, Hungary, Austria, Switzerland, Netherlands, Japan, France, Japan, Indonesia, and Thailand. And he has published over more than 150 research papers and 200 technical reports, and has guided 10 PhD students in pulp and paper technology and related fields. Currently, Dr. Thaplial is also the editor of In Paper International, a quarterly journal on global pulp and paper industries. With this, I would like to call upon Sir for his talk.
Thank you very much. It's an honor for me to be with you all today. A very good morning to all of you, distinguished guests, fellow industry enthusiasts, scientists from IIP and other CSIR laboratories, and ladies and gentlemen. Basically, I am a course scientist from the heart, and I have worked with the pulp and paper industry for almost 3 decades, and I will be delving mostly on the issues related to pulp and paper and how we can get the support from the CSIR institutes, not only IIP but many other institutes. I'm really impressed with the OWOT. This is one very interesting initiative, and particularly it is being guided by the Honorable Minister of Department of Science and Technology and Ministry of Science and Technology, Dr. Jitendra Singh, a very good and visionary who I hope would like to steer it further. And it is very interesting, as Dr. Best told, that you are taking up various subjects and topics related to the industrial research, and among the 37 CSIR institutes, it will bring a lot of solutions to the industry. I am very hopeful about that. So with these words, first of all, let me thank Dr. Bist to give me an opportunity to be with you today. And as I told, I would like to present the developments of the biochemicals with a focus on pulp and paper industry, as it was my association for last 3 decades. One very important aspect which makes it a compatible industry with what we are talking today is that the uniqueness of the pulp and paper industry, because it is based on biomass, renewable resources. And second thing, it is the oldest industry which is linked with our social, cultural, economic growth of the country. So we are basically intermingled. So any growth which will be a part of our industry will be transferred to the total structure of the country. So being a part of the industry which is based on renewable resources, so there are various opportunities for integration of biochemical processes and the products in our industry. And that will be the main point which I would like to deal today, and request Director IIP to take it forward if with the permission and with the interest of the institutes, CSIR institutes, and particularly IIP, we can organize similar interaction meets and workshops with the industry. Particularly, I can bring the paper industry, and we can discuss various issues. And if it is possible, institute can win their heart, because they are basically core industrialists. They look in the profit margins. You must be understanding, sir, because if there is some profit margin and a guarantee, performance guarantee, then certainly industry will like to deal with many of the subjects. Particularly, I would like to tell about the technologies which you showcased. Some of the technology I was noting down are very much useful for our setup. Waste plastic recycling. Paper industry generates a lot of waste plastic. Where from it comes? It is the waste paper or post-consumer waste product which we recycle, and that is mostly either laminated with plastics and some other form of either laminated or in different layers they are produced for different applications. So the waste plastic which we generate, I'll give an example. Nearby Dehradun, we have the Muzaffarnagar cluster of paper industries. They generate about 5 tons of plastic per day from 2 or 3 industries only, which I could assess. So if we combine in a cluster all the paper mills, we'll have huge quantities of waste, which at the moment is not utilized. And there is no value addition. First of all, that is the biggest point. So your plastic waste recycling is very important for our industry and very useful. Then you talked about diphenyl carbonate from phenol and carbon dioxide. Very, very interesting subject. And this is one area where our industry can work with you. Particularly, we can separate lignin from the black liquor, which is the biomass generated from the industry as a waste. And right now we are only incinerating it in a specially designed boiler, which we call recovery boiler. And this is a very, very low cost utilization. But if the lignin is separated, which is almost 40 to 50% of the total mass, solid mass. So this diphenyl carbonate from the phenol generated from lignin, because these are all aromatic compounds, very, very, very highly complicated compounds, and phenol production, and then the utilization of carbon dioxide from either from the flue gases or some other sources. That will be a very good example of carbon capture in the industry. As you mentioned, phosgene replacement will be one of the very important aspects for our industry. Then carbon dioxide to methanol, particularly from the syngas, which we generally think about, that may be one of the important area for us. And crude oil to chemicals, like our bio residue upgradation, that also can lead to a lot of examples. So these are some areas where we would like to deal with you, Dr. Saab, and with the scientific community from CSIR. Let us work out some way how we can take it further, and I would like to discuss, because right now I am with the part of industry, and we deal in different situations, how to tackle. And when we talk about this with the industry officials and the ministry officials, then generally they all talk about change the public perception, because our industry is viewed and is looked at as one of the polluting industry. So that may be some solution from the work already being done, or we can also plan to devise some projects jointly with the support from government, Bureau of Energy Efficiency and Ministry of Power, and many other sources of funding, so that one demonstration plant, if it is brought out in any industry, that will be a boost, that will give a boost to our support for the environment. So I'm not very much aware about the petrochemical, because after my graduation, post-graduation, and the doctorate, I joined the sector, pulp and paper sector, and looked into all the problems. Basically, I was a man of polymers, but since I was with the industry, so that industry is now in my blood, and always I think about how we can do that. As a scientist, as a entrepreneur also, we can look into those aspects with the industrialists. So my idea now, which I would like to discuss with you in a very short, and maybe sometimes if we have chance, we would like to discuss it. This is the integration of our pulp and paper industries with the biorefineries. And I visited many countries, particularly in Finland. I was last month I was there, and I visited UPM, one of the largest Finnish pulp and paper producer in the world. So they have started one integrated pulp mill and biorefinery project. And what they are doing right now is they are producing products like which I could discuss with them, and I could see the facilities: monoethylene glycol and biomonopropylene glycol they are producing, and they are still struggling to find the market for these products, because the new concept which pulp and paper industry is going to introduce is not accepted by regular industry professionals. And they are also producing lignin-based renewable functional fillers. Basically, these fillers, after separating lignin from the black liquor, they are modifying it, they are substituting it with some group substitution, and they are using it as a substitute for carbon black and silica in the rubber industry, rubber tire industry. So these type of products are now slowly the industry people, they are thinking about how we can integrate. And the best part is, it's not only integration and development of some chemicals. This will change the scenario of the pulp and paper industry, which when we look very closely, they are operating at a very low profit margins. And with a huge investment, capital investment, if the industry cannot produce, and the gestation period, or which is more than 7 to 8 years, it is not a very good industrial prospect. And that is the reason why we don't have any greenfield projects in India for last 2 decades. I have not seen any greenfield project coming up based on pulp and paper, because putting a huge capital and waiting for 5 to 10 years for coming back to some normalcy, that is not acceptable in the present times, when we are talking about the IT and many other industries. So who would like to invest? But integration of this biorefinery or biochemicals production with the pulp and paper sector, this can totally change the scenario. And that's why we have many options. Like I just jotted down some of the things before coming here. So like we have biomass gasification. That is a very, very common practice which paper industry is doing it right now. We have biomass gasifiers, but we utilize it only for production of the syngas or some other fuels, and use it as a substitute for furnace oil in our lime kiln or in the recovery boiler. So that is the only utilization our industry is looking. That is a piecemeal, very small part of the integration. Then we have black liquor gasification. That also is coming up very well. And in this particular case, we don't separate the lignin, but we pyrolyze the black liquor and generate syngas, which can be used for generation of steam and power for the industry, along with some methanol and ethanol production. That also is one concept which is, but it is not adopted fully. They don't have faith how to go ahead. And this type of things, along with this, we have hemicellulose extraction before the chemical pulping. Generally what we do the chemical pulping with the biomass as such. Either it may be the wood chips or bagasse, wheat straw, or any other agricultural residue. We do the chemical pulping with sodium hydroxide and sodium sulfide. So that is the general way. So what exactly happens? The lignin is dissolved along with some hemicelluloses which are present in the biomass or wood resources. So hemicellulose is degraded, and this degraded hemicellulose generally is of low calorific value, and that's why we convert it into something which is a very useful product, into some degraded products, and then incinerate it in the recovery boilers. So that approach we are propagating among the industry professionals, that you change this approach, separate or extract the hemicellulose and take it for production of some value-added chemicals after hydrolysis and then even extraction and the fermentation. So a lot of different types of products which are possible is acetic acid, furfural, gypsum, calcium sulfate, and ethanol. So this type of products can be produced. Even we have the possibility, Dr. Bhaskar from IIP, we had an interaction when I was with CBPRI, and we used to talk about xylitol, ethanol, butanol, acetone, and even hydrogen, lactic acid, and PHA production from the industry waste or biomasses. So these are some objectives which I would request you to please look into these aspects, and we can, if we have to devise some methodology how we can approach. There, it will be a very, very diverse application, because we have to utilize different resources, different biomass products or waste generated from the industry, and then utilize it in a proper way. And if such a thing works out, I give you a guarantee, there will be many large number of greenfield projects. They will come up if we improve their balance sheet, if we improve their economics, techno-economic feasibility. The total scenario will change. So the point is, I'll not take much time. The point is, if we do this, how we can benefit. This is not only one industry which will be benefited. Basically, this will benefit the whole nation as a part of our activities. So employment generation, first of all, because our industries are located in rural areas, and they provide opportunities to the people coming from the rural background. So they can be then either their skill levels can be improved, they can brought into the income generation levels by introducing them into the production streams. Then the second part is the farmers and those who are the suppliers to the paper industry. Their economics will also be improved. So income generation for the rural masses, that will be one part. Overall, we'll have to change the environmental prospects or our vision about the industry. And biorefineries, if these are integrated with our conventional pulp and paper production, they can reduce the waste generation and greenhouse gas emissions. And particularly, these will be the clean production technologies and practices which will benefit air and water quality. So best part is one community engagement also can be thought about, because we are not talking about this is one industry only or some suppliers and some backward and forward linkages, but this is the involvement of the whole community. That is also possible, and this integration of our biorefineries will give lot of advantages. Of course, there will be some challenges but this is our part which we can look into. And R&D, the last, is going to play the biggest role, because this is the journey for the towards the innovative ideas, and we have to come with that and present it to our industry. So with these words, I will like to thank you again, Dr. Saab, Dr. Best, and all the my fellow friends from the scientific community, and now I am a part of industry, so my industry colleagues also, my friends from the industry, that our petrochemical and biochemical sectors are basically at a crossroad, and this R&D will be the compass for this journey towards the sustainability and prosperity of the industry. So we have to embrace it and think about the solutions. Thank you very much, and I hope we'll march towards the future in a bold way. Thank you very much.
Thank you, Dr. Bipin, for the informative insight into the untapped opportunities in pulp and paper sector. We are surely hopeful, and we assure you that we will follow your guidance and charter out pathways for fruitful collaborations in the near future. With this, I would now like to call upon Dr. Devashish Ghosh, who is currently working. Okay. Before doing that, we would like to have a memento distribution for our chief guest and our guest of honor. I would now like to ask Dr. Singh Bish to felicitate our chief guest with a memento. Yes. Yes. Now I would like to ask Dr. Devashish Ghosh, who is currently working as a principal scientist in CSIR-IIP, to showcase some of his technologies and processes which he has been working upon as part of the Material Research Resources and Efficiency Division in CSIR-IIP. With this, I'm going to hand over.
Yeah, thank you. Good morning, dignitaries, Director Sir, Dr. Thapliyal, meeting after a long time, and we have a solid collaboration with CPPRI so far. And today, as a part of this thing, I think, yes, today, as a part of the celebration of 1 week, one theme, we would like to present MRED's R&D offerings as a celebration of pan-CSIR collaborations. In this presentation, I would like to touch upon 3 parts. One is a process, one is a product, and another thing is a catalyst, which is obviously a biocatalyst. Before starting this thing, this is what the R&D offering, R&D contributions of MRED, that we work with the renewable carbonaceous feedstocks starting from C3, C5, C6, as well as C12. Why I am telling these things? C3 comes from glycerol, which is a biodiesel plant byproduct. C5 and C6 can come from lignocellulosic feedstock. At the same time, C6 can also come from starchy feedstocks. And when we are talking about a C12, which is a waste sugary stream, may be considered as a 1G feedstock also. Converting with this process for material flow and resource efficiency, we also deal with life cycle impact, techno-economic assessment, and even beyond that study up to even environmental, society and governance level. And the product that we will be mostly dealing with, one is microbial single cell oil, that is lipid or fatty oil, and that oil actually works as a feedstock for fuels, oleochemicals, nutraceuticals like that. Products like xylitol through fermentation process, and obviously and fuel entity like ethanol, that is obviously one of our work. In our division, we are already equipped with a plant processing system starting from 500 ml to 500 liter, so that we can diligently actually look into the process, scale up and economics further. Now, before starting this talk mainly, let us look into the journey of CSIR-IIP for bioethanol part. We started working with biomass hydrolysis and saccharification since 2002 during 10th five-year plan in the name of a project you can say CMM 13, where other than IIP along with them NIST, NCL and many other labs were a part of that. At that time, we are in a division called CBD. Then during 11th five-year plan, we moved into another division PES-CBD, where we started working with process know-how development for high temperature ethanol fermentation. And you can see at that very time, the first national biofuel policy came into existence. And then in around 2012, during the 12th five-year plan, we started working with 1G, 2G, and also started exploring 1.5G ethanol process and started connecting with the industries. At the same time, then during 2018, when new national biofuel policy came into existence, and the same MRED, the present our division, came into existence, and we took a challenge at a pan-CSIR level to develop a technology on ethanol costing at a less than 100 rupees per liter. Gradually, we are still working with that. We are working with PSUs, industries, and at present, many CSIR labs, like along with us, NIST, CFTRI, IMMT, all are working together. So with this thing, let us first say the genesis of the pan-CSIR 2G. Actually, why pan-CSIR 2G was formed? It was developed to stop a repetitive laboratory R&D across CSIR and bring all under one umbrella in a pan-CSIR mode. And our idea was to linearize a cradle-to-gate operation at a scale of 0.1 TPD biomass input basis operation. We started working with rice straw and tried to develop and deliver a project in a time-bound manner, and at the same time as a team CSIR. We had certain objectives for these projects. You can see the objectives that our idea was to develop an integrated technology for second generation ethanol with a targeted cost of less than 100 rupees per liter of ethanol without GST. Second is obviously development of a commercializable plug-in unit operations. This is very important because everyone was looking for product ethanol in a fermentation broth, and if he thinks that it's a success, where a fuel commodity which is regulated by the government, we have to understand that there is a huge amount of monetary involvement when an industry will invest. So there are various type of unit operations, various parts of processes, and if we can develop a process in such a way that any part can also be given to an industry for plug-in operations. So that was considered as an objective. And one of the major objective which was also taken to develop an end-to-end process within a time of 12 months. So time-bound operation was the first target for this thing. So this was the entire organization of the Pan CSIR 2G. You can see that almost first time almost 12 CSIR labs participated in this project with a single goal for development. And we divided this operation into 3 parts. One is upstream, downstream, and finally to an integration. In the upstream part, we started from procurement of feed from field to factory gate, then to biomass size reduction, then to pre-treatment, lignin valorization, enzymatic saccharification, sugar stream concentration, yeast cultivation and fermentation, distillation, get-to-get ethanol production at pilot scale. These were the part of the upstream processes where you can see the various labs who did what. Either in collaboration or in single-handedly they handled those unit parts. And in the downstream sector, we started with ecotoxicity. At the same time, wastewater treatment. That was another important aspect, that any industrial process, whatever generated any solid or liquid waste material, those things we just cannot throw to the environment. So all those things also we took care in that part. And finally, we integrated with techno-economic assessment, life cycle impact, process simulation, patent landscaping, FTO analysis, market survey, and DPR development. So this was a process which was supported by CSIR as in FTT mode, and timeline was given only 12 months for that. So before starting this thing, we have actually assessed what could be the basic cost for every unit operation per liter ethanol. And we dealt with all these factors starting from biomass milling, pre-treatment, hydrolysis, concentration, fermentation, distillation, wastewater treatment. So initial costing we found it was coming around 164 rupees nearly per liter of ethanol. And later on, then we set our target, can we bring it down to less than 100 rupees? And for that, we envisage that what we can do. In the part of CSIR-IIP in our head, the fermentation was the major challenge. We were given initial projected cost was 14.5 rupees per liter ethanol, and target was given to bring down the cost less than rupees 6 per liter ethanol. And actually, and thankfully we could achieve that target. We could develop our own yeast, propagated that yeast, recycled that yeast during fermentation for 25 times, and brought down the cost at rupees 3.12 per liter of ethanol. So this was one of the success stories for ethanol project in Pan CSIR 2G ethanol format. The present process is at TRL 5 level, and presently we are working with industries also for further commercialization. Next comes a product that is one of our, brand product we can say, that as Professor Thaplial was saying, that what to do with the hemicellulose part. So this is one of the advantage of an application of hemicellulose where we can achieve fruit gate xylitol. So this process was developed in collaboration with NCL along with us, and we have already developed it at a scale level of TRL 4 and gone to a level up to that we could generate 98% pure xylitol without, and we have already tested its tox profile and everything. So this product is almost market ready. So we are now looking with industry also for further scale up. We have developed the process at a 10 kg biomass processing based and at a fermentation scale of 50 liters, and the process is economically viable. The cost of the xylitol, which is coming nearly around less than 450 rupees per kg, and this particular product is an alternate to the present catalytic process. So we have an advantage over the greenhouse emission for the overall process. And lastly, as I said, that MRED's another offering is a biocatalyst, that is a lacase, which is a lignin, basically lignin degrading enzyme. So this lacase biocatalyst we are developing in for a long time, and it has got a solid some applications in terms of bioremediation for polyaromatic hydrocarbon degradation, delignification for almost we could achieve 20% lignification, dye decolorization, so it is also available for textile industry. So we could achieve more than 95% dye decolorization. And based on the uniqueness of this enzyme or catalyst, you can see the kcat km value or total kcat value, T-half is 110 minutes. It is a production time of 7 to 8 days. It's a fungal biocatalyst, and the yield is quite high. You can see it is almost 100 to 130 international unit per ml, which is definitely can be positioned almost one of the top 5 in this globe. So with this, thank you. I'm just closing this talk. For any further query, we can contact KDMRED, the proper channel. Thank you very much.
Now I'd like to call upon Mr. Sanjay from Indian Glycols Limited to share some of his thoughts.
Good morning, friends. I really apologize. Our R&D head, Mr. BP Joshi, is not able to join this meeting, and he really apologized for the same. I am not from the R&D background, but I have got the opportunity to work with global R&D teams across the various industries. Basis of my experience while working with them, I foresee few challenges in R&Ds from commercial point of views, not from the technical point of views. I can see it's into two parts. What is internal constant? Second is external constants. In internal constants, I think you might be saying, industry might be facing because allocation of funds, availability of materials, because if you are working on the new projects, you find it's not coming in a time manner. And when materials come, you have to meet the timelines. And within time frame, you have to deliver. That is also one of the challenges R&D people face. Apart from this, I think sometimes budgetary constraint is also there by the companies. They do not allocate the sufficient fund for R&Ds. Sometimes, even if the fund is allocated, we find the instruments what we needed that is lacking, and we have to go for third-party labs or to do it. That delays the process of achieving the timelines. So this is the general broad guideline I see in the R&D challenges. Apart from this, there are many more. You are must be aware of it. But working with the global R&D teams, I find two external factors which is coming or which will going to change the R&D way of working. First is the sustainabilities. And as you know, the United Nations sustainability goals, they have identified a lot of goals. And every company are aligning themselves how to achieve that. And luckily, our IGL team, they are already coming, all the using sources which is coming from sustainable sources, whether it's bio-EO, and lot of things are coming up in the coming time, which will come through the various medias and all. But what I see that the change in climate patterns, if we will not focus our approach on sustainabilities, our survival on this planet is very doubtful. So many of the European company you see or the US company you see, go to their website and see how they are much aligned to the sustainabilities. I think we should also learn from it and try to implement as quickly as possible, so that if we will not do, The stringent environment norms will force us to invest heavily on our facility to change it. And if we start the journey early, we'll be much more easily we'll be able to do it and make our suitable for the upcoming changes. The second thing what I see, artificial intelligence is going to play a very vital role in the way of how we work. And many of these big MNCs company you see, they are using this artificial intelligence technologies in their R&Ds as well. So my thought process is, if we learn from them, we implement such type of things, we will also have the advantage on making par with the global. Otherwise, we will lag behind. And thirdly, what I see that whatever we do, data is one of the important things in the coming time. So this data will help you to analyze where you are making mistakes. You make your system very much efficient and effective. So also think R&D from that perspective as well. So apart from this, I really apologize. I will not say any more because you are much more technically sounds on this. But from commercial point of view, what I thought, these are some of the things, upcoming trends we need to align before the times comes. So this is only short I can say to. So thanks in Institute of Petroleum to give me this opportunities. And I really apologize, but upcoming platform, I definitely like my R&D team head should come here and share their views on these aspects. So thank you.
I would like to call upon our chief guest to give a memento to Mr. Shankar, Mr. Sanjay from Indian Glycols. Before proceeding, just a general information due to some time constraint. I would request all the speakers to limit their in-house speakers to limit their speech to not more beyond 6-7 minutes, and for external speakers, I would humbly request them to, if possible, it's to wrap up within 12-13 minutes. So, just due to time constraint. Now I'd like to call upon Dr. Paresh Dhepe from CSIR NCL for his talk.
Right, so maybe okay. So good morning all. I am Dr. Paresh Dave from NCL Pune. I have not put my name anywhere over here because I thought maybe the time is very short, and plus I don't know whether I should consider as a CSR internal speaker or external speaker. But still I will take a liberty of considering myself as an internal speaker because I'm CSR. I hope I am audible to everybody at last. So good morning, Professor Bish, and our chief guest, Dr. Tharipal, for inviting me over here and giving the opportunity to represent some of the work which we are doing at CSIR-IIP. And also good morning to all of my friends from CSIR-IIP. So what I have done is I have prepared only 4 slides, not going to take much time, and I'm not going to go into the details of any of my work or the NCL work. I'm just going to give you the glances. And of course, many of you are already knowing that what we do at NCL. Just to start with, the first is the biomass acceleration at CSIR National Chemical Laboratory in Pune. That's okay, I think I have already. Okay. Biomass acceleration at CSIR National Chemical Laboratory Pune. So what we do in biomass acceleration is isolation and extraction. So as it was mentioned earlier by chief guest, that we have to work with biomass. The biorefineries has to be integrated with the paper and pulp industries, or maybe even with 2G ethanol processes which are coming up on a large scale in India. So what we do is we do green catalytic processes for isolation of cellulose, hemicellulose, and lignin from lignocellulosic materials. Then we also do Classen method, we also do H2O2 based method, we also do alkaline method, we also do acid pretreatments and all, just to separate out all these and then try to understand what kind of products which we get and compare those with each other. Because what happens normally, industries will work with only one pretreatment process. For instance, if it is a alkali pretreatment or if it is a craft process like Na2S or NaOH, then they may not be knowing what exactly the another process is doing and how it compares the purity of the cellulose, hemicellulose, and lignin. So what we do is we kind of compare the properties. Then also we do cellulose chemistry. So in cellulose chemistry, what we do, I'm just giving the examples of the chemicals which we are working on. Of course, these are done mostly with catalytic processes, but also with biochemical processes. So for instance, in chemicals, we do glucose, we do 5-hydroxymethylfurfural, we do FDCA, furan dicarboxylic acid, we do glycols like propylene glycol, ethylene glycol, we do levulinic acid synthesis, gluconic acid synthesis, you name, and we are doing. And of course, most of the oil marketing companies are also aware of this, like Dr. Bharat Nevalkar is very well aware of the work which we are doing in cellulose or hemicellulose or lignin chemistry. So these are just examples, and of course I have not given any conversions, yield, reaction conditions and all. So if anybody of you are interested in knowing those, maybe we can discuss in detail about those. Then in materials, we also do microcrystalline cellulose and nanocellulose synthesis from a cellulose which we get from kind of isolated from lignocellulosic materials. Then in a hemicellulose chemistry, of course, we work on chemicals like xylose, furfural, furfuryl alcohol, cyclopentanone, pentanol, then furoic acid, xylitol, furfuryl ether and all. Of course, the earlier speaker, Dr. Ghosh, mentioned about xylitol synthesis by biochemical route, and then there was a mission mode project few years back, which was a mission mode CSD. In that, IIP was working on, along with NCL, was working on xylitol production by biochemical routes, and we were working on kinetic route also. Then of course we are also working on lignin chemistry, as chief guest was mentioning that lignin is very much essential to be valorized, and we are working in lignin chemistry for last almost 15 years. In my group, we started working on lignin valorization from 2009 2010, and then since then we have completed successfully many of the industry projects on lignin valorization. Of course, the demands for every industry would be different, whether they want this product or that product, and we are working on, and currently also we are working on an industry project on lignin chemistry. So here what we do is we try to get phenolics, like you know that maybe to get only one single aromatic compound from lignin is very much difficult. It is impossible almost, because it is a mixture of many chemicals. And then we get phenolics, and we also are working on functionalization, defunctionalization of this lignin into hydrocarbons. Then we are also working on materials like, for instance, resins and polymers, as chief guest was mentioning that we have to work on fillers or something like that to make lignin valorization. So that also we are working on. So we are having a lot of expertise on these three or four topics of isolation, cellulose, hemicellulose, and lignin chemistry. And of course, recently for last 5 years, we are also started working on chitin chitosan chemistry, which is the animal derived or marine biomass. So what we are doing is we are trying to get chemicals out of it, which are nitrogen containing chemicals. You know that fixation of nitrogen in any chemical is very difficult if it is coming from fossil feedstock. But you have a nitrogen containing polysaccharide in the form of chitin chitosan, and then maybe we can use those, and that is what we are doing. And also in materials, we are nitrogen containing carbons we are synthesizing, which are essentially used as a support, or maybe in the fuel cell technology and all, wherever there is a transfer of electrons is required, the nitrogen doping is very much essential. And then we are making use of this chitin chitosan, which actually always contains nitrogen in it. We are trying to make use of that nitrogen and make chemicals out of it. Then of course these are all IP protected methods, a one-stop solution for catalytic and biochemical pathways for valorization of biomass at NCL, then homogeneous heterogeneous catalysis, and we are working on batch mode for biomass valorization from 50 ml to almost 20 liter reactors we have, and then in a flow reactor system from 0.1, 0.2 gram to almost 20 gram. Now to move forward, just I will give a brief on fossil feedstock work which we do at NCL. So we are working on reforming reactions. So you can consider it as a CH4 and CO2 platform. Like earlier it was a lignocellulosic and marine biomass. Here it is a CH4 reforming. We are into dry, steam reforming and all. to get CO plus hydrogen syngas mixture essentially in various ratios so that you can make various chemicals out of it. We are also into biogas upgradation. Once you have a CO2 plus methane, how to do the upgradation of that biogas. We are partnering with local industries who are making this biogas and then do the adjustment of CO and hydrogen ratio. Then we are also working on methane pyrolysis so that you can get hydrogen. Of course, nowadays everybody wants hydrogen as a source, or hydrogen has to be prepared, a green process for hydrogen production, and we are working on methane pyrolysis to get hydrogen. Then we are also working on oxidative coupling of methane, which essentially gives you higher oxygenates. And of course, DME is well-known story of NCL. We have now partnered with IOCL to take it further. And then, of course, in that domain, we are into methanol synthesis and also DME production. So it has gone into a very high level. And then this is a success of last mission mode project of CSIR. Of course, here also we have IP protected methods, recyclable heterogeneous catalyst, and also continuous reactors from 0.1 to 100 gram scale. Just to give you a glance on, again, a slide on biomass competencies, we work on complete array of basic and applied research areas, research based on the industry requirement and techno-economics. So we partner with the industries, we try to understand what they want. Of course, we have done some work on our own earlier, proof of concept is there, but then to develop it further, we work with the industries, try to understand their requirements and manipulate our deliverables, objectives, and reaction conditions accordingly. So we do understanding of complete analysis of lignocellulosic material by TAPI, ICP methods to understand what are the composition, what are the characteristics of those components which are isolated. We also do the extraction, as I have mentioned already, then characterization of all the compounds by different methods. I will not name those, you can read those over here. Then catalyst designing of and scale up of the catalyst for liquid phase. So as I said that we are already working with industries and we have gone up to 20-liter reactors in a batch mode at NCL, and then successfully we are showing the demonstration to the industries. And of course in the reactors we are working in batch mode, FBR, micro reactors and all. And this is my last slide. This is just an overall view of what we do in biomass. It is essentially the same which was mentioned on the first slide, but in a bit graphical way, just to attract your attention that okay, you have the biomass, you have cellulose, lignin, hemicellulose, and then how you can do whole of the chemistry. And on the right side, you can see that there is a biorefinery concept, and then the xylitol crystals which are isolated at NCL using our process, catalytic process, which has a 99% purity. And then you can also see the crystals of furic acid. Then you can see the crude HMF. Of course, we are doing crude HMF oxidation to FDCA because crude HMF to isolated or purified HMF requires lot of skills, and it is energy intensive and economically intensive process. So we are kind of trying to use the crude substrate, crude HMF itself to get FDCA in a good yield, and we could achieve almost 97-98% of yield. And you can see also the FDCA crystals over there. And then we have a very unique facility in CSIR, which is a 2D LC-MSMS. So you might have heard about the LC-MSMS, but then this is a two-dimensional LC-MSMS. If somebody is interested, I will explain to you in more detail what is that facility and why it is very important to use. And within CSIR only, this is one of the facility which we have. And this is what we are doing. You can just glance through. This is essentially the same which I have talked about on the first slide. So that's all from my side. Thank you very much. And if you have any interest, then maybe we can discuss about it during tea time, during lunch time. I am here until tomorrow morning. Thank you very much.
Thank you, sir. I would now like to call upon Director IIP to felicitate Dr. Paresh with a memento. With this, I would now like to call upon Dr. Bhupesh Samant, who is General Manager, Research and Development, Godrej Chemicals, for his talk.
Shall I put my
Yes.
expecting. Good morning, all. So myself is Dr. Pupesh from Godrej R&D. So first of all, I really like the way this program is started. The time is the important. Exactly 9:30 it started, and I really appreciate that. I also appreciate the way our chief guest addressed us all. We all are scientists. That the way he addressed us, and science and technology is a stream which binding us together. So I really appreciate the thoughts and whatever new ideas are generated on this platform. I'm not going to here tell you about products or anything. What we are doing. I'm going to present it. But the main important thing what I want from CSIR is people that you are cultivating over here in the form of MScs, MTech or PhDs. We want as a industries, Indian industries, we want these people to work with us, to give us new ideas and to give us new technologies. So to start with, our director has given the from crude oil to chemicals. I'm going to talk about from vegetable oils to chemicals. And Godrej is working on oleochemicals. These oleochemicals we derive from vegetable oils. So what are oleochemicals? We all know about oleochemicals. These chemicals derive from plant and animal fats. But Godrej is something which is very special, which gave India to come up with oleochemicals only on the basis of vegetable fat, not using the animal fat. And the common resources are as given palm oil, soybean oil, coconut oil, you name it. We have this all in our India, fertilized in our soil. Then this method of extraction from these oleochemicals is mechanical pressing, cold pressing, expeller pressing, and solvent extraction. Ultimately, we are using solvent over here, but we can recover these solvents and we can reuse this solvent, and we also repurpose these solvents. This is very important with respect to green chemistry, and that what our motto and our aim are. So then refining vegetable oils, we do these all processes like degumming, naturalization by free acid removals, then bleaching to get our desired specification of odor and color, and also the deodorization for the final product in the form of our oleochemicals. These processes are also involve some chemical processes such as hydrolysis, which is the conversion of fatty acids and glycerols. Also the transesterification, which is very common and very old processes, but which is renewed with our science and technology by using different catalysis. We also use enzymatic catalysis processes for this transesterification reactions. And also the hydrogenations. With pressure, with catalyst, we increase the yield efficiency of these hydrogenation processes to get to our products. So these are our key products. What we get from our oleochemicals is that fatty acids, fatty alcohols, glycerols, methyl esters. And where we use this? We use this all in all these sectors. We have some, customer also sitting over here, IOCL, BPCL. We use this in oil and gas. We use this in consumer products such as soaps, paints, coatings. The simple example is whatever wires we are preparing, and for that wire coating also, these fatty acids, fatty alcohols we use. We also use this in paper and pulp for polishing paper to get the final product of the paper, which is the smoothness, and that, that feeling what we get is that from the coating of that fatty acids. Also in food and beverages, all biscuits, all those cakes which getting the coats, gems, what we get, that coating of colors, different colors that we get from the fatty alcohols, fatty acids. New technologies such as electric vehicles, they use these batteries. So phase changing material is none other than fatty alcohols. So these new technologies are also involved, these all chemicals, which are oleochemicals, the plant-based chemicals, and old technologies also, which we are using for the years and years. They are also involving these fatty alcohols and fatty acids. So benefits of these oleochemicals, we all know, these are renewable resources, this is biodegradability, and carbon footprints are minimum. But there are challenges also. And that for those challenges only we need people, we need new thinking, out of the box thinking in the form of people. So of course market competition is always there, it will be there, and that's what gives us, anxiety to move forward. And technology advancement is of course that we are going ahead as India, as a country, as a competitor for all other developed countries. And innovation trends, yes, green chemistry, biorefineries, and advanced material, what I will say, we have all experts sitting over here who already talked, and we will going to talk today regarding this, new applications of bioplastics and nanotechnology. We also have, I think, nanotechnology center over here, and we also have several centers in India. So in summary, oleochemicals are versatile, sustainable resource and derived from variety of vegetable oils. A wide range of application, you name it, and in that sector we are there. And we're going to continue this all research in our world-class R&D center. Whatever photographs I have, showed is live photos that we developed in Mumbai, our R&D research center. So we do our research in vicinity of Mumbai. There is a Ambernath. There is a very big R&D center that we have developed, and we are working over there. So really thank you for invitation and to share my thoughts and ideas with you all. I'm available, so please do connect with me. After this event also, I'm available online, so please do connect and we'll be in touch. Thank you.
Thank you, Dr. Bhupesh. Now I'd like to again call upon our director to hand over a memento. इसके साथ है ना? Now I'd like to call upon Dr. Ishwara Murthy, Principal Scientist CLRI from CSIR-IIP to give his talk. Thanks.
Good morning. So first of all, thanks to CSIR-IIP for giving me this opportunity. So I would like to briefly go through what CSIR-CLRI is doing on the chemicals. Before that, this talk may be a little bit different from what we have heard, because for many of the audience, what is the role of chemistry in leather processing may be the new thing. So I'm just going to highlight those things. So for example, in the case in CLRI, so we have so many chemistry-based divisions are there, starting from the inorganic and physical, organic, and polymer, and so on. And our expertise is not only on the preparing and doing work on the leather chemicals, so and also we are working on the stimuli responsive materials, nanozymes and optoelectronic materials, and so on. So we are having the research group on the synthetic organic chemistry as well, and the peptide chemistry and the collagen chemistry. So that is the most important thing for our CLRI. And the next thing is I just going to highlight what are the processes that has been involved in the leather processing. So this will give you an understanding that why so much effort is required for in terms of chemicals for leather processing. So briefly it could be divided into three parts. So one is the raw materials, so that what we call it as the hides and skins, which is collected from the animal husbandry. And in India, it is mostly an unorganized sector, so it has been collected in the very remote places. And this being a biomaterial, so it tend to decompose it in a short time. So it has to be preserved, and it has to be taken into the tanning industry. So where the rest of the process starts. So that is, that is actually the production starts once that putrefiable natural material has been converted into a stable material, and it goes to the next step where the fashion and other things are involved. The production of, for example, if it is the material is going for the bag, or it is material is going for the shoe, and so on. So all these processes are taking place. So here, if you could see that there are so many processes have been highlighted, and those though we can be classified into the pre-tanning, post-tanning, and finishing operations, the processes are so intricate. The intricacies in the process is in that, for example, the first process is happening in that the pH, let us say that it is a 12. The next process that should be happening in the pH of 3 or 4. So ultimately, the entire pH has to be brought down, so it requires large amount of the acids and bases and salts. So that eventually reduces, increases the amount of the salt, and that has been also recovered, and so that requires an intensive usage of chemicals in the leather process. So here in CSIR, CLRI, so the technologies that has been developed can be grouped into these categories. So the leather processing technologies, so we work on what are the processes, what are the modifications that could involve the leather manufacturer in most efficient, and the leather chemicals with some new added features. And many of you may be knowing that most of the leather that has been manufactured in India is exported to the European countries, and so where the regulations are so stringent that even a trace amount of a particular chemicals will be made them to reject the entire lot, so it will be incurring the financial losses. So for that, we continuously work on the leather chemicals, and leather industry generate a large amount of waste. For example, for the 1 ton manufacture of leather, it's almost like 600 kgs of solid waste has been generated. So that is one of the biggest concern. And the leather product technologies, so because these are fashion driven, so always the new fashions and other things are coming up. So we are also having people who work on the leather product technologies. And the last thing is the healthcare products, because the collagen is a biomaterial, so which is a skin alternative. So we work on extracting the collagen based material, and that has been developed as a wound healing materials, for example in the case of the fire accident and other things. So this could be our healthcare products are already in the market. So with this, I'm going to highlight some of the technologies that has been already commercialized. For example, the chrome melamine syntan. The problem with the syntan is actually the synthetic tanning agent. Okay, so most of the syntans which is having the formaldehyde has been banned by the REACH norms, that is the European Union regulation norms. So where is it restricts the usage of certain chemicals. So that list is actually the dynamics. So year over year the new chemicals are added. So here we have developed chrome melamine syntans where there is no formaldehyde at all. So and this, whatever the syntax that we are using is, it should not be spoiling the natural material, it should not be spoiling the natural material. At the same time, so it gives the aesthetics feelings, what we call it as an organoleptic properties, the touch and feel. So all those things need to be need to be taken care. So this of course has been commercialized technology, and this is one of the successful product in the market. And other one is the protein based syntax. As I said, that leather industry develops a large amount of solid waste. For example, if you are taking the skin, it's a natural material, so it obviously have some damages, so that cannot be overcome. So those things need to be removed to make the product. So those are again generated as a solid waste. So that could be again hydrolyzed, and the protein hydrolyzed can be used, subjected to some process, and can be reused as a synthetic tanning agent, so that we can reduce the amount of solid waste generated in this process. And this is the one we have recently started working on. So since morning, so we have been hearing so many good stories in the lignin, so we are also working. So in this case, what we did is that we just took the black liquor from the CSIR-IIP paper mills from Europe, so and we converted that into a material synthetic synthetic tanning agent. So that has been used as a retanning agents. So that means that the leather, as I said, it's a natural material, it is not uniform throughout the materials. So after the tanning, sometimes again further one more tanning is required, so that is what we call it as a retanning. So it imparts, the product is actually free from the formaldehyde, and it imparts excellent softy touch and wet feel of the leather, and it is smooth and fine grain. And we also gone to the next step, whether the lignin, being an aromatics, could be functionalized further and used as a dyes or pigments for the leather industry. So for that, we just took a proof of concept example of the simple diazotizations. So the lignin fragment has been converted into the dye. So we could see that the azo-lignin, azo-derivatized lignin, has a very good penetration depth, and the most important thing is that it is highly photostable. So even we just kept the dye for the whole day under the xenon lamp, 150 watt xenon lamp, so we didn't see any degradation at all. So that's one out of the advantage of this dyes. And of course, still we are continuing this journey through the lignin and in partnership with IIP Dehradun. So there is one focused basic research project that is going on. And these are some of the technologies that has been already been validated at the pilot scale level, and it has been available for anyone to take up. And with that, I thank you for the opportunity. Thank you very much.
Thank you, sir. I would now like to call Dr. Senthil, but before that, sir, just please a minute. I would like to call Dr. Bharat Nevalkar from BPCL to present amendment to Dr. Ishwara Murthy from CLI. Now we have with us Dr. Senthil from CSIR-IIP. He will be giving his talk on eco-friendly color-shaped microbial proteining.
Thank you, audience. Just search. So this is back. Yeah. So good morning, sir. And myself, Senthil Prashad. I'm from CSIR-IIP Institute of Microbial Technology. So we work on the microbial biotechnology related area. Today I'm going to share in this industry meet the technology which we have developed in our lab, the eco-friendly color-shift microbial protein ink. And before that, I would like to thank all the organizing team members of CSIR-IIP and director sir and Umesh, everyone. So for their fantastic hospitality and making us be very pleasant here. And so before that, our institute is located in Chandigarh, sector 39A, and it was established in 1984. So the scientists here, we works on the basic and applied science on the different research area like molecular biology, recombinant cloning, expression, protein production, increasing the titer of the proteins, and molecular genetics like taxonomy, microbial taxonomy screening, and cell biology and immunology, some of the vaccines like mRNA vaccines, etc. And our department is on like the fermentation technology and applied microbiology, and we have other departments like bioinformatics, MTCC, and animal house facility. So our research groups works on prebiotics and sweeteners and color shift ink, which I am going to talk about today, and recombinant proteins like COVID. In past, we had a recombinant proteins production project, so we worked on these recombinant proteins, and apart from that, we work on industrial enzymes. So if you look into the optical variable ink, like most of these optical variable ink is used in the the banknotes, high security documents. This optical variable ink has a market $88 billion in 2023, and it moves up to the shooted up to $168 billion with a growth rate of 9.7. So these are the players: DIC, CIPA, and Glitzman Security. There are different forms of the optical variable inks. One is red to green, green to blue, and sometimes a gold and silver foils will be there. So if you see the data from the RBI, Indian government, the color shift requirement in India for the high denomination currency notes is around 24,000 kg, whereas for the low denomination currency notes, it is for 4,600 kg. But there is no indigenous technology available for the optical variable ink. So we have developed in our lab a microbial eco-friendly based ink. So these are the website. This is mentioned in the RBI website. This Reserve Bank website. You can see some of the suppliers of the optically variable ink. DIC. Is it on? So some of the color shift ink like DIC, the players who manufactures this ink, DIC, Glitzman, Luminescence, these are all imported manufacturers. If you see some of the Indian companies, they used to get the raw material and make the formulation, and they'll supply as per the agreement with the RBI. So there is no indigenous technology development here. So if you see the writing inks, printing inks, if you see the composition, that you see the carbon footprint 80%, right? So we wanted to make a eco-friendly process. So if you look at the currency notes, the printing ink is imported from CIPA. The paper which is imported, the cotton currency paper 100%, and printing machine is by intaglio printing. So these three technology we wanted to make some imprint, or that means we wanted to develop the technology on that. So ink, currency paper is changed, and the printing methodology has been changed. So if you look into the color shift ink present in the currency note, you can see the different features here. There are 18 security features. The first one is a watermark, second one is a latent image, and third is your denomination number in Devanagari, and the most important is 10th, this denomination, optical variable ink, which moves from green to blue. So if you see the Department of Currency Management rules, so the high quality counterfeit Indian currency offense rules says that as per the rules of UAP, so if you make any illegal kind of thing, it comes under the the different laws and different guidelines. So what we have developed in our lab is eco-friendly microbial protein ink we developed. So this is having the reversible character, the purple to yellow and yellow to purple. So purple to yellow is under the light illumination, and again from the yellow to the purple is without any light illumination. And also it's a temperature stable film, easy to scale up, and you don't require any reader machines. So the one such bacteria is a halobacteria which lives in solar solvents. We extracted this protein and we made the formulation, and these are the production, how we did the production from this bioreactor. And these are the steps we have used to produce and purify this bacteriorhodopsin. And this is a characteristic feature of this protein solution. And if you see that the light on the right hand side and left hand side, one is the light sensitive protein solution, another one is a reference strain. The formulation which we made, within a few seconds it changes the color with the light, even the mobile phone flashlight, and if you switch off the light it comes back to the original color within few seconds, and also it's a reversible. Again, we proved from the solution to the filter paper, like thin films. IMTECH, the IMT is quoted based on your the formulation which you made, and ECH is made up of the wild type, the reference strain, reference protein. So you can see the flash of the light which changes the color from the earlier color to the yellow, and yellow to the original color. Same with the films we demonstrated. So the identification is by either by sunlight. This is a protein loaded into the membrane and we laminated it. So it's a lamination resistant process, and we using the green laser pointers as well as torchlight is a only source for the identification. Don't require any readers. So and using the filters also we made some technology in that. And as you know that in the recent pandemic, so Confederation of all Indian traders, they suggested to the Health and Finance Ministry saying that to convert the plastic, that means a cotton currency, into the plastic currency notes for the easy for the sanitization, and also you cannot imitate it properly. So we developed a polymer based currency note where these three technology has been changed. It's a biodegradable protein, printing method, and reversible color shift. So making the eco-friendly. So the three companies shown interest in this technology. Those are suppliers to the RBI, Government of India, and we demonstrated at the different platform, and also in the Bangalore Tech Summit, as well as in that. These are the different forms, like stamp paper where the protein has been coated here, and other films like plastic currency notes. So this is another way, like we made from the orange peel. Again, it's from the biomass based, a small molecule, the quantum dots. So this is a blue emitted quantum dots, and we are making from the bio. You can see the currency notes here. The threads. These are also we are planning to make it in the bio based green methodology. So again, we are working on the dyes, pigments to make this formulation and make for the ink formulation for the anti-counterfeiting applications. So these are our publications. Yeah, these are the company industry collaborators. Yeah. So thank you. We would like to show one video. Right. So these are polymer currency notes. See the color change. In few seconds it changes the color. Like a normal color, reversible. Same with the other films.
Now it is good. This is in the dark.
In the sunlight.
Slowly, yeah, slowly you move it. Wow. So under the sunlight, it is colorless. So in the dark,
Again it comes back to the non-illuminated.
you can go back.
It's a reversible color shift.
Half.
And it is a eco-friendly microbial protein.
Yeah, come back.
Thank you. Thanks.
Thank you, Dr. Senthil. I would now finally again ask Dr. Bipin to present a memento to Dr. Senthil for his talk. With this, we are concluding the opening session, and I would like to invite you all for a short tea break in our downstairs dining hall, and we will again resume with the post tea session at 12 o'clock sharp. Thank you. the range of middle distillates. And we have a very group, the type of service that we provide in terms of consultancy or project work extends from from process conceptualization and development, proof of concept studies, okay, and development of technology information package, and support for development of basic engineering design package. We have a number of clients to our list of accolades, starting all right from BPCL, IOCL, HPCL, Reliance, and recently we have also been working with ONGC and we are looking forward to a successful implementation of one of our helium-based technologies. Now, these are some of the major works which we have worked recently and which we have taken up to the level of commercialization. So most of these have been covered up. This is the EIP, CSIR-IIP, EIL, NRL, Numaligarh Refinery Limited, wax deoiling technology, okay, for production of paraffin grade wax from vacuum gas oil. Okay, so it was commercialized in Numaligarh Refinery Limited and has been successfully running since this commission, and it is already on a technology readiness level of 9, and it is ready for commercialization in any other industry as well. And it has a huge market potential of around 0.1 million metric tons of waxes are being imported across the country. So it is basically a kind of import substitution technology. Okay. And it has also a huge market potential abroad as well. And it is a tentative capex and opex requirement for a typical 50,000 tons per annum production plant is around 1,000 crores, and the opex is around 5,000 tons 5,000 rupees per ton of feed. And this is another one of the technology which we have recently commercialized in Reliance Jamnagar refinery. This is for the upgradation of the FCC naphtha by recovery of benzene as well as high production of benzene lean gasoline. As you all must be aware of, a typical FCC naphtha obtained from an FCC cracker comprises of around 20 to 30% of the gasoline pool. So by taking out the benzene, we are effectively reducing the amount of benzene in the overall gasoline that is being produced in the refinery. So, and this gasoline is obviously, India has a benzene limit of at less than 1%, but in abroad foreign countries, the limit is far more strict and it is stringent to the level of 0.6%. So this gasoline that we are producing using this technology which is being produced is easily marketable for abroad countries, and we are also not pushing it for other Indian refineries to adopt this technology. It is a very good technology and it is a very state-of-the-art technology, because none of the existing technologies for solvent extraction based processes worldwide processes FCC naphtha, which is a very cumbersome feat, if you want to say. And this is another one that we have recently worked with ONGC Energy Technology Center for the recovery of high purity helium from natural gas. The natural gas comprises of helium around 0.4%, 0.04 to 0.1% by volume. But in order to purify that amount, we have developed an integrated cryogenic distillation followed by a vacuum stream adsorption process, by which we are able to recover almost 99% pure helium, and to a very good extent, and the 99.95 in order to say, because that is the market specs for the high purity helium which is required. And apart from that, the process modeling and simulation group has a very strong expertise in pinch analysis. So we have been extensively doing this work for several refineries in India since a very long time. Basically, pinch technology and pinch analysis is basically the study for process integration for minimization of heat and utility requirements. In a typical refinery, or it can be not only a refinery, we are also now looking for pulp and paper industries as well. We have been in talks with them, sugar industries, any chemical based process units. It can be integrated, okay, so as to minimize the utility requirement. So we have already worked on several major projects, 10 to 15 projects which have been actually implemented in refineries, okay. And the softwares that we generally use are for simulation, and we have an Aspen industrial license, as well as we also do some basic numerical modeling through COMSOL, okay. And many of our clients include the CPCL, HPCL, IOCL, as well as BPCL. Okay, the type of process units which we are able to analyze are mainly extends from crude trains, solvent extraction units, lube oil refining, petroleum wax, pulp and paper, sugar, as well as chemical and any other chemical industries. And this is another one from our lube extraction group. This is for the re-refining and the color stabilization of spent lube oils. This process basically is for production of Group 1 and Group 2 lube-based oil in lighter, inter, and heavy oil range. It has already been patented and it is on a TRL level 3. And if there is a suitable client, we can also take it up to that level of commercialization in plant as well. Okay. It also has a huge market potential, and the end users would be spent lube oil refiners. So this was a very brief overview, and there are other major projects also which we are working on in separation process division. So actually it is basically a group of chemical engineers and chemists who take the directly, we are more focused on the industrial implementation rather than on only lab-based paperwork and everything. So with this, I would like to ask our next speaker, Mr. Manish Kothari from CEO, who is the CEO from Flochem Pharmaceuticals, for his talk. Sir, email ID है शायद
So first of all, heartiest congratulations to CSIR and CSIR-IIP Dehradun for this nice coffee making session. Why is it coffee making? Is because actually we are working like, a milk, sugar and coffee in a cup, and nobody doing the stirring part. And I think today what we are trying to do is make a nice coffee, brew a coffee by doing the stirring, where you have industries and you have the researchers, scientists, and also the people from various dignitaries. So first of all, yeah, my heartiest congratulations to all the dignitaries of CSIR, CSIR-IIP for hosting a very pertinent industry meet. And I love this, and it's always my pleasure to be at IIP Dehradun. I've been associated with IIP Dehradun for now 6 years. And also it's always a very enriching experience. When I go back home, I take so many things from here, but then what I get stuck is not a starting point, or I feel what about the seed fund, what about the time, and what about the viability, feasibility, scalability, whether the process is perfected, whether I can be more competitive. So I think we were just talking that we should have the next session with industry to only address what are the concerns for these technologies and this high level research to go to market. I think the go to market is the most important thing, and that also will motivate all my friends who are sitting back. Good afternoon, friends. Good afternoon. You can see how much the energy we have. So I think it's important that we go to market with this kind of high level work. And as an industry, we are definitely looking forward to collaborate in every possible way. Yeah. And we are with CSIR to help you in taking your technologies into the market. The topic that was given to me, or I chose rather, was petrochemicals in pharmaceuticals and beyond. So pharmaceuticals, you probably must be thinking what pharma has to do in petrochemical, but I'll give you some little fact that pharmaceuticals represent only 3% of petrochemicals use. However, 99% of pharmaceuticals, they use petrochemical. So which clearly shows that petrochemical is a backbone of pharmaceutical market, which is close to 65 billion for India and 1,155 billion globally.
and when you see 99% of this market, they require petrochemical, then you can imagine what is the scale and size that you're talking. Of course, we are not as large as an industry compared to other industries, but also not a size that we can disregard or a size which we should overlook with respect to what problems and what solutions and how value addition can happen in this pharmaceutical industry. We all, probably myself and also you all, are seeing a paradigm shift in pharmaceuticals over last few years, not only pertaining to biologics, biosimilars, or adoption of green process technologies, but also in all around development of novel materials. Yeah, I think what is coming up in pharmaceuticals is the novel materials that are getting developed, that are going and sitting in the final dosage forms. Yeah. Particularly stable isotope labeled compounds, drug impregnated carbon nanotubes for targeted drug delivery systems, biocatalyst, use of novel excipients, etc. The list is long, but you can see we keep hearing about novel chemicals, novel materials being used in pharmaceuticals and healthcare as a whole. I like to address the most emerging science in pharma that's coming up is a stable isotope science. It's not a new science. This was probably that is prevalent from 1964, and but it's now getting approved. It's now being more visible. So what is isotope? We all know. And we also know what is deuterium, which is an isotope of hydrogen. And this is a naturally occurring isotope. It is twice heavier compared to hydrogen due to an additional neutron. It gives twice the stronger bond with carbon. It shows altered chemical properties. It is a dual purpose material and thus comes with a lot of regulations and controls from Department of Atomic Energy. India is the largest producer of deuterium. Now, this was something which probably we didn't know or we were not unaware, but I want to say that we are the largest producers in the world, the deuterium oxide, and we have 5 manufacturing plants across India with a combined capacity of 600 tons of deuterium oxide getting manufactured year after year, and we have enormous stock of deuterium oxide lying with us, and we don't know what to do. Not getting too much into that area, which is I'm not supposed to talk, but the area clearly is how do we use this deuterium, how do we substitute hydrogen with deuterium, how do we make materials which are not only novel but they are also more functionally or high performing materials, and where does it come from, why do we make, because it's primarily a coolant that is used in nuclear reactors. Having said that, we stick to the topic that is pharmaceuticals, and we see that the hydrogen, when replaced with deuterium, gives higher metabolic stability. Yeah, so it's very simple science because of its capability to be capability of being twice more stronger with carbon. It's more a stronger bond, and thus it's more metabolically stable. It improves the bioavailability and thus reduces significantly the drug dosing. Yeah, this is where we are coming from. When we use deuterium correctly into the drug fragment, basically we are trying to strengthen the bond with carbon, and that bond, because it is more stronger, it's more metabolically stable, and that improves the bioavailability and efficacy of the drug. Yeah, the science is simple. What industry requires is different ways of incorporating deuterium using the innovative technologies and innovative processes. It also eliminates formation of inactive or toxic metabolites. In most cases, it reduces the drug clearance, which means it improves the half-life of the drug, obviously because it's more available in the plasma and the clearance is slow, so it improves the half-life. As of now, there are 2 novel drugs that are already approved and are available in the market. And there are 18 plus drugs which are undergoing advanced clinical investigation. I've not mentioned here, but to what I understand, 20,000 drugs are under preclinical, where they're trying to use deuterium in some way. So this is obviously we are heading towards the new wave in pharmaceuticals where we'll see more and more drugs coming. We'll have isotopes labeled onto it. Some of the common starting materials which has deuterium into it are methanol D4. We are already doing a project with sir, your institute, and where we are still interested to scale it up. Benzene D6, toluene, ethanol. These are the common materials where these are building blocks. These are starting materials. If we can incorporate deuterium into these materials, and if we can scale this up to not as high as what industrially we manufacture benzene, but even if we can scale this up to few hundreds of tons, it opens up a lot of opportunity in electronic industries, OLED industry, semiconductor industry, and there's enormous work that is also happening where else this can be used, because the science is very simple. We just need to find more opportunities and more applications where these materials can be used. Our sincere thanks to CSIR-IIP for taking up this sponsored research project for developing synthesis protocol for on a pilot scale. We look forward to your continued support and guidance, sir. Lastly, we feel there is a long way to go together, and such enriching interactions between academia and industry shall bring forth much awaited innovation in all the fields of science and technology. And once again, thank you. Sorry for being very, very brief, because we have certain confidentialities that we like to respect, but it's an emerging science and we should be looking at it. My sincere request to all the CSIR labs across India. Thank you very much.
I would like to call upon Dr. Sanat to hand over a memento to Mr. Manish Kothari. Now I would like to call upon Dr. Bharat Newalkar, who is currently working as a Chief General Manager, Research and Development in BPCL, for his talk.
Good afternoon, friends, and Director Sir and Chief Guest. At the outset, let me thank Director IIP for inviting us to be part of this program. Highly delighted to be here. And when we got an invitation on this program, we were looking at it, how we should look at this program. Whether it is just going to be an industrial talk, going generic talk, talking about what it is and what we are looking for, or really we want to give food for thought. So in that aspect, I prepared the presentation that my inner scientist came out and told, no, it should be food for thought. So I made a presentation specifically focusing on niche petrochemicals, which we are today as a country lacking. And this kind of chemicals are required on a sustainable basis, because if you look at petrochemical marketing cycle, it goes ups and down. But this kind of petrochemicals, there is steady market is there. However, it has been highly guarded, and entry into this kind of platform requires industry academia collaboration at very, very strong level, and with that full commitment. With this background, now I would like to talk about niche petrochemicals, what we are looking into, and what we feel that can be a good food for thought for the audience over here. So I'll just brief on petrochemical scenario, which we all know. then the niche petrochemicals which can be thought of, then what R&D initiatives we have taken on this platform of niche petrochemicals, and I'll conclude with the conclusion and way forward. So this slide shows the courtesy of KPMG, which clearly shows that demand for petrochemicals is going to increase and increasing day by day. And with a CAGR of 4 today, is going to go to 3 to 4 again for 26-27, and with a consumption of 48.8 MMTPA to 55 MMTPA. And with this kind of demand, if you look at the past, we are the net importers of petrochemicals, and this is being shown over here. And we all see here that all C1, C2, C3, C4 and aromatics, the 5 building blocks of petrochemicals, which we refiners produce in refinery, but don't tap it. Don't tap it properly. We just leave it. Leave it in a pool, an MS pool or LPG pool or some kind of solvent pools, and just we don't realize the value of these chemicals, these building blocks of the petrochemicals. Similarly, the trend is shown here that all this we are going to be net importer of petchem by 2030 also. Now coming to this niche petrochemical platform, if you look at this chart, this is all given in all annual books of any petchem company or oil refining company, or even textbooks. You will see all these kind of charts, and you see the primary petchem building blocks are there. And on the right hand side, you will see all the petchems which can be made from this platform chemicals, platform molecules. However, they're silent on the niche part. They don't mention anything on niche part. That is where the पर्दे में रहने दो, पर्दा ना उठाओ. That is where the point is. So we at R&D BPCL are looking clearly into this platform, and coming to this now, I listed few of them. One is cyclohexyl benzene, hydroquinone, polypropylene propylene oxide, SAP, and then how do we use CO2 for niche petrochemicals? Instead of looking for a common methanol, formaldehyde, there are common things, and if you look at methanol also, there are already technology licenses available in the market. So if you want to beat them, you have to be really, really good. If you want to beat people like other tops or others. So, but if you look at this platform of petrochemicals, there are very few players in the market. However, they don't license technology. So if you look at the cyclohexyl benzene, it's a benzene derivative. And the benzene derivative, if you look at the cost, if you take relative cost of benzene 1, the cyclohexyl benzene, which is electronic grade, can go up to $45 per kg. It is used in lithium-ion battery as the overcharge protection agent. All mobiles what we have, they are all having this. But it's used in maybe in a few ppm level or very, very low percentage level. However, it is still important because if you have the revenue generation, from $1 to $45, it's a big jump. However, the technology for this is guarded. If you see the current players of this game is Eastman, Samsung, BASF, Mitsubishi. There are other players are there, they are very small capacities are there, but these are 4 players that are having major capacities. And cyclohexyl benzene is a versatile molecule which can be used as solvent, LCD players, so then it can be used for phenol production. It can go for production of caprolactam through cyclohexanone, and it has a variety of applications. And currently in India, we don't have any producer for this chemical, and we want to be a lithium-ion manufacturing hub in India. And if you want to be that, if you want to be in that part of the game, we have to have the entire value chain with us. If we have missing link in that, then we are going to have net importer of the value chain. So why I say this is a very, very versatile chemical, because if you look at normal phenol production process, it goes via propylene and benzene alkylation to give cumin oxidation to give phenol and acetone. If you use benzene, it goes for hydroalkylation to give cyclohexyl benzene, and then oxidation to peroxide, and then cleavage to phenol and cyclohexanol. In both the cases, you find the difference is that the byproduct, which is acetone in the normal process, whereas you get caprolactam over here. So caprolactam is a high value chemical, and this is a process which can be tapped for phenol production in future if want. So looking at the conventional process for cyclohexyl benzene, if you look at literature, the two routes, one is Feldkraft assisted route, other one is oxidative coupling route. And both the routes have drawback. Mainly they are having multiple step process, then low selectivity, handling issues of the catalyst, and they are very difficult to have integration with refinery. So considering this aspect, there is a need to go for direct hydroalkylation of process for making cyclohexyl benzene. But it will require a very, very finely tuned catalyst for making this process happen selectively and with a maximalist conversion. To do so, you require to have right balance of metal acid sites, and that will happen over zeolite. So this is important to develop a catalyst which can balance this both the acid sites and dual acid site as well as metal site, and function in tandem to make this cyclohexyl benzene selectively and at a high conversion level. And also you have to select a zeolite which will also not support formation of byproducts. So this is what I have told just now. These are major challenges for the catalyst development, and we have taken the initiative, and we have already completed the catalyst development program, and also completed the know-how at demonstration at pencil level. We have got the IPs protected for this, and now we are going for demo plant for this. So this is what is targeted for cyclohexyl benzene at VBCL R&D Center. However, there are opportunities for industry, academia both to look at catalyst improvement, good process parameters improvement, which can be done together. Coming to hydroquinone, we see that now if you look at the benzene cost and hydroquinone cost is very, very different, 10 times higher than the benzene cost. And as the polymer industry is growing in the country, this hydroquinone requirement also will go up. And this is basically used as a stabilizer, which all know, but is not produced in India. It is import substitution and required to be captured. Application point of view, I listed over here. The applications are antioxidant, polymerization inhibitor, photosynthesis material, and it also goes in cosmetic, polymer industry, and paint industry, adhesive, the rubber industry. And its CAGR also, if you look at it, it is growing. And currently, the manufacturers globally are Solvay, they are the major, Camden Fine and Eastman. They are the people who are making this product. And if you look at the industrial practice, what is being followed, there are three options are there to adopt this and produce hydroquinone. One is this hydroxidation of phenol, and second one is hydroxy peroxidation of para-diethyl benzene, and third one is oxidation of aniline. And route 3 is not followed by many people because it's a highly tedious route, and route 1 and 2 are being followed. But if you look at there's something missing here. If you look at this hydroxidation of phenol, you get a catechol as a major product instead of hydroquinone. So if you go for catechol production, then there is also need to look at the market for catechol, and then there is a challenge over there. And if you look at part 2, scheme 2, where you can look at para-diethyl benzene, if it can be tapped for making hydroquinone, then it becomes a main product. This route can be practiced with the phenol manufacturers, those who get para-diethyl benzene as a byproduct in the process of cumene. Currently, they go for trans-escalation to go back to cumene and then make again phenol from that. This can be tapped to go for oxidation process by selective oxidation and producing hydroquinone. So this can add a boost to phenol manufacturers because the cost of hydroquinone is much higher than what they are getting from phenol. So this product enhancement can be done depending on the market demand and supply. It can be thought of. So we have been working in this area because we are the major consumer of hydroquinone. At our Kochi refinery, we have got a polypropylene derivative plant wherein we produce acrylic acid and acrylates, which have been stabilized using hydroquinone, and these are mainly imported. Hydroquinone is imported. Annual consumption goes in the range of 600 to 700 tons per annum. And this consumption as a country is going to go up because many of the people are coming up with C3 derivative plant. So when you go for such kind of plants, you require to have this hydroquinone as a your solution available within the country. So if you look at this, we have been closely looking into association and also tie up with phenol manufacturers who can take up our know-how and look at solution for valorizing their byproduct stream, mainly paradiesopyl benzene. The major challenge is that scale up. We are looking into scale up very critically, and also the specification which have been required for a polymer industry that has to be met, because mainly the crystal size of the hydroquinone is critical for the polymer industry, which has to be met while going for this kind of product. So there are challenges available which can be looked into together. I'll come to propylene oxide, which is we all know propylene oxide also is a major platform chemical for petchem industry, and it is currently being practiced by low hydrogen route. There are limitations of this route, and the selectivity is a problem, and byproduct handling is a problem. So there is a need to look at alternate solutions. How do you look at it? How do you develop it? And this is what is the current practice which has been followed. And this low hydrogen route and catalytic epoxidation of H2O2. But when you go for H2O2, we have get better atomic economy, and for that purpose, we need to have a excellent catalyst for this purpose. The requirement of excellent catalyst is reported in literature is TS1. TS1 is known to us in 1993 onwards. I think first paper came out from NCL Pune with Paul Asami group on TS1. But I think today we have left it. Today we have left it because there is a publication over there. But that is not the thing, because if you look at this industrial practice, today TS1 is practiced for this process of making propylene oxide from propylene. So we need to revive our efforts, what have been done in past. Knowledge bank is there with us, but we have to revive that efforts now. See, this is a process which has been practiced now. You start with cumene. Cumene comes from basically a phenol plant. From a phenol process, propylene plus benzene gives cumene. It's undergo air oxidation, followed by epoxidation, and then cleavage. This is entire clear. This cleavage is happening on TS1. That is where we need to look at, again, revisit our whatever has been done, and come to the reality and develop unique catalyst platform for this kind of process. Coming to acrylic value chain, as I told you that we have already put up a propylene derivative plant at Kochi, and we are producing acrylic acid at our Kochi plant, and we are going for acrylic acid derivatives, namely N-butanol, 2-ethyl hexanol, and then followed by their derivatives, further derivatives for butyl acrylates and other acrylates. And we have got acrylic acid, which can be used for different applications. We are looking into that mainly in super absorbent polymer, carbomers, detergents, and water treatment chemicals. And if you look at this technology for SAP, it is highly guarded technology. Today, our consumption of the country is about 90 to 100 KTPA, and entire requirement is catered through import. And this technology is not licensed to us, and we tried a lot. Our management tried a lot in 2010-11 to get technology licensed. However, it was denied. So we developed our own technology. Since 2014, we are working, and we developed our own technology for development of this superabsorbent polymer using acrylic acid. Now we are partnered with EIL. Now we are setting up the 20 KTPA plant at our Kochi refinery to make this SAP based on our own indigenous technology. This is what is the our plan for commercialization, our journey for SAP development, what we have done so far. Now come to this CO2. How can we use it? CO2 for niche petrochemicals. Now, if you look at CO2 chemistry, CO2 conversion to carbonate and oxalic acid is very, very easy. If you look at this Gibbs free energy chart. And conversion to platform chemicals like ethylene is tough. Because net free energy is positive. It's tough to get ethylene from this CO2. So now to look at, and if you look at methanol and carbon monoxide, they are reasonably achievable and can be done. And we are all doing that, methanol, formic acid, and it has been done. But what I wanted to stress upon here is that can we look into only carbon monoxide? Because if you look at oxo process, which has been adopted for production of oxo alcohols, it utilizes syngas plus propylene, undergoes hydroformylation to give butanol and isobutanol. This process is used using a highly guarded catalyst, which is proprietary in nature and licensed only by 1 or 2 licensors in the world. We have been developing the catalyst. We have successfully developed the catalyst for this hydroformylation. We have been taking now the trial at our Kochi refinery. But what I want to put the point here is that with the syngas production, what we have here, requirement for this hydroformylation, can we utilize CO2 for this purpose? That CO2, if we can utilize it for this purpose, instead of making methanol or formic acid, we are looking for best solution possible based on the conversion and selectivity level to make syngas from CO2 and integrated with propylene hydroformylation operation. This will give us more advantage in terms of heat utilization and no requirement of energy intensive series distillation, which is already there. We are practicing right now. So I can discuss more on this in during break. But this is what we are looking into. And also when we are looking into this platform chemicals, there is also need to look at how efficiently we can have these platform chemicals. Today we practice distillation for the separation of these olefins. Can we look at better solutions for this kind of separation, which requires very, very, very methodical and dedicated efforts, both from industry and academia and people like you. Because I'll give some examples over here in the next slide, which have been patented by none other than ExxonMobil. See, if you look at light olefin separation, the distillation is a highly energy consumption process. Adsorption is relatively better. And if you look at that adsorption to be practiced, you require to have an excellent type of material which will be selective for olefin separation. One for C3 separation, which is reported in literature, is ITQ12. We have made this material. It is, let me tell you very, very frankly, it is very, very difficult to make this, even understand the patent, what has been given by them. It is very, very difficult to even read the patent, what they have told in that patent, and make this ITQ12 in the lab. We were successful only one time, but we could not repeat it. It has got excellent selectivity for propylene. At 80 degrees centigrade, it becomes a molecular gate for propane. Doesn't allow any entry of propane in the zeolite. The uptake of propane at 80 degrees centigrade is 0. That's what we have witnessed in our lab. And propylene is the maximum uptake is observed for this material. So such kind of materials are required. Similarly, if you look at ITQ 32, it is made for C4 separation. The trans-2-butene, 1,2-butene, these separations are very, very difficult by distillation process. These are platform chemicals. You want to do that separation, you require very, very good, excellent material. And my urge is that let us look at this kind of approaches where we can look into energy efficient separation of these materials, these platform chemicals, and can be utilized for our platform development of niche petrochemicals. So in conclusion, what I would like to say is that innovation is the key. With a sustainable focus, it is required. At the same time, we have to have the market, eye on the market. It's not happening that we are looking at the only the one way. It should not be like a horse. But yes, we require to have people who will guide the horses to look at in the one direction and be focused and deliver in the right manner through collaboration and partnership. And with this, I feel that if we do this thing together, we can achieve our niche petrochemical dream in the coming few years. So I thank again for the IIP director for inviting us over here. And I hope I have given food for thought.
Thank you, sir. I would like to call upon Dr. Samir Maiti to hand over a memento to Dr. Navalkar. Now I would like to call upon Dr. Y.S. Jhala, who is the General Manager Quality Control from Panipat Refinery, IRCL, for his talk.
Good afternoon, all of you. Most respected Dr. B. Saab, Dr. Thaplial Saab, the excellent panel. I am feeling myself very young and very junior among the Dr. Bharat Saab. After the Bharat Saab slides, even people cannot expect to open their slides. So I'm just remembering my college days. When we are discussing about the single paper, the chemistry, the complete chain reactions and how molecules are traveling, how catalyst is working, chloride, water molecule. Now, sir, in industry, we just shifted our water and chlorine molecule and just crude and fuel out. So, definitely, sir, Bisab, really, it is a nice talking with the groups. We are attending so much different type of big seminars and international seminars also. But I feel today, very touch on the actual chemistry and the petroleum chemistry, because very small group we are discussing very small thing, and it's a good to industry and academics, because I'm always trying whenever we got any research paper of international experts, they when we go for their career or their biography and biodata, like BISAP also, we found the industry academics and now in India, the numbers are very less. Actually, like we started our career in industry and majority type we are working on industrial problems and day-to-day issues. But I always very think when I work in anybody work in industry for 10 to 15 years, they are having some issues in their blackboard. But solutions, sometimes he doesn't want solutions and doesn't having the time to find out the solution. सो चलता है, आज का निकाल देते हैं, कल देखेंगे. बट if these problems are really problem statement for research organization and academics and young peoples, I think no research paper is just begging for any markings. The beyond that, few days back, I just want to start in IIPs. In 2 months back, we are having some acute problem in our few of the refineries with respect to the crudes, and fortunately, I am the team leader for solving the problem, and I got it some old papers in our R&D in Faridabad. I got one paper of 1985 of IIP, and I got the solution completely. So I just want to say things are in our India, things are in our group. Sometimes we are not matching ourselves, our issues. Sometimes we are hiding. I'm taking some time, but I'm just sharing my views. In our refinery, 2 years back, we are getting, sir, one fire in oxygen cylinder. Very big fire in oxygen cylinder. And as a head, when I travel and I just get कि यार कैसे हुआ, क्या हुआ, my majority of people are saying, sir, oxygen में fire होता नहीं, इस matter को छोड़ दीजिए, leave it. ये सर जवाब नहीं दे पाएंगे, ये नहीं दे पाएंगे. But मैं मतलब I just curiosity, यार oxygen में fire हो गया. Then I started asking with my some industry colleagues. I got one refiners, I also got 2 times. Then I got Indian refineries, 50% got oxygen cylinder fire in 10 years. Then I started, नहीं कोई बात नहीं, मेरा insult होगा तो that insult is my, कि मुझे नहीं पता. Then I started open that discussion तो management oxygen cylinder में fire हुआ है, मुझे जानना है क्यों हुआ है. Then I got it some literature from foreigner. US में this is oxygen cylinder is a hazardous category, very very hazardous category, because their fire in the hospitals in oxygen cylinder is very normal. And when we got it the things, I just only share कि कैसे हम लोग अगर डिस्कस नहीं करेंगे तो some big happens in our laboratories. बाद में ये पता पड़ा कि very simple things, oxygen cylinder after a huge time they are having some iron particles in their cells. अगर मेरा एक्चुअली क्या होता है, सिलेंडर का हैंडलिंग 99% लैब में सबसे नीचे वाला बंदा करेगा हायरार्की में, ठीक है. और हमारे यहाँ भी उसने किया, एक्चुअली क्या किया, उसने बहुत फास्ट उसका थ्रोटल कर दिया, बिकॉज इट इज ए 5 o'clock, हिज बस वाज 5:15. इमीडिएटली उसने सिलेंडर चेंज किया. जब वो उसका ऑक्सीजन का फ्लो होता है, इट वाज हैविंग द जस्ट मॉलिक्यूल के साथ, उसका साथ जब आयरन मॉलिक्यूल उसके साथ थ्रो करते हैं, मॉलिक्यूल टू मॉलिक्यूल आपका आयरन पार्टिकल्स आर फ्रिक्शन, फायर हैपन्स, और उससे क्या हुआ, इतना एनर्जी होता है कि रेगुलेटर फट जाता है ऊपर से. और आप देखिए जब वो बंदा खड़ा था उसका बैक साइड का रेगुलेटर फटा और दीवार फट गई. इफ इट इज अपोजिट साइड, नो बडी, वी कैन नॉट सी हिम बैक. मेरा सिंपल बात है, this type of things we can discuss in our Indian construct. Definitely it will solve our problems. So in my presentation, luckily I am working in the fuels, petrochemicals, biomolecules also. So I tried not so much chemistry like sir, simple theory. Probably it will give some idea about Indian oil. So I think since morning we are discussing, so I'm not touching upon the normal things. Definitely petrochemical is a requirement of the day, and whatever the Indian refineries are coming, or whatever the older refineries of our PSUs also, we always want, like Dr. Bisab, increasing our trends from 7 to 8% to 9%, 9%. However, still it is very far, about 40 to 50%. Except I think Reliance is just planning for new refinery, crude to chemical, which is having very high, but we are just start thinking, because economics margins are very thing. And when think about the petrochemical, one thing is very busy, that everything is start from the chemistry, chemical, then petrochemical, then fuel and refinery. Because few days back, sir started the SAF here, and I'm also working with the IIP project of SAF since starting in the testing support. And the Ministry of Finance asked few days back about where to put SAF as a code, how to make HSN code of SAF, whether it is chemical or whether it is fuel. So 3 to 4 days we are just struggling how to prove it is a fuel, how to prove it is a chemical, because chemical is a separate chapter, fuel is a separate chapter. So these type of things are happened. So petrochemical, definitely the theory started from whatever the normal which are not useful as a fuel, we can go for petrochemical. This is a basic first concept started from the Indian refineries. Now it is changing diversely or different type of aspects. So when we are talking about the red ocean strategy and blue ocean strategy, definitely today's concept, fuel is a necessity. We cannot think about e-mobility. I have attended so many things. Still, every 2 years, our PPSC is giving the data, and he increased 5 years oil requirement. 2020 पे आया प्लेटू, फिर 30 पे आ गया, अभी recently 40 पे ले आए वो, 40 तक तो रहेगा. So we don't know, but हाँ, one thing we know very clearly, there is a requirement of both the things, and we have to make our country very clearly about the requirement of energy need and requirement of our normal utilities like chemical needs. So it is a blue ocean strategy. We need to make things competitive, make our refineries petrochemical integrated system. So it is a normal refinery system. Initially refineries are having 0%, nothing petrochemical. Now started with aromatics concept. In our Panipat PX we have started. Then we started about paraffins in our Gujarat refinery. Then we started about the aromatics and olefin rich naphtha cracker, gas crackers started, and crude to chemical still it is new chapter, but it is important. So on an average 8 to 10% petrochemicals part in refinery. This is the journey of Indian Oil. 2004 we started first time in the petrochemical business as a LAB, linear alkyl benzene. Then PTA in 2006, 2010 is a complete first time naphtha cracker come in the Indian Oil in Panipat. Then butadiene, then rubber we have produced, then butene one we have started, polypropylene, Paradeep we have started, then shifted to Paradeep, then MEG. Other than this, there is a lot of plants also I am just sharing. So now when petrochemical, at present also, whatever the additional naphtha we are having, that naphtha we are shifted to our petrochemical plant for production of different petrochemicals, which is plastics or in the chemical form. This is a journey of only Panipat refinery, which is IOCL most, I can say, petrochemical complex where we are having refinery, petrochemical, 2G, 3G. So in Panipat refinery, you can say we are having the all molecules of, including biomolecules of 2G and 3G ethanol also. So this is our present capabilities, and I was to see upcoming Gujarat refinery. We are coming for acrylic, oxo alcohol like Kochi refinery, and polypropylene. We are just diversifying in all areas, eastern, western, PX, PTA we are coming, and rubber also we are, PBR rubber we are coming now. The styrene also we are coming. So such type of new chemicals we are, I mean, textile project we are going to start in Paradeep, and malic anhydride in Panipat. Polyvinyl chloride also work started in 2028 is coming into IOCL Panipat refinery. Dual feed cracker, this is a new technology of coming with, we're having the off gas cracking also, some heavier cracking also we are planning. So it is a first chapter of crude to chemical, we can say, how it is not concept 100% crude to chemical also. So integration level we are talking about, so it started from refinery and ended up to crude to chemical. These are the some of the pictures. Actually crude to chemical is a new chapter, and whenever you go for any discussions, every big means licensor or technology partners like UOP, Chevron, everyone is coming with their own concept. What Bisab also said that some are using very light crudes in the China, and they are fighting for 50%, because the biggest challenge what they are having the crude to chemical is a crude itself, because the refinery or any plant is very heavy. We cannot make a very high number of variables in the plant, but crude is very variable. Now after COVID, all Indian refineries have got a big huge volume of Russian crudes, and Russian crudes full of asphaltene, full of metals, full of heavy and full of wax. Whole product profile is disturbed. And even our catalysts we are facing lot of different type of issues. Our chloride guards are not working. Our asphalt arsenic guards are same, but arsenic is entered in the system. So actually these are the challenge, but definitely refiners are get margins also. So cheap crude we have utilized, and वो कहते हैं ना सर, जब तक challenge नहीं आएगा तो Indians are not started. So now Indian is started. So आप ये देखिए, मैं इसका पॉजिटिव पार्ट एक ही बोलता हूँ कि हमने पुरानी रिफाइनरी में भी रशियन क्रूड चला दिया 3 साल. So ultimately BPCL, IOCL and HPCL, all three are using very Russian crude, but these are the challenges. So biggest challenge in crude to chemical is you cannot configure a very high variable refinery. So still lot of challenges will come on the system. Now I coming to the biomolecules. So already we have successfully commissioned our 2G plant from Parali to ethanol, that is second generation ethanol. And I just take it this because these biofuels also, we are having lot of challenges different time. And I think one of the key areas of R&D is a challenge of 2G and 3G ethanol. One thing is the stability of feedstock. Again, the biggest issue is the feedstock in the 2G and 3G. A feedstock is varying and very sensitive. 8% catalyst and every system is very sensitive. Slight variation they cannot actually face. And the second challenge, whatever the waste material coming out of the 2G and 3G, still people are not clear because waste material composition is still changing because feed change, waste change. So if you are targeting something like lignin, sir, we are lot of having issue with the lignin because very high lignin generation from the 2G ethanol, and lignin is 8%. We are discussing with IT, and we are just discussing with some of the new small companies also to use this lignin. Pyrolysis also we are planning lignin pyrolysis, and so ultimately these are the food for thought. Because now Indian government is very fast. E10, E12, E15 already launched. E20 we are launching in next year. So ethanol is one of the top requirement of the day. Next year also coming the biodiesel. If biodiesel is not added after April 2025, we all OMC we face. So first is requirement of that bio product in the country, and the manufacturing of bio product is still generation new challenges to R&D. A new challenge means new thought means, but this is very clear. After Brazil, I can say, if we are working on that, I think we are the biggest economy of the biofuels. Because whatever we are experiencing, what all experience is with us only. Because in 2G, we are experience. Few days back, sir, we have called HPCL and BPCL also in Panipat to just share our experience to 2G, because they both are coming with 2G. Because whatever we experience, probably in the manufacturing process, if they can make some changes, probably the other my peer groups cannot share. So 2G is we have started from rice scan. We are just successfully, this plant is working successfully. However, some challenges are there, but some challenges are also there in the analysis part also. Because like 1G ethanol, I never face any quality problem in 1G ethanol, never. I think 0.1%. In the 2G and 3G, there is a lot of quality problems. Slight changes, your sulfur will shoot up. I have never seen the sulfur in ethanol, but I started seeing in 2G and 3G. Sulfur, your stability problem in ethanol, moisture. So this is opportunity to learn something, to evaluate something, and the exchange of ideas, because whatever we are experiencing, we can exchange to each other. So industry colleagues can find out the way, and we can together we can grow. These are the 3G technology. This is LanzaTech's world's first technology, which is implemented in Panipat refinery, where whatever the CO2 which is getting from our refinery CO2 is capturing, and they are having some natural bacteria which take CO2 as a food and convert into ethanol and acetic acid. So challenge is same. This technology, 2G technology is a PRAS technology, so it is Indian technology, but this technology is completely US technology, LanzaTech, and 100% is not open to anything. So ultimately, what we face in this thing, we now try to make our system more robust, so we can utilize our indigenous technology. Because in all these things, I can find out the biggest investment of Indian things is technology only. The catalyst, proprietary catalyst. Still today, sir, LAB, all our Reliance, IOC, LAB 100% UOP. Catalyst we have to take from UOP. Wherever we went to product, we have to take the UOP. So such type of things, I think definitely all R&Ds of IOC, IIP, BPCL, HPCL, every year they are working with the new concept. So probably in the coming days, so challenges what we have discussed also, less in-house technology, still we are struggling, and high dependence of imported testing protocols, because whenever they give the technology, they will freeze your hand, they bind your hand. Sometimes they know, but you cannot do this, you cannot do this, that we can run plant by full of afraids. If our own technology, we can take some challenge, we can take some innovations. And definitely when we innovate, we find out some way out and it will give some good things. Sustainability route, one of the biggest requirement, because आज की तारीख में मैंने देखा है refineries are big problem in the water. In last 6 to 7 years, one of the biggest discussion point in the refinery is water management. How because whatever the things are then your wastewater, your zero liquid discharge. So I think for a chemistry or petrochemical, one of the biggest area in the coming thing is sustainability also. How we can utilize the water, how you can make our system to utilize minimum utilities. These are the important thing. And one point in my mind, we require more synchronization in Indian R&Ds. Whatever, if it is a private R&D, government R&D, PSU R&D, because sometimes we all are giving our efforts to a single things, and after 3 years, small route difference, but destination is same. If one energy utilized for another one, probably this type of energy will make system more good, and we can utilize our more potentials. So thank you very much for your patience hearing. Thank you. Thank you.
Some of the important research activities that are going on in our division is CH4 activation, methane activation to produce syngas. We generally use various methods like dry reforming, this steam reforming, as well as dry reforming to produce this syngas. Apart from that, we also work on this CH activation to produce C2 hydrocarbons like ethylene, ethane, as well as other aromatic compounds. In syngas conversion, there are several important molecules like oxygenates, methanol, ethanol, other ether materials. We are working on those, as well as this synthetic diesel as well. Apart from that, we are working on this naphtha reforming, where we use several, we have synthesized several valuable catalysts to produce various LPG products as well as gasoline. In addition to that, we are also doing some other important works on glycerol conversion, some animal fat oil based conversion, as well as bio oil upgradation. So some of the major works which are going on in our division, This one is the conversion of CO2 to methanol, which our director has already highlighted in his talk in the morning session. So in this, right now, the present work is the demonstration of this 10 kg per day production of methanol, which we expect to complete by September this year. Other important projects works we are working on is direct conversion of this benzene to phenol. Basically, at the moment in our lab, we are working using this hydrogen peroxide, but our main goal is to develop a new catalyst that can work in a continuous process using this molecular oxygen. So that is our main target. Apart from that, we are also working on this levinic acid to gamma valinolactone and this propylene to propylene oxide. I think the figure is missing from here anyway, but in this process also we have achieved quite high conversion and selectivity, but at the moment in this projects also we are looking for a continuous process and development of some new catalysts related to that. Finally, this production of syngas by tri-reforming of methane is also going on in our division, and at the moment this bench scale studies has already been completed up to TRL level 3, and we are planning to extend this further into pilot scale. And finally, I'd like to acknowledge Director CSIR-IIP for giving me this opportunity to present this talk on behalf of LSPD division, my head LSPD, and special thanks to all the scientists, project staffs, and the students for their valuable contribution to complete this project in a successful manner. Thank you very much.
Now I'd like to call upon Dr. Avinash Palutkar from the Upstream Wax and Rheology Division to highlight his work.
Good afternoon, everyone. I'm going to present on behalf of Upstream and Wax Rheology Division. So the major thrust of our division is conversion of waste plastics into value-added products. Along with that, we also do research works on additives for flow improvers. So today I'm going to discuss on waste plastics to chemicals. Basically, 9 to 10 million tons of waste plastics are generated every year, and among that 40% remains uncollected. So along with that, the demands for petrochemicals are getting improved. It is expected to grow 55 million metric tons in 2027. Therefore, basically these waste plastics create some problems. So this is composed of hydrocarbon molecules. Therefore, it can be converted into fuel and chemicals. So there is no such a proven technology to convert these waste plastics into fuel and chemicals. Therefore, technological interventions in that field is needed. So when we talk about waste plastics, there are two major kinds of waste plastics. One is pre-consumer waste plastics, which are coming from production industries, and another one is a post-consumer waste plastics, that is municipal solid waste plastics. So in UWRD, we have a couple of technologies to convert these post-consumer waste plastics into value-added products like gasoline, diesel, and BTX by thermocatalytic conversion route. Along with that, if we If we take waste plastics from pre-consumer waste, we have through liquid phase depolymerization, we can convert that waste plastics into paraffin wax and microcrystalline wax. So through thermocatalytic conversion route, we have three options. We can convert either 1 kg of waste plastics that is composed of polyethylene, polypropylene into gasoline or diesel or petrochemicals. So here we are going to focus on the process of petrochemicals. So the same process can be applicable for making gasoline out of the waste plastics which are composed of polyethylene, polypropylene, and there is only change of a catalyst for these three options. So the basic process of CSIR-IIP GALE is pyrolysis based process followed by catalytic conversions of the vapors, and after fractionation we get up to around 42% by mass of the aromatic rich liquid and around 58% of the C1 C5 gases. So the compositions of when we see about the compositions of the aromatic rich liquid, we can have a 28% of the BTX. Along with that, we can get up to 37% of the C3 gases, which can be useful as a fuel. Yeah, another one is the liquid phase depolymerization. The waste plastics which is coming from the production industries directly from the process like LPW, we can convert that into waxes, paraffin waxes or microcrystalline waxes. The process that we have is a liquid phase depolymerization, and we have a working unit of 100 kgs per day capacity. If we consider 100 kgs of LPW, we can get up to 85 kgs of the microcrystalline waxes, which basically falls in the range of type C and type D type of waxes. Yeah, I would like to conclude on the point that waste plastics are continue to be available and which need to be technological interventions to deal with the waste plastics. Along with that, the chemical demand is going to increase. So therefore, through this CSIR-IIP GALE process, we can facilitate or utilize these waste plastics to produce either fuel or chemicals. Yeah, these are the existing facilities that we have with us, right from the lab scale reactor to 1 ton per day pilot plant capacity reactor. Yeah, thank you so much.
Thank you, Dr. Avinash. Now coming to the last talk of this session, I would now like to call upon Dr. Pankaj Goswami, Director Operations Oil India Limited, for his talk on the dais. Okay, so in that scenario, I would like to call upon a break for this, and we can proceed towards lunch, and we can again assemble at around 2:30 p.m. It's almost 1:30. Okay, thank you.
A variety of petrochemicals drive our daily life and development of nation. The elite group comprising plastics and a host of other chemicals are downstream hydrocarbons derived from crude oil and natural gas. The value additions in petrochemicals serve various vital sectors such as agriculture, healthcare, infrastructure, etc. Currently, with a market size of 35 million metric ton, the Indian petrochemical industry stands tall among global competitors. But earlier, petrochemicals industries depended heavily on imported technologies and products for operations and services. This was a major constraint and barrier for its growth and development.
India needs energy for self-sufficiency, energy to grow, energy to develop its economy. We import 80% of our energy needs through crude oil, and when we produce fuels from crude oil, we also produce petrochemicals that go into a host of applications from food, clothing, shelter, building materials, day-to-day use items, plastics, and so on. The CSIR laboratories are working together relentlessly to make India self-sufficient in energy for our growth and economic aspirations, and in petrochemicals for value creation for our citizens.
CSIR laboratories transformed the petrochemical sector by developing and commercializing many path-breaking technologies. Several innovative processes were developed that are important for pushing up the petrochemical industry to new heights.
CSIR-IIP is working in the downstream sector of hydrocarbon industry. So we are mainly working on development of fuels and lubricants, chemicals and petrochemicals, biomass to fuels, and also on the CO2 capture and utilization, and new areas like bio lubricants and energy. We have developed several technologies in the past and they have been commercialized. If I talk about Reliance, the technology is one of its kind in the world. We are doing simultaneously producing the low benzene US quality gasoline and recovering that benzene in the pure form. So this kind of technology is not available presently anywhere. Reliance has put this plant at a cost of around 500 crore rupees, and it is greatly benefited by this technology.
To address environment concerns, CSIR-IIP developed a unique technology for simultaneous production of US-grade gasoline and high-purity benzene. The process, first of its kind in the world, yields gasoline with low benzene and sulfur, and simultaneously high pure benzene is also recovered. Recently, based on this process, Reliance Industries Limited commissioned a petrochemical plant at Jamnagar, which has a payback period of not more than 2.5 years. The technology has been granted a US patent and one Indian patent has been filed. The plant is under smooth operation with maximum throughput and attractive returns from export and sale of gasoline and benzene.
भारतीय पेट्रोलियम संस्थान देहरादून ने मोम बनाने की एक टेक्नोलॉजी विकसित की है। ये टेक्नोलॉजी पूरी तरह इंडिजीनियस टेक्नोलॉजी है और ये टेक्नोलॉजी नुमालीगढ़ रिफाइनरी को स्थानांतरित की गई है। नुमालीगढ़ रिफाइनरी जो आसाम में स्थित है, उसने इस टेक्नोलॉजी के आधार पर वहाँ एक प्लांट, वैक्स का प्लांट लगाया है, उसमें प्रोडक्शन स्टार्ट हो गया है।
A novel technology to produce paraffin wax and microcrystalline wax from petroleum streams was developed to curb heavy import of waxes for industrial uses. The low-cost technology is energy efficient with many unique features such as use of single solvent and lower solvent to feed ratio. Numaligarh Refinery Limited commissioned a wax plant based on this technology, which was dedicated to nation by Prime Minister on 5th February 2016. Production of waxes by the plant has increased profitability of refinery by 77 crores per annum, slashed import of waxes by 50%, saved foreign exchange worth rupees 300 crore per annum, and captured 52% of the Indian market share for paraffin wax. Although a new player in the market, NRL is supplying waxes to more than 60 clients in India and has also started exports to Kenya, Bangladesh, Nepal, Thailand, etc.
We have developed many technologies. First of the technology was benzene, toluene, xylene extraction. This was commercialized in BPCL Mumbai. Later on, we have developed many technologies. Second one was food grade hexane technology using sulfolane, then food grade hexane technology using NMP.
CSIR-IIP developed NMP lube extraction technology for production of Group 1 lube base oils. After USA, India is the second country to develop this process, which has many salient features, such as low solvent to feed ratio, low operational temperatures and better products quality, etc. More importantly, in this technology, solvent composition can be tailor-made for processing of wide range of lubes. A grassroots NMP lube extraction unit of combined throughput 3.5 lakh TPA was commercialized at IOCL Haldia refinery. Development of LPG sweetening catalyst, ThoxCat, has earned many laurels for country, which includes 6 foreign and 3 Indian patents.
IIP thought of developing a catalyst which would be globally competitive because a lot of foreign exchange was being lost in buying these catalysts from abroad. So with that in mind, IIP collaborated with BPCL back in 1994 to develop this LPG sweetening catalyst. The first successful trial happened in 2001 in BPCL Mahul refinery, where the quality of LPG treated by this indigenously developed globally competitive catalyst named as ThoxCat ES was established.
It is a low-cost but globally competitive catalyst applicable for extractive sweetening of LPG, LSRM or pentane. It can also be used for liquid-liquid sweetening of lighter petroleum fractions like light naphtha or light cracked gasoline. A good number of Indian refineries are using this catalyst with better performance than the previously used catalyst. No further investment is required for any modification in existing plant. For production and sale of this catalyst, license has been given to Lona Industries Limited, Mumbai. CSIR-IIP developed a unique technology of aromatic extraction for production of benzene and toluene using sulfolane solvent. The technology was commercially implemented at BPCL Mumbai and KRL Kochi with very good success rate and performance. CSIR-NCL is another leading laboratory which has significantly contributed in development and modernization of petrochemical industries. Several of its technologies have been successfully commercialized by Indian refineries and petrochemical companies. Most of the technologies are environment friendly and potential source of increasing profits or gross refinery margins. Some of its notable technologies are xylofining technology, albuene technology, para-diethyl benzene technology, styrene technology, olefining process, Endevax technology, and FCL technology. Indigenous technologies, process and products developed by CSIR labs have found applications in Indian refineries and petrochemical industries. In many cases, imports have been curbed drastically and an era of exports has begun. Self-reliance is rolling steadily. Armed with CSIR technologies, the Indian petrochemical sector is bracing itself to meet demand growth of increasing population. CSIR labs are marching ahead with a mission and vision to carve a place of Indian petrochemical sector among global leaders. The day is not far ahead when India will be self-reliant in terms of production of petrochemicals, but also be in a position to export the same.
नमस्कार, आप देख रहे हैं न्यू इंडिया डिबेट।
आपके साथ मैं हूं पराक्रम सिंह शेखावत। आज भारत 248.9 MMTPA रिफाइनिंग क्षमता वाला वैश्विक रिफाइनिंग हब है, जो कि संयुक्त राज्य अमेरिका, चीन और रूस के बाद दुनिया का चौथा सबसे बड़ा देश है। हमारे देश में कुल 23 रिफाइनरीज हैं, जो कि भौगोलिक रूप से भी अच्छी तरह से फैली हुई हैं और साथ ही क्रॉस कंट्री पाइपलाइन से भी जुड़ी हुई हैं। न्यू इंडिया डिबेट में आज का विषय है क्रूड ऑयल सेक्टर में भारत की स्थिति। इस चर्चा के जरिए हम समझने की कोशिश करेंगे पेट्रोकेमिकल्स, रिफाइनरीज और बायोफ्यूल यानी कि जैव ईंधन के क्षेत्र में हमारे देश में कितना काम हुआ है। हम आ पहुँचे हैं देहरादून के भारतीय पेट्रोलियम संस्थान में। तो चलिए मेरे साथ नए भारत की युवा आवाज़ के साथ शुरू करते हैं न्यू इंडिया डिबेट। देहरादून के राजाजी नेशनल पार्क के खूबसूरत प्राकृतिक वातावरण के बीच इंडियन इंस्टीट्यूट ऑफ पेट्रोलियम कैंपस बना हुआ है और यहाँ पर मेरे साथ IIP के रिसर्च स्कॉलर्स हैं जिनसे हम बात करेंगे, और साथ ही मेरे ठीक पीछे जो आप प्लांट देख रहे हैं ये प्लास्टिक वेस्ट टू डीजल पायलट प्लांट है, जो कि 1 टन प्लास्टिक से तकरीबन 800 लीटर डीजल बनाता है, जिसका उपयोग किया जाता है। तो वाकई में ये अपने आप में बहुत ही सराहनीय प्रयास है और गेल, CSIR और IIP का कोलैबोरेटिव प्रोजेक्ट है ये। मैं समझना चाहूँगा आपसे ये प्लांट किस तरीके से काम करता है।
सर, यहाँ पे हम बेस प्लास्टिक को पहले तो प्री ट्रीटमेंट करते हैं, जैसे कि इसको वॉश करते हैं, श्रेड करते हैं, और इसके बाद जो है हम इसको पायरोलिसिस प्रोसेस के थ्रू इसको हम वेपर्स में कन्वर्ट करते हैं जो प्लास्टिक होता है, और उसको फिर हम एक कैटालिटिक वेड होता है जिससे हम पास करते हैं, और आफ्टर दैट ये डीजल में कन्वर्ट होता है। और इससे हम डिफरेंट टाइप के भी प्रोडक्ट ले सकते हैं, जैसे गैसोलीन, डीजल और कुछ हैवियर प्रोडक्ट्स जैसे एरोमेटिक्स, उसमें बेंजीन, टॉलुइन, जाइलिन, इस तरह के प्रोडक्ट में हम वेस्ट प्लास्टिक को कन्वर्ट कर सकते हैं, जिससे कि एक तरह से हमारी जो ऊर्जा की खपत है उसको, जो कि जीवाश्म ईंधनों पे निर्भर है, उसको कम किया जा सकता है।
बहुत अच्छा। मतलब देखिए, आपकी जो प्लास्टिक जो कि हज़ारों सालों तक वो नष्ट नहीं होता है और पर्यावरण को भी नुकसान पहुंचाता है, ऐसे में ये जो प्लास्टिक है आप ये कहां से इकट्ठा करते हैं, और जो तकरीबन 800 लीटर डीजल हर दिन यहां पर जो बनता है उसका इस्तेमाल किस तरीके से करते हैं आगे के लिए?
अभी सर इसके लिए हम टेस्टिंग फेज़ में हैं। अभी हम इसकी टेस्टिंग कर रहे हैं। यूरो 6 स्टैंडर्ड्स होते हैं, जो BS स्टैंडर्ड्स हैं, वो इसको मैच तो कर चुका है, लेकिन अभी भी ये टेस्टिंग फेज़ में ही है। बाकी जो NGOs हैं, अलग अलग रति फाउंडेशन है, यहाँ पे हिमालयन इंस्टीट्यूट है, वहाँ का जो NGO है, इन NGOs से कनेक्ट कर कर हम यहाँ वेस्ट प्लास्टिक्स का अरेंजमेंट करते हैं। उसके बाद वही हमें बेसिकली PEPP जो प्लास्टिक्स हैं वही हम इसमें यूज़ करते हैं। अदरवाइज़ जो दूसरे प्लास्टिक्स हैं वो अभी उसके लिए डीजल का प्रोसेस ये अभी नहीं है।
साइंटिफिकली अगर देखा जाए तो प्लास्टिक वेस्ट एक कॉम्पोजिट वेस्ट होता है, जिसमें बहुत तरह के प्लास्टिक होते हैं। पेट बॉटल से PVC तक होते हैं, अलग अलग पॉलीमर्स। तो पहले तो हमें उनका क्लासिफिकेशन करना पड़ता है कि अलग अलग प्लास्टिक कहाँ से कितने वेस्ट, कितने तरह के वेस्ट निकल रहे हैं, वो आखिर में जा कहाँ रहे हैं। कहीं कलेक्शन पे जा रहे हैं, कहीं लैंडफिल पे जा रहे हैं। और उसके बाद जिस तरह यहाँ पायरोलाइसिस की सिस्टम लगाई गई है, उस तरह अलग अलग ट्रीटमेंट सजेस्ट करते हैं कि हम किस तरह से डीपॉलीमराइजेशन कर पाएँ और उससे ईंधन या फिर दूसरे चीज़ें तैयार कर पाएँ। जापानीज़ बहुत लंबे समय से करते आ रहे हैं, वो एटम्स को देखते हैं, एटम इकोनॉमी को देखते हैं। अब वक्त आ गया है कि हमें भी उस डायरेक्शन में सोचना चाहिए, हमें एटम्स को पकड़ना चाहिए। सिर्फ कार्बन ही नहीं, कार्बन के अलावा जो मेटल्स हैं, जो फॉस्फोरस है, नाइट्रोजन है, हमें उनको भी कन्वर्ट करना चाहिए और उनके साथ साथ मटेरियल को रिसाइकिल करना है और रिसोर्स एफिशिएंसी की तरफ जाना है।
हाइड्रोजन ग्रीन क्लीन फ्यूल है, ये कितना इम्पोर्टेंट है हमारे एनवायरनमेंट के लिए और इस पर किस तरीके से काम हो रहा है?
सर, पहले तो हमें समझना पड़ेगा कि ग्रीन हाइड्रोजन और ग्रे हाइड्रोजन में अंतर क्या है। ग्रीन हाइड्रोजन सर जो बनता है उसमें यूज़ होता है रिन्यूएबल सोर्स ऑफ एनर्जी। पहले तो जो हाइड्रोजन बनाने की जो प्रक्रिया है उसको इलेक्ट्रोलिसिस बोलते हैं, और पानी में से इलेक्ट्रिसिटी पास करके उसको हाइड्रोजन और ऑक्सीजन में तोड़ा जाता है।
तो सर जो इलेक्ट्रिसिटी यूज़ हो रही है उसको हम कैसे प्रोड्यूस कर रहे हैं। अगर उसको प्रोड्यूस करने में हमको रिन्यूएबल सोर्स ऑफ एनर्जी लग रहा है जैसे विंड पावर, सोलर पावर, तो वो होगी ग्रीन हाइड्रोजन। और अगर हम फॉसिल फ्यूल्स यूज़ कर रहे हैं जैसे कि पेट्रोलियम प्रोडक्ट्स, कोल, तो वो होगी ग्रे हाइड्रोजन जो कि पोल्यूशन ही क्रिएट कर रही है फाइनली। तो सर ग्रीन हाइड्रोजन को यूज़ करने का फ़ायदा है, एक तो H2O अबंडेंस में है काफ़ी, क्योंकि 70% ऑफ अर्थ इज़ वाटर ओनली। दूसरा सर इको फ्रेंडली क्लीन फ्यूल है, इससे ग्रीन हाउस इफेक्ट, ग्लोबल वार्मिंग कम हो रहा है। तीसरा सर एनर्जी प्रोडक्शन बहुत ज़्यादा है।
इसके साथ साथ बायोफ्यूल जो कि उसका एक पार्ट है, ये कितना इम्पोर्टेंट है और इस पर IIP किस तरीके से काम कर रहा है।
भारत में इस संस्थान में ऐसा पहला विभाग है मटेरियल रिसोर्सेज एफिशिएंसी डिवीज़न, जो प्योरली वेस्ट को टारगेट करता है कि वेस्ट को हम किस तरीके से यूटिलाइज़ कर सकते हैं। तो उसे हम थर्मली ट्रीट करके हम बायोचार भी बनाते हैं। उसके अलावा हम बायोलॉजिकली ट्रीट करके डिफरेंट एग्रो वेस्ट से हम बायोइथेनॉल और डिफरेंट प्रोडक्ट्स भी बनाते हैं। तो इसके लिए हम यहाँ पे 3 टाइप के प्री ट्रीटमेंट मेथड यूज़ करते हैं, एसिड प्री ट्रीटमेंट, अल्कली प्री ट्रीटमेंट और एंजाइमेटिक प्री ट्रीटमेंट। और एंजाइमेटिक प्री ट्रीटमेंट में हम सेलुलेजेस, अमाइलेजेस ऐसे डिफरेंट एंजाइम्स यूज़ करते हैं ताकि जो ये बायोफ्यूल बनाने का जो प्रोसेस है वो थोड़ा कॉस्ट इफ़ेक्टिव हो पाए।
इंडिया में अभी बस 1% बायोफ्यूल जनरेट हो रहा है और इसमें अगर हम वर्ल्ड के टॉप 5 देश को देखें तो अमेरिका 45% के अराउंड बायोफ्यूल जनरेट करती है, इंडोनेशिया फिर सेकेंड नंबर पे जो 26% के अराउंड, जर्मनी, अर्जेंटीना और ब्राज़ील ये प्रोड्यूस करती है। इंडिया अभी बहुत लैग कर रही है इसमें। और अगर रिसर्च और इनोवेशन पे ज़्यादा से ज़्यादा ध्यान दिया जाए और जैसा कि IIP में यहाँ पे बायोफ्यूल पे बहुत अच्छा काम हो रहा है, तो शायद हम लोग एक दिन उस लीग में पहुँच जाएँ, टॉप 5 के लीग में पहुँच जाएँ, जहाँ पे से हम लोग हो सकता है शायद इससे जो एक्सपोर्ट भी कर सकते हैं। और अभी जो इस बायोफ्यूल का मार्केट है, गवर्नमेंट ऑफ इंडिया के एक्सपर्ट कमेटी के एक रिपोर्ट के अनुसार लगभग 30,000 करोड़ का है।
एसेंशियल ऑयल इंडस्ट्रीज़ हैं, आफ्टर द ऑयल एक्सट्रैक्शंस बहुत सारा वेस्ट जनरेट करती हैं। तो अगर उस वेस्ट पे भी फोकस किया जाए तो हम और भी अच्छी डायरेक्शन में हम काम कर सकते हैं। सिर्फ बायोफ्यूल ही नहीं, उसके थ्रू हम बायोचार जनरेट कर सकते हैं विच कैन बी अ गुड फर्टिलाइज़र फॉर द सॉइल टू। अदर दैन दिस जो बायो ऑयल जनरेट होता है, इस बायोफ्यूल के अलावा हम उसको एज अ पेस्टिसाइड भी यूज़ कर सकते हैं, जो किसान हैं वो उसको यूज़ कर सकते हैं।
प्लास्टिक से हम वैल्यू एडेड केमिकल्स ऑब्टेन कर सकते हैं। वैल्यू एडेड केमिकल्स में बहुत सारे केमिकल्स की रेंज आ जाती है, जैसे कि ओलेफिन्स आ जाते हैं, एरोमेटिक्स आ जाते हैं। एरोमेटिक्स में आते हैं बेंजीन, टॉलवीन, ज़ाइलिन, जो कि केमिकल प्रिकर्सर हो सकते हैं, इंटरमीडिएट्स हो सकते हैं बहुत सारे यूज़फुल केमिकल्स का। इंडिया बहुत सारे केमिकल इंपोर्ट करता है आज के टाइम पे, और डिपेंडेंसी को कम करने के लिए, सेल्फ डिपेंड होने के लिए वी कैन यूज़ दिस केमिकल इंटरमीडिएट फॉर वैल्यूएबल केमिकल्स।
क्रूड ऑयल आपका देखेंगे तो डे बाय डे ख़त्म ही हो रहा है, तो उसका अल्टरनेटिव ऑप्शन आपका यही बचता है कि बायोफ्यूल। आइदर आप फीड उसमें कुछ भी ले सकते हैं, उसके ऊपर IIP रिसर्च कर रहा है कि आप वेस्ट प्लास्टिक लेते हैं या प्लांट ऑयल लेते हैं या जो भी अनसैचुरेटेड ट्राइग्लिसराइड हैं उससे आप कन्वर्जन कर रहे हैं, तो डे बाय डे उस पर रिसर्च हो रहा है सर। तो इसलिए बायोफ्यूल काफ़ी इंपॉर्टेंट हमारे लिए।
ईंधन के जो वैकल्पिक स्रोत हैं उस पर हम ध्यान दें, और बायोफ्यूल के साथ साथ हम देख रहे हैं कि ग्रीन डीजल पर भी काम हो रहा है, और उसके बहुत सारे ऐसे उदाहरण भी हैं कि उसके ज़रिए अगर मैं गलत नहीं हूँ तो देहरादून से दिल्ली के स्पाइसजेट की फ़्लाइट भी उस ग्रीन डीजल से उड़ाई गई थी। ये कितना ज़्यादा इम्पॉर्टेंट है हमारे एनवायरनमेंट को भी सेफ रखने में।
जो पहली फ़्लाइट थी स्पाइसजेट की बायोडीजल पर आधारित, जो देहरादून से दिल्ली के लिए गई थी, वो एक IIP का एक इनोवेशन था, एक टेक्नोलॉजी थी जो राष्ट्र निर्माण में IIP ने योगदान दिया था अपना।
लेकिन इसके साथ साथ एक सवाल ये भी है कि जो हमारी क्रूड ऑयल की जो रिफाइनिंग प्रोसेस है, उस रिफाइनिंग प्रोसेस में भी जो दूषित और जो जहरीले केमिकल्स निकलते हैं वो एक तरीके से हमारे पर्यावरण को नुकसान पहुंचाते हैं। तो वो रिफाइनिंग प्रोसेस हम तकनीक के इस्तेमाल से कैसे इको फ्रेंडली बना सकते हैं, कैसे उसमें हम ये कर सकते हैं कि वो हमारे पर्यावरण को, प्रकृति को नुकसान ना पहुंचाए।
सर क्रूड ऑयल जब आपका डिस्टिलेशन होता है, जब क्रूड ऑयल से हम नैप्था, डीजल ऐसा निकलते हैं, तो उसमें एक बहुत ही दूषण और मतलब जो इंजन को ख़राब करने वाली एक केमिकल होता है जिसको एस्फाल्टिन बोलते हैं। तो एस्फाल्टिन को हम बेसिकली कुछ यूज़ करते हैं, जैसे कि एस्फाल्टिन नॉर्मल होता है कि आप चोकिंग कर देता है, या फिर आपका अगर उसमें आपके ऑयल्स में अगर ज़्यादा हो,
बट अगर हम नॉर्मल डीजल में या पेट्रोलियम में अगर थोड़ा सा एस्पर्टिन हम दे सकते हैं तो इट कैन एक्ट एज एन लुब्रिकेंट। तो ये भी रिसर्च हुआ है।
सिर्फ रिफाइनरी से ही नहीं और भी इंडस्ट्रियल प्रोसेसिंग से जो भी वेस्ट निकलता है, एक जैसे इन्होंने बताया कि कोई इंटरमीडिएट बाई प्रोडक्ट है उसे हम डायरेक्टली यूज़ कर सकते हैं। पर आपने जो सवाल पूछा था कि इसे कैसे सस्टेनेबल ज़्यादा बनाए या एनवायरमेंटल फ्रेंडली कैसे बनाए, तो उसके लिए जो चीज़ हम करते हैं, IIP भी जिस चीज़ को ट्राई कर रही है वो है हम लाइफ साइकिल असेसमेंट करते हैं, लाइफ साइकिल एनालिसिस करते हैं। किसी भी प्रोसेस, चाहे वो रिफाइनिंग का हो या फिर डाउनस्ट्रीम प्रोसेसिंग का हो या अपस्ट्रीमिंग करना हो, हम हर प्रोसेस को हर एक स्टेजेस पे तोड़ के हम देखते हैं कि एयर का एमिशन लिक्विड वेस्ट हो या सॉलिड वेस्ट हो, कितने क्वांटिटी में जनरेट हो रहा है, किस तरह का वो वेस्ट है, उसकी टॉक्सिसिटी कितनी है, नेफ्रोटॉक्सिसिटी हो मतलब हार्ट डिजीज़ कॉज करे वो जाके, या न्यूरोटॉक्सिसिटी हो, उन सारी चीज़ों को देख के प्लस उसकी एनर्जी, क्योंकि आप क्रूड प्रोसेसिंग कीजिए या वेस्ट प्रोसेसिंग कीजिए, आपको एनर्जी वहाँ भी यूटिलाइज़ करना है। तो उन सारी चीज़ों को देख के हम ये रास्ता खोजने की कोशिश करते हैं कि ग्रीन केमिस्ट्री को अप्लाई करके ज़्यादा इको फ्रेंडली मटेरियल यूज़ करें तो क्या डिफरेंस आएगा, या उससे जो वेस्ट निकल रहा है उसे डायरेक्ट यूटिलाइज़ कर ले तो कितना बेनिफिट होगा।
ठीक है, आप कुछ कहना चाहेंगे?
या मैं CO2 एमिशन के ऊपर बात करना चाहता हूँ। हम लोग देखते हैं 1960, दैट इज़ द इंडस्ट्रियल एरा, स्टार्टिंग ऑफ द इंडस्ट्रियल एरा, तो वहाँ से अभी तक का तो जो नेचर में कार्बन डाइऑक्साइड का अमाउंट है वो काफ़ी ज़्यादा इंक्रीज़ हो गया। तो करेंट डेट पे आज का एमिशन है 421 ppm। तो उसको कम करने के लिए अगर वो बढ़ता रहेगा तो हम लोगों के एनवायरनमेंट पे बहुत ज़्यादा इफेक्ट पड़ेगा, ग्लोबल वार्मिंग जैसे इफेक्ट बढ़ने लगेंगे। तो इसको कम करने के लिए IIP में हम लोग बहुत सारा टेक्नोलॉजी अपनाते हैं। तो कार्बन डाइऑक्साइड को हम क्रूड लेके हम लोग उससे अलग अलग केमिकल्स बनाने की कोशिश करते हैं, लाइक मिथानॉल, फॉर्मिक एसिड, सिनगैस एट्सेट्रा। उन लोगों से हम इसको ईंधन के रूप में यूज़ कर सकते हैं।
देखिए, हम एनवायरनमेंट पर हम बात कर रहे हैं और कैसे हम ग्रीन फ्यूल, बायोफ्यूल को बढ़ावा देकर और हम हमारे पर्यावरण को बेहतर बना सकते हैं।
सर, जैसे कि आपने बात किया कि हमारे इंडस्ट्रीज़ से काफ़ी जो पोल्यूशन है, जैसे कि हमारे कुछ हार्मफुल गैसेस हैं H2S, SO2, तो इस पे भी IIP ने काफ़ी काम किया है। अभी हमारा एक प्रोजेक्ट है जिसमें हम H2S गैस से वापस से हाइड्रोजन एक्सट्रैक्ट करते हैं। तो हमारा एक साइकिल है, थर्मोकेमिकल सल्फर आयोडीन साइकिल, जिस पे हमारा काफ़ी काम हुआ है, हमारा पेटेंट भी है IIP का। तभी हम इसको कॉमर्शलाइजेशन की तरफ लेके जाना चाह रहे हैं। तो जिसमें हम क्या करते हैं, हम हाइड्रोजन गैस को H2S से एक्सट्रैक्ट करते हैं। इसके अलावा जैसे कि आपने बताया कि हमारा जो एटमॉस्फेयर में CO2 है, इस पर मेरे मित्र ने भी बताया कि इस पर काफ़ी काम हुआ है। तो अभी हमारा इसका NTPC के साथ एक कोलैबोरेटिव प्रोजेक्ट चल रहा है, जिससे हम कार्बन डाइऑक्साइड से मिथेनॉल, इथेनॉल जैसे फ्यूल पे काम कर रहे हैं।
सर, इसी सीरीज़ में जैसे CO2 एक एनवायरनमेंट पॉल्यूट कर रहा है, तो इसी सीरीज़ में जैसे मीथेन को हम नेगलेक्ट कर रहे हैं अभी। तो मीथेन एनवायरनमेंट में बहुत ज़्यादा चीज़ों से मिलती रहती है, जैसे बायोगैस प्लांट से भी मीथेन मिलता है। और ये बहुत सारे मतलब वर्ल्ड के उन एरियाज़ में मिलता है जहाँ पे जो ह्यूमन का मतलब एक्सेस है वो कम है। तो ये एक वेस्ट जा रहा होता है इन्वायरमेंट में। और दूसरा चीज़ कि साथ साथ इससे जो हम प्रोडक्ट्स बना सकते हैं, वो जो पहले से हमारे पास अवेलेबल जो टेक्निक है वो थोड़ा कॉस्ट मतलब ज़्यादा एक्सपेंसिव है। बट अगर हम एज अ कैटलिस्ट को अगर हम यूज करते हैं तो डायरेक्ट मीथेन से हम वैल्यूएबल प्रोडक्ट्स बना सकते हैं, जैसे बेंजीन है, टॉल्विन, जाइलिन है। तो इन चीज़ों को हम बना सकते हैं जो आगे हमें फ्यूल प्रोवाइड करेंगे। और वैसे भी मीथेन जो है वो CO2 के तुलना में जो 21 टाइम्स ज़्यादा ग्रीन हाउस इफेक्ट शो करती है। तो अभी हम लोग इसी चीज़ पे काम कर रहे हैं कि मीथेन से डायरेक्टली हम कैटलिस्ट यूज़ करके वैल्यूएबल प्रोडक्ट्स बना सकें।
कि यदि हम पेट्रोलियम के इतिहास पर नज़र डालें भारत में, तो ये हम कह सकते हैं कि असम के डिगबोई में पहली ऑयल रिफाइनरी स्थापित की गई। तब से लेकर आज तक कितना सुधार और क्या बदला है तकनीकी रूप से?
जैसे कि हम जानते हैं कि भारत जो है वो चौथा पेट्रोल का उत्पादन करता है। पहले नंबर पे अमेरिका है, रशिया है, चाइना है, चौथे नंबर पे भारत है। तो इस समय पे हमारे भारत में 23 रिफाइनरीज़ हैं जो इस पे काम कर रही हैं और हमारा जो क्रूड ऑयल है उसको पेट्रोल में कन्वर्ट कर रही है।
बहुत सारे प्रयास यहाँ पर हैं और इसमें ये बहुत महत्वपूर्ण है कि हम बायोफ्यूल और ग्रीन डीजल और हाइड्रोजन पावर्ड व्हीकल्स, क्योंकि अब इलेक्ट्रिक व्हीकल की तो हम बात करते ही हैं, लेकिन ये हाइड्रोजन पावर्ड व्हीकल्स की भी बात हो रही है। तो इस पर ध्यान देने की ज़रूरत है हम सभी को, और ये बहुत ज़रूरी है हमारे बेहतर भविष्य के लिए। फिलहाल न्यू इंडिया डिबेट में रुक रहे हैं एक छोटे से ब्रेक के लिए। ब्रेक के बाद आपको लेकर चलेंगे क्रूड ऑयल रिसर्च सेंटर की लेबोरेटरी में, और वहाँ तकनीकी रूप से समझने की कोशिश करेंगे कि उसके और क्या कुछ मायने हैं। बने रहिए हमारे साथ। ब्रेक के बाद एक बार फिर आपका स्वागत। आप देख रहे हैं न्यू इंडिया डिबेट, और जैसा कि ब्रेक पर जाने के पहले हमने आपको कहा था हम आपको लेकर चलेंगे IIP की लेबोरेटरी में, तो हम यहाँ पर आ चुके हैं और हमारे रिसर्चर्स यहाँ पर लेबोरेटरी में किस तरह से काम कर रहे हैं थोड़ा सा ये समझने की कोशिश भी करेंगे। ब्रदर, क्या नाम है आपका?
मेरा नाम अनिल है।
अनिल, ये समझना चाहेंगे कि क्रूड ऑयल और पेट्रोलियम को लेकर आप लेबोरेटरी में किस तरीके से रिसर्च करते हैं, क्या वो टेक्निक्स होती हैं, एक आम भाषा में यदि समझने की कोशिश करें तो?
जैसा कि हमारा संस्थान भारतीय पेट्रोलियम संस्थान, इसका जो मोटो है वो है कि भविष्य के जो ईंधन है उसको उत्पादित करना है। तो उसके लिए हम क्या करते हैं कि जो ग्लोबल वार्मिंग वाली गैसें हैं जैसे मीथेन और CO2, इनको किसी और वैल्यूएबल प्रोडक्ट्स में कन्वर्ट करते हैं, और जिससे कि हम मतलब जो पेट्रोल की कीमतें हैं और डीजल की कीमतें हैं उनमें कमी लेके आएँ और लोगों के बीच एक सस्ते दामों पर फ्यूल्स उपलब्ध कराते हैं।
बेहतर तकनीक का इस्तेमाल तो हर दिन हो रहा है, लेकिन पेट्रोलियम उत्पादों से जो जहरीले यौगिक निकलते हैं और उनको आप लोग किस तरीके से मैनेज करते हैं, क्योंकि ये भी एक बहुत बड़ा कंसर्न है हमारे देश में कि जो एरोमेटिक यौगिक जो होते हैं उनको अलग करने की प्रक्रिया क्या है?
सॉल्वेंट्स के प्रयोग के द्वारा, यानी सॉल्वेंट एक्सट्रैक्शन प्रोसेस के द्वारा इन एरोमेटिक यौगिकों को अलग करते हैं, निकालते हैं जो पेट्रोलियम उत्पाद है उसमें से। तो वर्तमान में क्या है कि जो रिफाइनरीज हैं उनके द्वारा एक कमर्शलाइज जो प्रोसेस हैं, जो वर्तमान में अच्छी कमर्शलाइज प्रोसेस हैं, उसमें जो ट्रेडिशनल सॉल्वेंट्स हैं जैसे NMP, सल्फोलेन, यानी इनका प्रयोग किया जाता है, और इसके द्वारा BTX जो है मैं बता रहा हूँ जिसकी बेंजीन, टोलिन, जैलिन, इसको निकाला जाता है। इनके स्थान पर बायोबेस सॉल्वेंट्स जो कि इको फ्रेंडली बायोबेस सॉल्वेंट्स हैं, उनके प्रयोग के द्वारा इको फ्रेंडली सॉल्वेंट एक्सट्रैक्शन प्रोसेस को डेवलप करना मेरा एक मुख्य काम है।
तो मतलब आप समझिए कि इंडियन इंस्टीट्यूट ऑफ पेट्रोलियम में जो हमारे रिसर्चर्स हैं, जो स्कॉलर्स हैं, वो किस तरीके से काम करते हैं और जो कि आपके और हमारे स्वास्थ्य का भी ध्यान रखते हैं। यहाँ पर हमारे साथ एक और साथी हैं, क्या नाम है आपका?
मेरा नाम अमृतेश है।
अमृतेश, ये समझना चाहेंगे कि आपका क्या बैकग्राउंड है, मतलब किस फील्ड में आप काम करते हैं?
हम लोग लिग्नो सेल्यूलोज बायोमास पे काम करते हैं। जैसे जो भी बायोमास जो एक्चुअली ये होता है कि लिग्निन जो है वो वर्ल्ड इन्वायरमेंट में सबसे ज़्यादा सेकेंड सबसे पाया जाने वाला सब्सटेंस है। तो हम लोग उससे कोशिश करते हैं बायोचार बनाने का, जिससे वाटर प्यूरिफिकेशन में काम आता है, या फिर बायोफ्यूल बनाने का जो कि बायोफ्यूल जो कि वैल्यू एडिशन में काम आता है।
सामान्य भाषा में कैसे समझ सकते हैं बायोचार होता क्या है?
बायो मीन्स लिविंग, और चार जो हम लोग पायरोलाइसिस मतलब जलाने के बाद जो प्रोडक्ट मिलता है, तो वो मतलब उसमें बस कार्बन रहता है और फिर जो वोलेटाइल मैटर रहते हैं वो भी मतलब डिफ्यूज़ हो जाते हैं, मतलब हवा में चल जाते हैं। तो वही बायोचार है, उससे हम लोग प्यूरिफिकेशन का काम करते हैं, वाटर प्यूरिफिकेशन। और वाटर प्यूरिफिकेशन में अभी इंडिया जैसे अभी बहुत ज़्यादा एडवांस हो गया है, जैसे AMR एंटी माइक्रोबियल रेसिस्टेंस जीन, एंटीबायोटिक्स एज वेल एज मतलब हैवी मेटल्स, आर्सेनिक, ये सब बहुत ज़्यादा वाटर में पाए जाते हैं। तो उसके रिमूवल के लिए काम आता है। और फिर बायोफ्यूल भी इससे बनता है, जो कि बायोफ्यूल जो कि हम लोग ब्लेंड करके इथेनॉल के साथ पेट्रोल और डीजल में मिक्स करके इसको आगे पेट्रोल में यूज कर सकते हैं।
देखिए, क्रूड ऑयल और पेट्रोलियम सेक्टर अपने आप में एक बहुत बड़ा क्षेत्र है, और उसमें उसका जो साइंस है वो बड़ा रोचक भी है, और ये भी हम समझ सकते हैं कि हमारे देश में जो शोध के स्तर पर काम हो रहा है वो किस स्तर का हो रहा है, ये भी महत्वपूर्ण है। इन सब के बीच में आपसे ये जानना चाहेंगे हम कि हाइड्रोजन पावर्ड व्हीकल्स के लिए हाइड्रोजन का स्टोरेज वो कितना इंपॉर्टेंट रोल प्ले करता है और इसका प्रोसेस क्या है?
स्टोरेज ऑफ हाइड्रोजन टैंक है, वो या तो गैसियस फॉर्म में हाइड्रोजन रख पाते हैं या लिक्विड फॉर्म में। अभी तक ऐसा कोई काम नहीं हुआ है कि हाइड्रोजन को हम सॉलिड फॉर्म में भी स्टोर कर सकें। IIP के अंडर सीनियर साइंटिस्ट डॉक्टर शैलेश सिंह सर का रिसर्च ग्रुप है, वो इंडिया में पहली बार है कि इसके ऊपर यहाँ पे काम हो रहा है, मतलब हाइड्रोजन को हम सॉलिड फॉर्म में भी स्टोर कर सकें यूजिंग हाई एंट्रोपी एलॉय, जो कि एक खास तौर के एलॉयज़ हैं। तो सर इसमें क्या है, हाइड्रोजन की डेंसिटी जो है घनत्व बहुत कम होता है। हाइड्रोजन की डेंसिटी अगर मैं बताऊं आपको तो 0.1 kg पर मीटर क्यूब है। मतलब आप ये मानिए कि 1 मीटर क्यूब वॉल्यूम में केवल 100 ग्राम हाइड्रोजन आएगी। बाकी हम उसको अगर कंप्रेस करना चाहेंगे तो 700 बार प्रेशर तक कंप्रेस करना पड़ेगा। अगर हम लिक्विड या फिर गैसियस फॉर्म में हाइड्रोजन को स्टोर करना चाह रहे हैं तो सर इतने हाई प्रेशर पे स्टोर करना बहुत ही एक डिफ़िकल्ट टास्क है और बहुत ही सेफ्टी इश्यूज़ को ये सेफ्टी इशू के लिए भी बहुत बड़ा चैलेंज है। तो सर इसका एक तो यहाँ पे सॉलिड फॉर्म में स्टोर करने का काम हो रहा है हाइड्रोजन को, उससे फ्यूल टैंक से कैसे इलेक्ट्रिसिटी बनेगी उसके पीछे की पूरी केमिस्ट्री है, और फिर व्हीकल कैसे बन पाती है, व्हीकल कैसे मूव होगी हाइड्रोजन से यूजिंग दैट हाइड्रोजन इन सॉलिड फॉर्म।
बहुत बड़े स्तर पर काम लगातार जारी है, लेकिन इन सब के साथ साथ सरकार भी कई स्तर पर प्रयास कर रही है। और इसका एक आंकड़े का जिक्र यहाँ पर मैं ज़रूर करना चाहूँगा कि वर्ष 2025 से 2030 तक पेट्रोलियम के साथ 20% एथेनॉल मिश्रण का लक्ष्य को आगे बढ़ाने की नीति पर सरकार ने फैसला लिया है और इसको मंजूरी दे दी है। मैं समझना चाहूँगा कि क्या लाभ इससे होगा।
हमारा जो क्रूड ऑयल है वो फॉसिल फ्यूल से निकलता है और हम अगर 100% इस चीज़ को यूज़ करेंगे तो ये हमारा ख़त्म हो जाएगा। तो अगर हम 20% उसको एथेनॉल को अगर हम यूज़ करेंगे तो उससे क्या होगा, हमारा कंजप्शन कम होगा क्रूड ऑयल का। और हमारे जो ऑयल मिनिस्टर हैं वो क्या कर रहे हैं, इसको उन्होंने कहा है कि हम 50% अगर एथेनॉल को अगर हम यूज़ करेंगे पेट्रोल में तो हमारा क्रूड ऑयल का कंजप्शन कम होगा, प्लस हमारी एनर्जी कम लगेगी। तो ये हमारे अल्टरनेटिव्स टेक्निक्स हैं जो हम डे बाय डे इस चीज़ को इंक्रीज़ कर रहे हैं।
इथेनॉल है अप टू 2030 तक 20% ब्लेंडिंग के लिए बोला गया है कि पेट्रोल में उसका ब्लेंडिंग होना चाहिए। इसको हम बहुत सारे अदर एप्लीकेशंस के लिए भी यूज़ कर सकते हैं, ठीक है। लाइक हम पावर जनरेशन में हम बायोमास को यूज़ कर सकते हैं, जैसे अभी बताया उन्होंने वाटर ट्रीटमेंट के लिए हम बायोमास को यूज़ कर सकते हैं। अदर देन दिस कि और सारी ऐसी इंडस्ट्रीज़ है जैसे पेंट इंडस्ट्रीज़ होगी तो वहाँ पे हम जो बायोमास के थ्रू ऑयल प्रोड्यूस कर सकते हैं उसमें भी उसका बहुत सारा एप्लीकेशंस है।
2023 तक लगभग 5000 कंप्रेस्ड बायोगैस संयंत्र स्थापित करने की सरकार की कोशिश है। क्या फ़ायदा होगा इससे?
जैसा कि हम जान सकते हैं हमारा बायोगैस जो कि मेनली मीथेन गैस होती है, तो मीथेन एक हमारा बहुत ही अच्छा सोर्स है एनर्जी का। और बायोगैस जो है हमारे देश में बहुत ही भारी मात्रा में उपलब्ध है। जैसे कि हमारा रेलवे स्टेशन, एयरपोर्ट, वहाँ के जो टॉयलेट्स हैं उनको यूज़ करके हम बायोगैस बना सकते हैं।
पेट्रोल और क्रूड ऑयल एक सीमित मात्रा में पूरी दुनिया के पास है, और ऐसे में क्या विकल्प भारत के पास हैं और किस तरीके से हम काम कर रहे हैं उन विकल्पों पर?
हाँ, अभी जैसे कि हम फॉसिल फ्यूल्स पे डिपेंडेंट हैं तो हम उसकी बजाय हम रिन्यूएबल फीड स्टॉक्स यूज़ कर सकते हैं, जैसे कि शुगर केन बगास होता है, कॉर्न कॉब होता है। इनको यूज़ करके हम बहुत सारे ऑयल्स फ्यूल्स बना सकते हैं। जैसे कि मैं तो माइक्रो ऑर्गेनिजम्स पे काम करती हूँ तो हम इनको एज अ फीड स्टॉक यूज़ करते हैं कार्बन सोर्स की तरह, और फिर हम बहुत सारे केमिकल्स और ऑयल्स बनाते हैं। जिसमें मैं काम करती हूँ ऑलरेडी एक ओलिजिनस ईस्ट है, मतलब जो ऑयल बनाता है ऑलरेडी ये ऑयल प्रोड्यूस करता है। तो अगर हम इन जो भी हमारे वेस्ट प्रोडक्ट हैं वो भी एक वेस्ट ही है उनके लिए, जो भी एग्रीकल्चर वेस्ट होता है उसको एज अ कार्बन सोर्स यूज़ करके हम भी इससे ऑयल प्रोड्यूस कर सकते हैं।
जो पेट्रोकेमिकल्स हैं मतलब उनका जो प्रोसेस्ड प्रोडक्ट है वो किस तरीके से उसमें स्कोप है अब, और किस तरीके से उस पर काम हो रहा है?
देखिए, पेट्रोकेमिकल के जो प्रोसेस्ड प्रोडक्ट्स निकलते हैं मेनली क्रूड रिफाइनरीज़ के बाई प्रोडक्ट्स हो या फिर एक्चुअली तो जो प्रोसेस्ड प्रोडक्ट्स हैं वो तो कमर्शियलाइज्ड होते हैं, पर मेनली जो इश्यूज़ होते हैं वो बाई प्रोडक्ट्स के साथ होते हैं जो वेस्ट निकलते हैं। और हमारे देश में अभी बड़ी समस्या हमारे पास ये है कि जो एडवांस टेक्नोलॉजीज़ चाहिए वो जितने कॉस्ट पे आते हैं वो हमारे पास रेडिली अवेलेबल नहीं हो पाते हैं। जहाँ पे वो प्रोसेसिंग के यूटिलाइजेबल मटेरियल निकल रहे हैं वहाँ पे वो टेक्नोलॉजी अभी अवेलेबल नहीं है। और जिस जगह पे हमारे यहाँ पे वो समस्या है कि जहाँ वो वेस्ट जनरेट हो रहा है ट्रीटमेंट की फैसिलिटी वहाँ नहीं है, पर जहाँ पर फैसिलिटी है वहाँ तक वेस्ट को पहुँचाना बड़ा मुश्किल हो रहा है।
क्रूड ऑयल और पेट्रोलियम जितने भी प्रोडक्ट्स हैं उन पर रिसर्च के अपने अलग अलग तरीके हैं, और उन तरीकों को समझना भी यहाँ पर बहुत ज़रूरी है। और यदि हम अलग अलग तरीकों को समझने की बात कर रहे हैं तो जैसे अल्टरनेटिव फ्यूल की यहाँ पर बात हुई, बायोगैस फ्यूल के बारे में हमने बात की। जब हम बात करते हैं कि हम कैसे इको फ्रेंडली और एनवायरमेंटल फ्रेंडली हम फ्यूल हम तैयार कर सकें, तो आपको लगता है कि हमारे यहाँ पर जो उस पर जो काम हो रहा है वो एक सही डायरेक्शन में है और उससे हम बेटर फ्यूचर एक्सपेक्ट कर सकते हैं?
हमारा जो क्रूड ऑयल है उसे हम पहले रिफ़ाइन करना पड़ता है, उसके बाद हम उसे यूज़ कर सकते हैं। तो ये जो प्रोसेस होती है ये डिस्टिलेशन के थ्रू की जाती है, पर डिस्टिलेशन जो है वो बहुत एनर्जी इंटेंसिव प्रोसेस है, तो हमें कोई ऐसा अल्टरनेटिव ढूंढना है जो डिस्टिलेशन को रिप्लेस कर सके। तो हम जो यहाँ पर काम कर रहे हैं बेसिकली वो एडजॉर्प्टिव सेपरेशन पर डिपेंडेंट है, यानी हम एक एडजॉर्बेंट का यूज़ करते हैं और जो ये एडजॉर्प्टिव सेपरेशन प्रोसेस है ये डिस्टिलेशन के कंपेरिजन में एनर्जी भी कम यूज़ करती है और एक ग्रीन टेक्नोलॉजी है। तो एक अच्छा अल्टरनेटिव हो सकता है हमारे फ्यूचर के लिए, क्योंकि हमें ये एक बहुत बड़ा सेपरेशन जो है वो पेट्रोलियम में बहुत बड़ा उसका योगदान रहता है, हमें बहुत ज़रूरी चाहिए। तो हम ग्रीन टेक्नोलॉजी में हम डिस्टिलेशन के बदले अगर एडजॉर्प्टिव सेपरेशन को डालें तो ये बहुत अच्छा अल्टरनेटिव हो सकता है इसका।
जो लेबोरेटरी में रिसर्च का जो प्रोसेस है वो कैसे हमारे इम्प्लीमेंटेशन को आसान बनाता है?
इंडिया अलोन, मतलब अकेले इंडिया 10 मीट्रिक टन के अराउंड वेस्ट प्लास्टिक को जनरेट करता है हर साल, जिसमें से हाफ तो रिसाइकिल हो जाता है और हाफ ऐसी अनकलेक्टेड रहता है एनवायरनमेंट में, जो कि हार्मफुल है। इसके लिए हम क्या कर सकते हैं, केमिकल रिसाइकलिंग हम यूज़ कर सकते हैं, जिसमें कि पायरोलिसिस एक प्रोसेस होती है। इसमें क्या होता है, जनरली हाई टेम्परेचर हम देते हैं प्लास्टिक को और जो वेपर के फॉर्म में कन्वर्ट हो जाता है, जिसे हम कंडेंस करके एज अ लिक्विड हम ऑयल मतलब प्राप्त करते हैं और गैसेस हम यूज़ कर सकते हैं। जो बाई प्रोडक्ट होता है, गैसेस होती हैं 4 होती हैं और जो मेनली हमारा होता है वो लिक्विड होता है। जो इसमें से गैसेस निकलती हैं उसका हम फर्दर यूज़ कर सकते हैं, उसमें मीथेन, हाइड्रोजन वगैरह होते हैं, तो उसे हम प्लांट चलाने के लिए दोबारा यूज़ कर सकते हैं। जो प्लास्टिक से जो ऑयल निकलता है उससे हम एज अ केमिकल फीड स्टॉक जैसे कि ओलेफिन, बेंजीन, टॉलविन, ज़ाइलिन हम यूज़ कर सकते हैं और एज अ फ्यूल हम यूज़ कर सकते हैं विद हाई ऑक्टेन नंबर।
अलग अलग पहलुओं पर हम बात कर रहे हैं, तो उसमें ये भी समझना ज़रूरी है कि जो रिसर्च टेक्निक है और जो लेबोरेटरी की टेक्निक्स हैं उसमें हम बदलती तकनीक के साथ में हम हर दिन उसमें नया एक सुधार देख रहे हैं। मैं आपसे समझना चाहूँगा कि कैसे जो लेबोरेटरी की टेक्निक्स है वो वर्ल्ड क्लास इंटरनेशनल लेवल की यदि हम बात करें तो उसकी तुलना में हमारे पास में जो संसाधन है, हमारे पास में जो सिस्टम है वो कैसा है? मतलब वो लेटेस्ट टेक्नोलॉजी हम यूज़ कर पा रहे हैं, नहीं कर पा रहे हैं, उस पर काम हो रहा है, उस पर क्या कहेंगे?
जी सर, हम कर रहे हैं। जैसे मेरा बायोमास कन्वर्जन एरिया है तो वहाँ पे जो भी लेटेस्ट टेक्नोलॉजीज़ हैं, है ना, कैसे हम बायोमास को फर्दर बायोफ्यूल्स में कन्वर्ट कर सकते हैं या फिर प्लेटफॉर्म केमिकल्स में, वैल्यू एडिड केमिकल्स में कन्वर्ट कर सकते हैं, तो वो सारी टेक्नोलॉजीज़ हमारे पास उपलब्ध हैं यहाँ पे। तो जैसे मेरा जो है काम वो क्या है, बायोमास से जैसे कोई भी हम सपोज इथेनॉल ब्लेंडिंग की बात करते हैं, है ना, जब तो जो शुगर केन बगास से है वो मोस्टली यूज़ हो रहा है, तो उससे क्या होता है वो इथेनॉल बना रहे हैं, बट जो वेस्ट प्रोडक्ट क्या रह जाता है हमारा लिग्निन, क्योंकि लिग्निन क्या है, एक एरोमेटिक पॉलीमर है, तो वो एज अ वेस्ट है, बट उससे भी हम क्या कर सकते हैं, वैल्यू एडिड प्रोडक्ट्स बना सकते हैं। सारी की सारी टेक्नोलॉजी जो भी लेटेस्ट हैं हमारे पास उपलब्ध हैं, सारी की सारी IIP में।
तो प्लास्टिक वेस्ट मैनेजमेंट से लेकर हाइड्रोजन ग्रीन क्लीन फ्यूल तक इंडियन इंस्टीट्यूट ऑफ पेट्रोलियम के इन स्कॉलर से बात करने के बाद जिस तरीके से इन सभी क्षेत्रों में काम हो रहा है, हम ये कह सकते हैं कि हमारे देश का भविष्य सुरक्षित हाथों में है। लेकिन जिम्मेदार नागरिक होने के नाते हम सभी की जिम्मेदारी है कि क्रूड ऑयल और पेट्रोलियम का हम सही रूप में, सही तरीके से इस्तेमाल कर सकें, जिससे कि भविष्य के भारत के लिए भी हम कुछ बचा कर रख सकें और प्रकृति और पर्यावरण को भी हम फ़ायदा पहुंचा सकें। इसी के साथ न्यू इंडिया डिबेट की इस चर्चा को यहीं विराम देते हैं। आप न्यू इंडिया डिबेट के इस एपिसोड को संसद टीवी के YouTube चैनल पर भी देख सकते हैं। नमस्कार।
This simple looking but unique machine is CSIR Indian Institute of Petroleum's room temperature biodiesel unit. In this, without heating, we can make biodiesel from simple and readily available materials like used cooking oil from our kitchens or tree-borne oils taken from locally available trees like jatropha, karanjia, sal, mahua and others. To this we add methanol and some proprietary chemicals of CSIR-IIP. Put it into this, simply give it a short stir, and then we allow the layers to separate. The bottom layer is glycerine, which is useful for cosmetics and pharmaceuticals, and the top layer is biodiesel. And this is so simple that it can be operated in every village. We are calling this Gaon Gaon mein Biodiesel. Biodiesel in every village, and we hope it will reach the far corners of India in the months to come.
We have also developed a small 5-liter unit which can be used in rural areas. As you can see, after 4 to 5 hours of reaction, 2 layers get separated. Upper layer is the biodiesel layer and lower layer is glycerol layer. The upper layer can be used directly into the gensets and the other agricultural machineries with up to 20% blending into the diesel, and this glycerol layer can be used in pharmaceutical industry and soap making industry. So basically this is a hand driven unit which can be mixed like this, but it can also be mounted on a bicycle and it can be used to cover daily needs of biodiesel or diesel of farmers in the rural area.
As per our directors regarding our room temperature mobile unit, अभी हमारे पास लगभग 20 से 22 मिलियन टन यूज कुकिंग ऑयल की खपत होती है इंडिया में, और उसमें से हम खाली 2 से 3 मिलियन टन यूसीओ भी कलेक्ट कर पाएँ और उसे बायोडीजल में कन्वर्ट कर पाएँ, तो हम बहुत लॉट ऑफ वी कैन से लॉट ऑफ एक्सचेंज फॉरेन एक्सचेंज. एंड अपार्ट फ्रॉम दैट रूको मिशन, regarding RUCO mission, we are able to collect only 1.2 million ton of UCO for the conversion of biodiesel. As far as our demo of room temperature biodiesel process is concerned, right now we are able to convert 90% of UCO into biodiesel depending on the quality of used cooking oil. And as such, we have already tied up with a local NGO for the collection of UCO, and right now we are getting around 1000 liter per month of used cooking oil, which we are getting from more than 15 restaurant, halwais and street shops, and we are trying to expand this for Dehradun nearby region like Rishikesh, Mussoorie, because as such it's a tourist hub. Apart from that, our mission is just to implement this process at the village level, and by March 2021 we are going to install this type of unit around 4 to 5 places, which includes CBD Raipur in Chhattisgarh region, Bundelkhand region in UP, and in Dehradun region through our local aggregator, and one for NCR region. So this is our mission, and we want that our process should reach to help the rural employment of the village people and should boost Indian economy. Thank you.
A 10 meter cube per day capacity biogas plant was installed at CSIR-IIP campus. To construct this biogas plant, initially a 12 feet into 12 feet into 12 feet pit was dug. The base of this pit was cemented with concrete. After this, the body of biogas plant was constructed, which was a 6 feet diameter well over which other parts of biogas plant like angle frame and gas holder were installed. All these parts were fabricated at CSIR-IIP itself. This biogas plant has hydraulic retention time of about 30 to 35 days, and up to 8% of total solids in the feed can be utilized. Biomethanation is a process which is also called as methane fermentation, in which organic material is microbiologically converted under anaerobic conditions to biogas. Domestic biogas plants convert animal manure, human excrement, and potentially other organic materials into small but precious amount of combustible methane gas, which is known as biogas. Biogas can be used in simple gas stoves for cooking and in lamps for basic lighting. However, upgraded biogas can be used as fuel for automobiles and feed for many other value-added chemicals. Besides it, the leftover part after digestion in biogas plant may also be used as wet manure. The biogas generated from this plant is being used for further technical studies, whereas surplus biogas is being supplied to CSIR-IIP staff canteen, where it is being used for making tea and snacks, which therefore is saving considerable amount of LPG being used in canteen. Hence, if we look at the overall economics of this plant, considering financial inputs and outputs in terms of total energy generated equivalent to petroleum based fuels like LPG, then we may easily get a payback period of 3 years, both on fixed and recurring capital investments. That makes it a very cheap source of clean energy. Thank you.
Welcome back. Think about it. An aircraft which runs on the extract of the Jatropha plant. Jatropha oilseed being converted into refined aviation turbine fuel. It's not quite called aviation turbine fuel, but it's essentially green fuel, and it is remarkable that it works. It's there. Yesterday I had a fantastic experience. I was on board a SpiceJet flight, the first flight using a biojet fuel from Dehradun to Delhi. Does this actually work? What does it all mean? I spoke to some of the scientists and some of the engineers and captains of SpiceJet who were behind this.
It looks like any other engine of a turboprop aircraft, but that particular engine on the right wing of this Bombardier Q400 aircraft of SpiceJet has 25% of its fuel fueled by Jatropha seed. The rest, 75%, is aviation turbine fuel. What essentially we are talking about is the future of aviation, of efficient aviation, where biojet fuel can have a real mark, a real impact in India. Well, joining us now, Dr. Anjan Ray. Dr. Ray is somebody who's had a huge role in making this entire process actually take place. Thank you, sir, very much for being with us. 25% Jatropha oil in the right engine, 75% aviation turbine fuel. By having biojet fuel, what are you hoping to achieve?
A quick correction first. It's 25% Jatropha oil derived biojet fuel with 75% ATF in the right engine. What we hope to achieve is that we should be able to show by this flight that it is possible to replace both expensive and imported fossil fuel with homegrown fuel. All the carbon that we need for the fuel needs of India can be found within our own borders. And these small steps will add up, just as biodiesel, ethanol and other initiatives are adding up, to an economy where we will be less and less dependent on the former petroleum economy.
Yeah. And it's much cleaner, that's the bottom line.
It is much cleaner. The sulfur level in the biojet fuel is less than 10 parts per million, whereas in conventional aviation turbine fuel, the specification is 3000 parts per million. So we're releasing much less emission into the upper atmosphere. Also, the greenhouse gas emissions, the carbon footprint, is lower by something like 50 to 80% on a 100% substitution basis. We are substituting by 25%, so we'll be saving 12 to 20% of carbon footprint on this flight.
What about the costs?
The costs are a function of the feedstock cost. Right now, this is being produced by farmers in Chhattisgarh at a relatively small scale, and then converted at a very small scale of 4 liters an hour. When you start converting at a refinery scale, if the feedstock is inexpensive enough, it will be competitive.
All right. And what are some of the challenges in getting this technology, this fuel, to other airlines? Is there a lot of interest?
I think there is a lot of interest. We've seen many airlines attempt to get there in the last few years, but SpiceJet has made it. So I believe.
And the Air Force, I believe, has showed some interest also.
The Air Force has shown a lot of interest. The Air Force Chief of Staff has gone on record to say that he would like to fly an AN-32 transport at the coming Republic Day flypast.
Tell us a little bit, one final question, on the chemistry of the fuel. How are you able to blend it with aviation turbine fuel? What is the quality that the Jatropha seed oil needs to actually exhibit?
the jatropha seed oil needs to be converted to something that looks like, smells like, acts like and performs like ATF, literally what we call a drop-in fuel. For this, we remove all the oxygen from the jatropha seed oil by a process called hydrotreating, and then we rearrange the molecules by a process called isomerization to get the same properties as aviation turbine fuel.
All right, well, Dr. Roy, Dr. A, it sounds tremendously exciting, and let's hope it ultimately works out. For airlines, it'll be a huge, huge saving if the efficiency which you are promising actually works out. 1.8% more efficient than normal engines, right?
Yes, we expect an efficiency of between 1.5 to 2% based on the normal engine performance on a drop-in basis. I would like to credit my team, particularly Dr. Anil Sinha, who led this project, because without getting the quality of product that gives this efficiency, we would not have reached this stage.
And the savings will come through the efficiency because the cost of the fuel itself is still quite expensive, relatively speaking.
Yes, the savings will come not only through the efficiency but also through lower operating and maintenance costs, possibly less filter changes, and as people start getting sensitive to emissions, if emissions start getting priced tomorrow, then this will win hands down.
So why did SpiceJet take the decision to actually try out biojet fuels? Joining us now, Captain Gurcharan Arora, somebody who was instrumental in pursuing what for many was a dream. Thanks very much for speaking to us. Why did you decide to go ahead with this?
Thank you for having me. Our chairman, Mr. Ajay Singh, has created an environment where he encourages us to innovate, think out of the box. And green fuel is something which we've been talking about, researching for the last 9 years. Our research led us to the Indian Institute of Petroleum, where we found that they've actually got a lab which is manufacturing biojet fuel, the only lab that we found at that point in time. So we went and met Dr. Ray, Dr. Anjan Ray. He is extremely enthusiastic and he was very excited about working with us. So the excitement was mutual. So we set up a sort of informal partnership about a year ago, and that led us to communicating a lot, us committing to him that whatever you're manufacturing, we want it. Side by side, we researched how to get it into the airplane, the rule position, the regulations, met the regulator, DGCA. The DGCA was extremely supportive, extremely supportive. So that was a magic combination. Since we had the encouragement from the regulator and we had Dr. Anjan Ray and IIP with us, we encouraged him to manufacture. He manufactured about 400 kgs, which we then put into the right side, which you flew today. Yes. And magic happened.
So a lot of people have been tweeting me and have been asking, did it feel any different from another flight? And the answer obviously was no, it didn't. But people are curious. I mean, does this do anything to the aircraft? How would you respond to basic queries like that?
Right. At the outset, I'd like to say that since I'm not a subject matter expert on the effect of fuel on seals and rubber and sealants, I can only tell you from my research, which is from books. It's a little early to tell. I think we need to keep studying it over a few years. Initial research says there is no serious impact. In fact, we've got Pratt & Whitney, the engine manufacturer, on board with us. We've got Bombardier, the aircraft manufacturer, on board with us. They tell us it's good to go. And so we just want to monitor a specific engine number which we want to keep flying with this kind of fuel over a long period of time, let's say 6 months to a year, and then be able to give an answer.
So 1.8% at least on an average, more greater efficiency.
Absolutely.
As opposed to. So that's because it's cleaner, right?
Yes.
It produces less soot.
It doesn't have that sulfur content which fossil fuel has.
Right. And that enhances efficiency.
Yes, it does.
So in simple terms, it means that you're consuming less fuel and flying more.
Yes.
Now, another question that a lot of people would ask, why have we restricted ourselves today to just 25% of the biojet fuel and not more?
Right. In any program, when you start something new, it's always sensible to be conservative when you start. So our research tells us that worldwide, scientists have encouraged that start with 25% as a good number, build some confidence, and then gradually work up to 50%. And we intend to follow the same route.
And it would be limited ultimately to 50%, with 50% always being made up of aviation turbine fuel.
No, we are actually hopeful that while we do our flying and our research, the world works its way up and the scientists work their way up and we reach a stage where it's 100%.
And that would need engineering changes in the engines of aircraft?
No, it does not. I mean, that's what my research tells me. That's what my speaking with subject matter experts and scientists tell me, that no. But they will keep studying the sealants and the rings. That's their area of concern, and they're the best guys to tell on that. But I do not see any significant changes in the engine technology.
So one final question. I just find this chat fascinating, absolutely. In the future, 25, say 30 years down the road, around the world, if this fuel is accepted in whichever form the biofuel comes from, we could have clean air transportation, which is more efficient, employing any number of people on the ground because they're part of an ecosystem, essentially changing the face of civil aviation and also ensuring that we save huge amounts in terms of foreign exchange and importing fuel.
You've got it just right. Absolutely.
So all
perfect.
of that.
All of that. It's clean. It's more.
That would change our lives. I mean, it would change the quality of living. I mean, if our import bill goes down. So this is more than just aviation, right? It's a larger thing.
It is. It's holistic. It's you're living in a very, very clean, green environment, and you're not pulling anything out of the earth. It's completely renewable. It's from the plants and going back to the plants. I mean, what can be better than that?
Yeah.
All you're producing is carbon dioxide and water.
Right.
And the carbon dioxide is going back into the plants. Water is going back into the atmosphere. It's fantastic.
The sulfur content is a fraction. The nitrogen content has gone down dramatically also. Right?
Absolutely right.
Yeah. This was possibly the cleanest Q400 flight that we've had in India.
Without a doubt.
All right. Thank you so much, Captain. It's been a pleasure speaking to you. Well, there you have it, an idea of what we are looking at. It's not just aviation. It's an ecosystem. It's an ecosystem where we're looking after our environment. People are being transported in a clean manner. Fuel prices are going down. And because of enhanced efficiency, costs are also being reduced for airlines. So it works in many different ways. The key aspect of this is bringing down the per barrel cost of biofuel. If that is done, and that needs a lot of government involvement, refinery involvement, then this could be part of a holistic change which will revolutionize not just aerospace over here in India, but indeed around the world.
Hello, this video presentation is about improved gur bhatti, which is developed by CSIR Indian Institute of Petroleum, Dehradun. Gur and khansari are among the major agro-processing industries found in rural sector of our country. Nearly 50% of total sugarcane produced in the country is used for manufacturing of about 8 million tons of gur, which is known as the most nutritious agent among all sweeteners. Bagasse is charged through a window located at one end of the furnace. No fire grates were used. The other end of the furnace opens into the base of a vertical chimney of rectangular cross section. The cross sectional area gradually reduces from bottom to top. To do this, CSIR-IIP made few changes in the design of conventional gur bhatti. The first major change was inclusion of fire grates under the first pan. With the help of fire grates, complete and proper combustion of bagasse was ensured. The second major change in the design was inclusion of fourth pan, which extracted extra amount of energy from the flue gases which were going waste into the atmosphere. Temperature of sugarcane juice in the fourth pan is around 40 degrees Celsius. Temperature of sugarcane juice in the third pan is around 80 degrees Celsius, and in the first pan where the sugarcane juice gets converted into solid gur, the temperature is around 110 degrees Celsius. While the impurities are removed step by step in all these pans. During initial observation, we found that there is a lot of bagasse consumption in these conventional gur bhattis. To reduce the consumption of bagasse, we at Indian Institute of Petroleum developed this energy efficient good bhattis. We successfully reduced the bagasse consumption by 15%. To do this, we provided fire grades under the furnace. Good making industry is growing day by day. Around 2.5 million people are engaged in this industry, which is a good indicator from employment point of view. There are about 2000 good bhattis which are running only in the northern part. Good has many advantages over sugar. It has very low amount of glucose in it when compared to sugar. For this reason, patients of diabetes may also use it as an alternate source of sweetener. Besides it, good is rich in iron also. CSIR-IIP improved good bhatti is gaining popularity day by day. So far, 34 numbers of such good bhattis have been installed at various locations of Uttar Pradesh and Uttarakhand. CSIR-IP improved good bhatti has many advantages over conventional good bhatti. Therefore, we believe that each and every farmer and rural people involved in this industry should adopt the design of CSIR improved good bhatti for the betterment of their own and for the betterment of society, environment, and of our.
A variety of petrochemicals drive our daily life and development of nation. The lead group comprising plastics and host of other chemicals are downstream hydrocarbons derived from crude oil and natural gas. The value addition
what is actually R&D model. So actually is already touched on the full model. So our idea about that we don't want to keep the lab activities for CSIR and for IIT. We want to do it providing the project. In this regard, we want to make it and all that not much more interested in the business. Not very good for me. So basically, we are highly interested now in you can go from pilot to command. Usually, we are focusing on the pilot already go down whatever. Follow. And we had established but we already get the around are inspired by the companies such as some new products in our in the what and these chemicals by our own
polypropylene is the final product. So intermediate products like propylene, ethylene, and many other, whatever the intermediate products we can produce from our own feedstock, because we want to think about the viability, because we are always interested into the applied research. So the viability is the one option for the HMEL. So in this regard, we want to make our own utilities we have a lot of, because we already are refiners. So we are always thinking about our own feedstock, so at least we can reduce our cost, and then in this regard we want to implement the things. Second is the valorization of the byproducts, which is converted to the high value products, because refinery has a lot of valorization products. So with there we can utilize it and make a different type of new products, new value added products and process. So in this side we are also looking at the bio-based process and technologies, effluent treatment, which is the one of the major challenge for the refiners. So ETP is the one of the major challenge. In a new technology like CO2 capture and utilization technologies, renewable, green, and recycling technology, which is much more thrust, because we are producing the polypropylene, polyethylene. So recycling a certain percentage as per the government rule is coming out. So some percentage of we should be recycle on this side. And lastly and least last but not least, crude to chemicals. So these are some major areas where our work is going on. So in a valorization, we are looking much more faster and much more aggressive way, where because we are lot of valorization stream, we are lot of streams are available in our refinery, which is required high value products. Similarly, like pygas valorization, because a lot of chemicals are available in this stream, and we want to extract these high value chemicals, because the list is very big. Similarly, the petcoke valorization, PFO valorization, because petcoke can be used in the needle coke or electrode and supercapacitors, LCO2 naphthalene, C9 chemicals, C5, C4. So all these are streams which is available in our refinery, and we want to extract the high value products on this side. If the IIP can help on this side, or maybe make some proposal on this side, so where we are happy on this to start the project. Similarly, ETP, effluent and water treatment technologies, also we are looking. We already developed one CLO2 wet gas wet oxidation technologies, and which is already implemented in the refinery, and we are planning to license this to other refineries also. And sustainable recycled technologies, where the SAF commercial viable SAF is we are looking on this side. We are working on this with the different technology licensors, but still we are looking some indigenous technology which can help us to become a more commercial viable SAF. So these are the product stream available for the valorization. Like C4 we have currently we are recycling, C5, C8 we are selling, CBFS, PFO we are selling. So we want to we want to make some high value product from these streams. Similarly, benzene we are selling into the market. So we are looking the benzene derivatives, and there's a high value benzene derivative like nitrobenzene, like low value, high volume. We are not looking. We are looking at the low quantity but high value products in this side, because so the profitability will increase of the refinery. Similarly, the toluene plant, we already extracted the toluene from the pygas, and the plant will be coming out in the very soon. Similarly, mix xylene, ethylene, ethyl benzene, these products is also available. So extraction is also required in this side. Even the quantity is less, but we want to looking in the high value product in this side. So at least we can make a project viable. So these are the streams available for new proposals and new R&D initiatives from the IIP, or maybe other any of the CSIR, because a lot of CSIR and other industries people are also available here. So other research activities in the development of the catalyst and chemical additives, we are already engaged with the HPCL, R&D centers, and some other companies, where we are developing the catalyst, chemicals, new chemicals, niche products, niche chemical products are also looking in this side. Similarly, the more thrust is going on. Crude to chemical is now a very common things, and many people are talking about this. But we are now talking about the digitization, because all the refinery process required a lot of efficiency, because efficiency is very less, because existing refinery process is almost mature. So the more of efficiency is required in this side. So at least we can save the cost. Similarly, the fuel is the one of the major problem for the refinery. We are spending around 10 to 11% fuel losses in the refinery, and maybe 25 to 30 40% in the petrochem. So we want to reduce. If 1 or 2% we can reduce, I think a lot of saving we can save on this side. So if the fuel and energy saving we can do, I think a lot of amount we can save in this refinery side. Not only refinery, all the process. Similarly, we are looking for the renewables and green technologies for, but that all these technologies are not still commercial viable. So our pace is a little bit slow in this side. But we are also exploring all these options. If anybody has a good technology and any good process, then they can share with us. So we are ready to fund for this project. But for evaluating the process of this side. So these are some activities. And what are the challenges what we are facing? And not only the HMEL is facing, maybe all the refineries are facing on this side. So here we require the fuel and energy saving and an improvement in required in the side. So a lot of is any innovation we can do where we can save a lot of money through the fuel and energy saving. That would be the major benefit for the all the refineries. Not only refineries, maybe all the industry, because fuel is one much of major cost cutting, reduce the cash flow of your refinery. So that's why. And development the efficient, cost-effective process by separate, because a lot of separation is required. We have a mixed stream, so required a lot of separation in this side. So if any good separation technique is available, I think it would be work for the HMEL. And the integration of the new technologies, because normally R&D institutes are developing at the pilot scale, and then the going to the pilot to commercial scale is very, the success rate is very slow, very low, or very slow also, both time, in terms of the product quality and product and efficiency of the. So that is the major challenge we are also facing when we are integrating something with the existing process. So a lot of problems challenges are coming out in the set, and a lot of fund will be required in this side. So that also one of the major challenge we are always facing, and facing from long time also. Similarly, the augmentation of the digitization and AL, maybe the new technologies, it can reduce our, it can optimize our process, existing process, maybe the new process that can help us in to solve the problem with the minimal environmental impact, because environment is also one of the major thrust is coming out from the government side, and as an individual also we have to think about how we can reduce the environmental impact from our own operations. Similarly, the development of the new chemicals and biochemicals, because a lot of bio-based chemical process are is under development. But as my belief is that, because controlling mechanism in the bio process is little bit less. So that's why we cannot control the algae, or maybe the microalgae, modified algae. So the production cost, as Mr. Jhala has already mentioned, okay, the feed is changed and the product will change. So similarly, lot of control is required in the biological process. If control is available, then I think this biofield is biochemical process is a very robust process, will be robust process. And the last is the indigenous, because a lot of product is available, lot of chemical we have to identify, but because the technology is available sometimes out of India, and sometimes in India the technologies are not available, and when we are purchasing from outside, the total project viability will go on out, because they are asking a lot of money and a lot of fund is required. So in this regard, many products we cannot launch, or we cannot think about it, because of the indigenous technologies are not available. If the indigenous technology is available, maybe we can make a small quantity, but the product can be viable on this side. So these are some prospects and challenges which we require. If any of the CSIR lab or anybody can help us in this side, so we are most welcome to share the proposal with us, and we are happy to work with him. Thank you. This is my.
Thank you, sir. I would now like to call Dr. Payal Chala, handing over memento to Agnihotra. Coming on to the last invited talks for this session, and I would now like to call Dr. Ravindranath Maiti, who is the Chief General Manager and Head R&D EIL, for his talk on R&D prospects and challenges in petrochemicals, developmental initiatives by EIL.
Good afternoon. Am I audible? Respected Director IIP, Dr. H.S. Beast, and eminent scientist, participants, ladies and gentlemen. I'll be talking on that challenges, that R&D challenges mostly associated with that development work and towards commercializations. My talk will be mostly focused on that. Other than that, I'll be mentioning that in petrochemicals area, some initiative taken by EIL and doing work. So for that, a little bit 1 or 2 minutes background on that EIL, very specific, with related to R&D model, just to make the background of that what sort of R&D model is there we are working. So EIL, it's India's leading engineering consultancy and EPC Navaratna company, you know, that it established in 1965, but in 1967 it becomes wholly owned that government company. We have our R&D facilities at Gurgaon, and we have our over more than 7,000 assignments EIL has done, project worth of over $200 billion, that much of project executed, with an international presence in Middle East, Africa, South Asia, Central Asia. Now, what sort of work EIL do? Okay. So this is the stages. All the stages means starting from that. If you have the licensed technology or say in-house technology, but the stages to go for that commercial implementation or design. That process design, we have process design department. We do the process design, pre-feasibility, DFR, conceptual design, process design package. Then comes that engineering, residual engineering, detail engineering. This is relevant because in development stage one, BEDP preparations stage will come. So little bit I want to throw light on that. Then procurement, then comes with constructions, then commissioning, PGTR. They are also the safety audit. During that detail engineering, hazard study, that is the very 40 process technology. Some of our own, starting from the conceptualizations, some with the collaborators. We have live patents around 85, but more than 70% of that patent are commercialized. So that is our strength. We have technology collaborations with IOCL, BPCL, IIP, INCL, that is, and that DBT ICT also. And right side that the area of work that I am not going to that. Now during why this success rate of say more than 70% patents is commercialized? Because once the technology is conceptualized, we go all the trail of that steps. The TRL level, you know, I am not going to the TRL. Some configuration study we did, a lot of configuration studies we have given the recommendations. Here also the crude to chemicals comes in, because based on that inside products, feedback, control, lot of permutation combinations will be there. Based on that refinery specific, the study is very specific. because based on that, all generic solution is not there. Then supplementing cleaner energy, it is generic, not related to only petrochemicals. In other area also, some initiatives, just to highlight it. CO2 capture, I mentioned that utilization area. We have also some, with GALE, we have utilized the captured CO2, maintaining the pH in that pH solutions, that pH maintaining. And CO2 capture area, I highlighted. CO2 utilization is also highlighted. We have started also CO2 to DME, that we have initiated it, catalyst development, because this is in parallel, everywhere is going on, but still to be touched with the industrial target. Energy efficiency improvement, we have done a lot of studies for the refineries, and we also doing that baseline studies for petrochemicals also. A lot of recommendations we provided, and they are being implemented also. Then energy, that's petrochemical benchmarking. What is the benefit? Benchmarking is recognized as an effective approach towards improvement in productivity, quality, other dimensions of performance that are determinants for competitiveness. This is the one point I want to highlight only. This is the strength we have. Why do we are in that petrochemical benchmarking business? Because we are involved in setting up of more than 10 mega petrochemical plants. We have handled variety of feedstock. Then units also we have handled, starting from crackers, associated units, all the units that listed we have handled. We have handled with the various licensor data, conducted baseline audit. So that large data bank also with us. So we are much more comfortable and strengthy to provide these benchmarking solutions to petrochemical complex. Now this is that integration, some RFCC based, some is hydrocracker based, that integration is there. Mostly it is generic, and a lot of talks are going on integrations. This is one sort of integrations also we have studied, one sort of configurations. We come out with all that detailed data after that configuration study. What will be the profit, and what will be the materials development, what will be the product development. There are challenges also, COTC. It's not easy to go. Some of the that challenges what we are foreseeing. There may be massive shift from refining to petrochemicals, can result in over investment and over capacity, which may erode the petrochemical margins. And impact on growth due to ban on single use of plastic, and increase in reusability and recyclability of the plastics, or due to say mega complex coming up globally, producing petrochemicals for exports may not be competitive. Implications on global demand for refinery fuels, that also one factor. And this is only green hydrogen area. We are giving consultancy service. We are doing PMC service also. We have done. We have prepared a lot of DFRs. We have done also conceptual study for green hydrogen implementations on various refineries and various places. We are developing one technology, because that green hydrogen, that electrolyzer based technology will come, but when we are executing that the deoxo reactor comes in line, but that is also as a licensed technology, as a package item it comes, but indigenously we have tried to develop that, so that balance of the part we can do. That is called deoxo reactor technology. That catalyst already we have developed, tested in our. We have also our pilot reactor in our R&D centers. But for the development, we follow all the stages. So doing that scale up designs, so a lot of experience we have got. Sometimes what I told, that 4 steps of development is required for that commercializations. Even based on experience, starting from the first level, second level, also we have designed that is working. That depends on complexity of your problem. This is one that we are doing it, the concentrated solar thermal for steam generations, but now we are modifying it for crude, to supplying the heat to the crude heating. This is one for information. So we are setting up one plant in our R&D center also, that starting from the biogas to value-added chemicals, that is starting from the horticulture, the biogas will be generated, we will capture it, and that methane as that gas as a product, and then captured CO2 will be converted to biofuels, and that methanol, ethanol, and that chemical route. So one will be the algae route based, and another will be the chemical that catalyst.
Population of the India electrical vehicle is also drastic, particularly if you see that European country, they are in the reach in the maximum. Then USA, Japan, China, of course we are in the below that all this whatever in the listed here. So this is also actually forcing us, we have to think that minimum use of the fossil fuel as a transportation, and we have to change that whatever is the crude coming from this, and we have to change in the petrochemical. This is another thrust that why actually refinery thinking to change the fossil fuel as a transportation to the petrochemical. Even if we see also that scenario, percentage of, now when we talked about the chemicals, now in 2000, you see China global actually percentage in the chemical is only 6%. Within 17 years, they go up to 6% to 37%. There is a huge change of the production of the chemicals. So now almost all the universe is depend on the Chinese productions. For example, if I give one example, now also our demand of this particularly pharmaceutical medicines, we have huge that export. But all these molecules, even more than 99% molecules come from the China. This is called API. So if tomorrow something's happened and China stop providing the molecules which produce the medicine, then we will be great problems. So of course that competition, the production of the chemicals in the compared to the China, we nowhere stand, particularly when we think about the cost competitiveness. They are so cheap that we cannot actually compete. But sometimes we have to think that our Atmanirbhar. So in that respect also, we have to think that how actually chemical production we can increase. Not only always think that cost competitiveness, even it has to be a thing in the directions of this, that Atmanirbhar. Of course, that production of this chemical with respect to actually red color, with respect to the years, of course we are growing slowly. I mean 3.2%, I think, 1.8% to 2.9%. Even as you remember also in the our central government also announced that PL scheme, that product link incentive. In this product link incentive, actually government of India decided at least 500 molecules should be actually synthesized in India itself. But that initiative also government give CO2. So how to actually mitigate that CO2 emissions? So with this, I invite all these panelists, please come here in the dais and we can discuss. So, your director, sir. R.N. Maiti, please. Bharat, Dr. Bharat, please come here. And Dr. Jhala and HML, Agnihotri, please. So in this actually open discussion, I will start first with this Jhala, because I am choosing Jhala first because with this PSU, actually we have actually great example that they have gas cracker, naphtha cracker, they have lot of produce, lot of actually petrochemical feedstock. Not only that, they have also aromatization integration. So this is the actually best example to start that how actually we can proceed when we talked about the crude to chemicals.
Yeah. Thank you, Mati sir. Definitely, you open an important question of the day, how to use this. And definitely opportunity crude oil is a very typical chapter. What we have faced in the last 3-4 years, complete crude oil, the business of crude oil, what crude oil refinery can get is one of the agenda point of geopolitical scenarios. Sometimes refineries choosing of crude oil is not up to the actually hand in the crude oil. Lot of depend upon the how the Indian relations with other countries and what geopolitical supporting. So opportunity crude oil is something. I can say it is a negative part. Sometimes we are getting less opportunity crude based on the refinery. But definitely bio oil or pyrolysis oil, I can say, because last couple of days, recently I have visited one of the plant also of the which produce this pyrolysis oil of municipal solid waste. But definitely, sir, this is a good way. Whatever the bio oil we can produce, bio naphtha, bio oil, it can be directly feed into the naphtha cracker systems, and we can also get the carbon credit. Some of the literature I have reviewed, people are using this slight quantity of bio naphtha, 5 to 10% in the naphtha pool, then crack it, and then 5 to 10% they are giving this opportunity to their polymers also, biopolymers. And it's a big companies sometimes giving some carbon credits also, utilizing of 2% of biodiesel. Synthetic diesel also people are started, other than biodiesel, using this pyrolysis. First they are preparing pyrolysis crude oil, and after pyrolysis crude oil distillation they are preparing synthetic diesel. So definitely this is a good route as per me from in India, because pyrolysis crude oil can be can be done in a very small type of reactors also, and that crude oil can be taken by big refiners, and then we can blend it in their 1%, 2%, their complete crude oil. Then ultimately this system is in the process. So I think this is one of the viable, because already you have covered in your presentation also, there is a very big investment when we think about crude chemical directly, and all the big licensors having their own technologies, and there is a very tough task for anybody to identify what are the best technology. Every technology is having some benefits, some advantage, and sometimes it is also risk of the shifting of business also. You are producing one chemical and probably this chemical is a lot of availability, dumping, and probably you are not having good market also. Thank you.
Yeah. When we just talk freely, particularly during the discussion, I have the 2-3 questions. Maybe I will cross-check with you. In the meantime, I just asked that HML, and they have, of course, they are another example. Particularly, they have DCC. They are DCC actually running for a long time. Particularly, you can say that in higher conversion of the FCC. And not only that, recent time also they have actually put their gas cracker, naphtha cracker, and gas scraper in capacity, if I am not capacity, and 1.2 million metric ton ethylene production. So they are also in the good example. So how actually we think that this particularly opportunity crude and that bio oil and pyrolysis, and can we cope up with this here existing refinery configuration?
Yeah, HML is already putting a multi-feed cracker for this existing petrochemical 1.2 TPA plant. And bio oil is really one of the good opportunity. Like in a UK, if you know, Neste has already pivot from a normal refinery to bio. And India has a lot of biomass and other things also. So if we can convert our biomass, or maybe whatever the biological process, through biological process, we can convert if 1 or 2% of the total imported crude, which we can convert into our bio crude and we can supply. So our dependency will go down with the global market, because as you know, geopolitical situations, the crude prices is very volatile, and this is a lot of in currency also going from India as this one. So bio oil is really a good option. But the feasibility of bio oil is what I am seeing in the near future, maybe in a couple of years or 5 or 10 years, it is not maybe viable. So that's why our refineries are capable for converting whatever the feed we are getting from bio oil also.
So first we have checked the viability ke bio oil is equivalent to whatever the crude we are because HML is refining heavy crude also, because we have a very complex high Nelson index refinery. So we are processing heavy crude, not very heavy, but in the meantime of 25 to 30, 31, 32 APIs crude we are processing. So in this side, bio oil is a good opportunity, but the viability should be there. We have to check on this side that this much bio oil should be available in India. Again, we are importing from outside. I don't think so it is a good option. If we are again importing from outside India, like Neste or some other companies are providing us the crude, this is not the good option for in terms of me, because we have to change a lot of, because bio oil should not be the same assay like a crude what we are already processing. But we can check on this side, but if it is indigenous produced in India, then I think we can immediately accept it, all these things.
Particularly in this way, I want to add, because we have already presented at this moment around 84 to 85% actually crude we import. Actually, our interest is that if we replace our indigenous, particularly bio oil and pyrolysis oil, which may be in coming 4-5 years will coming, so that can actually import substitute. So we are not actually thinking to import bio oil or pyrolysis oil outside. We have to think our own actually feedstock. So in that direction actually we are proceeding.
If it is available in India and we can match our whatever the assay of crude we are processing, if it is nearby or maybe little bit deviation on that also, so I think HML will be open on this side to process the biofuel, and HML should also open for pivoting from crude to biorefinery also. This is my personal belief. This is I'm not talking about the company side, but all the refiners should think about it, how we can switch from the conventional crude to the bio crude if it is possible for us.
Yeah, we will come with the round talk. Now I go to this BPCL, because this is also R&D, and not only that, they have also refinery. You talked about the lot of actually how actually CO2, because in my slides also I just mentioned that mitigation of the CO2. So how actually, what we'll do with this mitigation of the CO2, and what you think that there is a lot of opportunity may have actually, as you know that the conversion of the CO2 is not a easy task, because it is due to the very high stability. So what is your thought?
Yeah, first of all, this topic of crude to chemicals, CTC, the cost to company. So if you look at the processing of this crude to chemicals pathway and going for CO2, already we are struggling with CO2. And as of now, today, except sequestration, there is no solution. There is absolutely no solution. Methanol production is there, but that is also not so attractive enough, because the import is so cheap that nobody is going to buy methanol from CO2 to methanol. So unless until refiners have upstream operations wherein they can go for some kind of sequestration options in India, to maybe to tie up with ONGC, people like ONGC, OIL, who can uptake our CO2 and carry out some pilot studies first. Maybe we can rope in Schlumberger, other people who are expert in this area, and look at the feasibility of going for pumping this CO2 in dry wells, and look at extracting oil from that. That could be one of the options we could foresee right now. But as a CO2 to utilization point of view, it is a very, very big challenge, and it's a challenge to the entire scientific community to go for a real solution which is really workable, doable, scalable, and sustainable. So this is my sincere submission. It is not that I can talk of things and go away, but there is a sincere submission that there is no solution.
No, as I directors mentioned that today's scenario,
Yeah.
maybe that methanol production in syngas is much cheaper than from
Yeah.
the CO2.
Yeah.
It is no doubt, it is everybody can understand. But as I mentioned, that if tomorrow and some government just put it the CO2 emission that some tax, so you have to pay tax according to the production.
Only
So that times it will be, it has to be, there is no alternative, I think so. What is
in that case, we'll have to look for the products which are going to fetch more value than the CO2 conversion value. What we are going to input has to be less than output. So you can try, we can foresee a program for CO2 to SAF. That kind of fuel, if you can target, which can give us more returns than what investments are, it will be more sustainable. And I would urge that if you can start with this program of CO2 to SAF conversion, rather than looking into oil to SAF or alcohol to SAF, because these two feedstocks are not going to be viable and sustainable in Indian context. To look at alcohol to jet alcohol is a political fuel, according to me, and oil to oil मिलता नहीं है. Oil is we are struggling with oil. ECO to oil, ECO to.
Yeah, it is our best friend because hand to hand we have actually, not only that, whatever actually IIP show today, that whatever we do research, actually your field is must, because after all, as you mentioned, as a scientist, we can proof of concept, we can pass through, and we can also up to 100 grams of catalyst we can test our in laboratory, and we can easily actually reach up to TRL level 4 and 5, and after that actually we stuck somewhere, and at this stage actually EIL help which is required. So of course we are doing lot of research work to chemicals, and in near future also we need your help, and particularly as you know that we are also doing dry reforming. Of course you can share also your particularly experience, your Nagothane, that EIL put their plant, and you have a lot of experience with that, and even our of course CO2 mitigation we have doing lot of work, even separation also we are doing. So what your actually idea, and how can we proceed, particularly when we talk to C2C?
Now, before answering all these questions, one general thought process: cost. Normally, that when technology being developed, that time we also parallelly talk about that cost viability. But more appropriate will be there first to establish the technology. It may be, say, suppose if we take one example, just methanol, you are telling, say, 17% conversion, 20% conversions. So cost that if it is 70%, after that if it reaches, say, 30%, okay, so 70% we may have to recycle. So cost actually, if you prepare DFR based on that 70% also, so you have a solid number to talk. Otherwise, negotiate, इसको बढ़ाऊं, उसको घटाऊं. Normally we have seen, क्योंकि sometimes some pro rata basis, something proportionate we normally gauge and try to take the decisions, but there is a gray area. Clear cut decision doesn't comes. तो इसलिए कि whatever the technology being developed, conceptual proof, after that one, this is my thought, that after that one DFR should be there. And DFR करने का वो जो है, जैसे EIL also is there, क्योंकि that we already explained कि different stages we take care. At least some pro rata basis में, without going detailed studies, also the DFR can be prepared. So you will have a database, one hand. Based on that, you can manipulate your technology directions. Catalyst को हम बढ़ाते 10 साल बिताएंगे, नहीं कि जो whatever is coming, marginal development में मेरा economics आता है, वो नंबर हमको पता नहीं चलता है, क्योंकि एक DFR और हेज ऑफ स्टडी इसमें ना पूरा क्लैरिटी आ जाता है वेयर वी आर, बट वो कॉस्टली अफेयर होता है, एंड उतना एक्सपर्टाइज भी सबके पास नहीं है. अभी कॉम्पिटिटिव आ रहा है, पहले EIL था, anybody comes also, they also will be taken. I am telling in a general way. Actually, that is the steps to be taken care to judge the technology, ये viable है कि नहीं viable. क्योंकि एक मीटिंग में हमने पार्टिसिपेट किया था कोई हाई लेवल में, वहाँ पे तो वेरी सीनियर लेवल पे वो कॉस्ट के बारे में आते ही इतना गुस्सा आया, वो बोलते ऑल दोज आर मैनिपुलेटिंग विद द कॉस्ट, प्लीज गेट आउट, come with the proper cost, then talk about the technological viability. First you prove your technology, pros and cons. Don't think about the viability. After that immediately you do one DFR sort of, इतना risk तो लेना ही पड़ेगा. Otherwise spending time 2-3 years, we will be spending that much money also. So that is the general thought I shared. And that your questions, that CO2 capture, I think if I not CO2 capture में मेरा ये क्या है कि CO2 capture में एक estimations में किसी ने बताया था, if we convert to that value added chemicals, methanol, ethanol, whatever, तो किसी ने एक स्टडी किया था बॉम्बे आईटी का कि मोस्टली जितना हमें CO2 कैप्चर करना चाहिए टू मिटिगेट दैट जीरो एटसेट्रा, उसका 30 to 35% मैक्सिमम वी कैन यूज ऑन दिस. सो रेस्ट यू हैव टू सिक्वेस्टेट, और कोई चारा नहीं है. सिक्वेस्टेशन का तो अभी रिसर्च चल ही रहा है. प्रॉब्लम इज देयर, जो कोल बेड, मिथेन, वो सी बेड, ऑल दिस एरिया, दैट IIT बॉम्बे इज लीडिंग दैट एरिया, दे आर डूइंग द रिसर्च. बट वैल्यू एडेड केमिकल्स का एक लिमिट है, जो कंजम्पशंस का जितना मैक्सिमम हो सकता वो 30-35% पीपल आर गेजिंग. बट दैट वी हैव टू ऑब्जर्व ऑल्सो. इट डजंट मैटर 35% विल लिव अप, वो भी करना ही है. And other that
you also mentioned in your particularly presentation that whatever we as a scientist we doing in laboratory, that is the ideal situation.
Definitely.
Then when you go actually bigger plan,
yes. वो बहुत हमें उसको देखा क्योंकि वो जो रेजिस्टेंस है ना, डिफरेंट रेजिस्टेंस, सम एग्जांपल से हाइड्रो ट्रीटिंग, हाइड्रो प्रोसेसिंग से PPM लेवल यू हैव टू मेंटेन. दैट मीन्स ईच रेजिस्टेंस स्टेप इज वेरी इंपॉर्टेंट. वहाँ पे आपको स्ट्रेटेजिकली स्टेप वाइज जाना पड़ेगा. यू हैव टू क्रैक द मास ट्रांसफर रेजिस्टेंस इन व्हाट एक्सटेंट, व्हाट साइज. हाँ, समटाइम्स सम वैसे ना स्केलेबिलिटी, how many times you will do the scalability. Scalability is 2 times also sufficient, sometimes 100 times, because what type of resistance you are playing, you have to gauge that whether that resistance has been gone away with that much of size. A series of resistance, it may be kinetic resistance, it may be transport resistance. That proper scientific knowledge should be there. In that case, it may be 3 times also sufficient for your scale up. After that, scale up is required to take care of the non-ideality and that synchronizations of the control system and that availability of the equipment. Because scale up डिजाइन इसलिए चाहिए, कोई सारे इक्विपमेंट इतना लिमिटेड होता है, यू कैनॉट डू लेस देन दिस कैपेसिटी. ये आपका डिस्ट्रीब्यूटर मिलेगा नहीं, वो नोजल मिलेगा नहीं, इज लाइक दैट. उसके बाद आएगा कंट्रोल सिस्टम, इट इज नॉट फिटिंग प्रॉपर्ली. उसके बाद हैज ऑफ स्टडी से ऐसे एलिमेंट आएगा, यू हैव टू पुट अ लॉट ऑफ थिंग्स. वो कॉस्ट it is going away like anything what you have gauged ना. So up to hedge off, the DFR along with that hedge off, वहाँ तक जाने के बाद एक डिसीजन मेकिंग पॉइंट आ जाता है. बट उसके लिए जो कॉस्ट समटाइम वही थॉट कि इतना कॉस्ट क्या बिल्डअप करेगा. मान लो इसी EIL का एक बेनिफिट है कि ऑल द डिपार्टमेंट्स इन द वन अम्ब्रेला, सो वी कैन गेज ईच एलिमेंट्स. दैट वे दैट इज एडवांटेज इज EIL, that is there. But that way, that collaborating partner has to also support. That's why I'm told you, na, if you come in between, so many things has not been impact study has not been done. So हम वो लेफापोती टेक्नोलॉजी कर लेते हैं. So both we become sufferer. So that's why always some talk I also share that it should be right partner in right time. उसमें cost saving होगा, robust टेक्नोलॉजी होगा. एंड पहले से लेने से ना है ना कि आपस में कोई सारे कॉन्फिडेंशियल चीज़ शेयर होता है, अगर पार्टनर बाद में बनाएंगे ना कुछ शेयर नहीं करेगा. वो होता है ना. तो दैट इज वन थिंग. इफ इट इज ए क्रिटिकल टेक्नोलॉजी, सी समटाइम्स ए सिंपल टेक्नोलॉजी, प्रोडक्ट डेवलपमेंट इज देयर, नथिंग नॉट मच ग्रेट थिंग्स आर देयर. बट सम आर बिग टेक्नोलॉजी, क्रूशियल टेक्नोलॉजी, जैसे बिग लाइसेंसर्स. सी मिडिल लेवल, इवन पेट्रोकेमिकल्स, मिडिल लेवल, हायर लेवल लाइसेंसर्स, दैट वी कैनॉट रिप्लेस. अभी तो ये है, लेकिन ये भी क्रैक कर सकते हैं. हम इथेन क्रैकिंग वर मेंशनिंग, सम यू नो इट. वी ट्राइड इन 90 दैट इथेन टू इथिलीन एंड प्रोपिलीन. वी डेवलप्ड ऑन द टेक्नोलॉजी. इट्स दैट थर्मल बेस्ड. वी पुट अप ए 4.5 मिलियन कैलकुलेटरी हीट ड्यूटी का जो है इसमें लगाया पानीपत में, सॉरी नागोथरा में. दैट टाइम इट वाज IPCL. That time it was IPCL. That was running, it was commissioned in 94. Fortunately, I joined in 90, so I was aligned in that. But at the first level, it was not working. Problem क्या था? Simple I can share. The convection bank design है. पहले तो हीटिंग में सारे हाइड्रोकार्बन हीट होगा, देन कन्वेक्शन बैंक में हीट पिकअप होगा. सो जो फीड आ रहा है कन्वेक्शन बैंक एंट्री करेगा, प्री हीटेड होगा, देन इट विल कम टू द हीटर. सो मान लीजिए 500 में उसको इंटर होना ही है, एंड ऊपर से वो 300 होगा. बट वो कन्वेक्शन बैंक का हाइड्रोकार्बन का जो हीट शील ट्यूब होता है, जिसको हम बेयर ट्यूब बोलते हैं, वो तो पहले ही रहता है, क्योंकि वो इसका रेडिएशन जोन का तो हीट तो वही फेस करेगा ना. तो उसका कैलकुलेशन में आया था 1.2 नंबर ऑफ रोज चाहिए. somehow that time who is designing he has put the rounded number 2. तो obviously that 1.2 आ रहा है तो 2 रो दे दो, तो 2 रो दे दिया. That is the mistake. When it was not working, when we troubleshoot that is the problem. So because giving that 2 row, it is taking up the all heat. So it is not getting heat. So lower heat में आ रहा है, तो crack उतना conversion हो ही नहीं रहा है. तो what spreaded की this Indian technology is not working. And in 94 that time pushing the technology was very hard. आज तो आई थिंक 2008 से 9 के बाद टेक्नोलॉजी पे उसमें थोड़ा एडवांटेज मिलता है, एंड ऑल्सो वी बिकम रोबस्ट. दैट टाइम वॉट एवर यू डेवलप्ड पहले तख्त में रख दो. इट वॉज लाइक दैट. बट दैट टाइम ऑल्सो इट वॉज आर्गुमेंट सिंपल और स्प्रेडेड दैट इट वॉज नॉट वर्किंग. सो हाउ, क्योंकि दैट टाइम 4-5 क्रैकर टेक्नोलॉजी केम. सो ऑल दैट लाइसेंस बाहर से आया है. अरे ये तो अभी इसको ट्रबल शूटिंग करना है, टाइम लगेगा. लेकिन दैट इंट्यूशन वाइज दैट इंडियन का यूज नहीं करना है, वो आ गया. तो छोटा छोटा सिंपल जो ट्रिकी इशूज, हाउ इट जेपरडाइज योर पूरा टारगेट. उसको जो आफ्टर दैट वी ट्रैवल शूट इट, इट इज वर्किंग फाइन एंड पैरेलल इट इज वर्किंग. बट बाय दैट टाइम द बास इज गन. वो बाहर से सब आ गए. उसके बाद तो 4-5 years कोई क्रैकर नहीं आ रहा था, तो वी लॉस्ट दैट अपॉर्चुनिटी. सो दैट इन बिग एरिया वी लॉस्ट द अपॉर्चुनिटी. दैट इज द फेलियर केस वी कैन से. बट दैट वी डेवलप द टेक्नोलॉजी क्रैकिंग, उसका जो कोकिंग मॉडल, रन लेंथ कितना होगा, TLX डिजाइन वाज क्रिटिकल. दैट वी डिड आल्सो EL से डिजाइन किया था. इसका TLX भी क्रिटिकल होता है, क्योंकि वो हाइड्रोकार्बन जाके ना 2 फेज सिनेरियो में जो TLX होता है ना, हाई टेम्परेचर ड्रॉप 835 से 300-400, उसका MOC चूज करना भी वेरी टफ है. बट दैट EL डिड इट. सो इट वाज दैट वाज वेरी सक्सेसफुल. बट द फर्स्ट चांस वी गॉट दैट बैड नेम, तो अपॉर्चुनिटी लॉस्ट. सो दैट्स वाई ना, ये जो चीज़ है दैट टेक्नोलॉजी से रिलेटेड नहीं है, इट कम्स लेटर ऑन.
Okay, thank you. Now I request our director, your thought about crude to chemical and how actually IIP can do actually.
All the stalwarts are sitting here from the industry. When you design a unit, you put a feed specification, right? And plant manager will never allow you to violate the specification of the feed. As naphtha cracker feed has a specification. Suppose I bring a bio oil or a pie oil or something. You will first check whether I am meeting the feed specification or not. You will not allow me to put anything into your plant which is violating the feed window. So that way the challenge with the technology developer is to take a very, very diverse range of feed where you don't have any control on the specification, and convert it to something which is having very narrow specification for the particular unit where you are targeting your product as a feed. So that way it becomes a big challenge for, we are talking of crude to chemical, but you see so far the commercial units, they have already maintained that narrow specification of feed. Nobody is saying that we will put anything, any garbage and get a gold out of it. So that is the biggest challenge, and a lot of R&D is needed for that. Still, the field people are talking of crude to chemical for a very long time, but the diversity of the problem is much, much bigger, and a very concerted R&D effort is needed. That I talk bio oils. See, first thing is the oxygen percentage in bio oil. Huge oxygen is there. And any refinery unit, most of the refinery units, I will say, there is a spec of oxygen. You cannot go above ppm or at least a point per percentage. But here you are talking of 40% oxygen. So that kind of challenges one has to overcome by doing something before coming to the refinery gate. So those are the gray areas where a lot of work is to be done. And secondly, as he's saying, that first is the technical feasibility. Whatever you are saying, that should be doable, no matter at what cost. That has to be proven that yes, I can take any material and I can do something, some black box magic, and convert it to the which meets the specification of the particular unit I am targeting. Then comes the second question, how economical you are. I convert everything to a feed which is meeting your spec, but the price of that feedstock goes above the cost of crude oil, then you are not going to put it. You want it something which is cheaper than the feed you are already putting, right? So if you don't bring down the cost, then you will not put it. Any refiner will not go with this kind of feed. The third thing is that X amount of CO2 I am emitting today using fossil fuel. Suppose doing all those juggleries, I am emitting more CO2 than the fossil fuels, then also the purpose is getting defeated. So that is why I was saying that this needs a good marriage between R&D institutes, engineering institutes, and refining industry to work together to find a solution which is feasible, technically feasible, which is economically feasible, and it is sustainable also in terms of CO2 mitigation. So all these things together, no one has a right answer today. There are so many challenges, even in pie oil also. If you see the current pie oils, I'm not talking of our process where you have a secondary polishing unit, but the typical plastic pyrolyzers, they will give you a black liquid, or it's like a crude oil. But if you check the specification, the silicon percentage will vary from one level to maximum level. You cannot design a plant for such variation of a metal impurities or silicon impurities. So those kind of challenges are still there, and a lot of concerted effort on R&D has to be done. Which are the best, most economical processes to convert these diverse feedstocks into the specification which the refinery will happily accept? That is the biggest challenge actually. And if Matthew asks me, I don't have a solution right now that what is the right way to do it. A lot of work has to be done. A lot of permutations and combinations are to be tried before reaching to a level where you can confidently say that anything comes, I will make it compatible to the refinery. So that kind of work is yet to be done. I think no one has done this kind of work right now. People are targeting a small window, and then they are, every unit is very specific unit they are putting, and then converting to petrochemicals. So still a lot of questions to be answered. No right answer right now with me also. Mati?
Yeah, now it is, of course, there is a lot of questions. Of course, there is no actually single answer is that, because it's a refinery, it's itself a complex situation. So in this, now I open actually for auditor, even that all open. So you can also ask if we have any doubts that how actually we can handle that with respect to crude to chemical.
One thing I just want to add, we have our Indian mindset should also be changed regarding some premium pricing also. If we are making anything from CO2 or maybe bio, like in a Europe or US, they are paying the premium prices on that. But in India, we are always going cheaper side. Whatever the harm in the environment or whatever the harm, we are not looking on this side. So maybe this is a government responsibility also to push the things in the premium price. They can put okay, premium price should be there, or government bear some taxes, some losses on the taxes side. That is not possible in the government side. But mindset, the people mindset will also change, because when I have seen in Europe and US, these guys are ready to pay premium if it is manufactured by the bio, or it is manufactured by, maybe it is reducing the CO2 or maybe some alternative routes. So, but in India, premium pricing concept is not applicable anywhere, what I have seen. Even in the industry as well as in common public also.
I will add to that. See, there are two ways. One is you increase the premium, or government gives you subsidy, like the PLI scheme. See, we are trying to create a manufacturing hub for batteries and EVs. And in that way, government is giving the PLI, production-based incentive, that if you making a product at X price, you bid what is the minimum discount you want from government. And the person who is asking minimum discount, that will get the PLI. So that is like a open tender. So suppose the battery price today is say $120 per kilowatt hour. And a company says, okay, I can make it with 10% discount. Other says I can make it with 8% discount. So the company who is offering 8% discount will say, you make. First priority is to you. Then the next person and next person. Similarly for CO2 mitigation or petchem or chemical increase also, I think a time will come when this kind of PLI schemes will come, which will give some benefits to the refiners or petrochemicals who are considering the net zero target, because ultimately the government has put a net zero target and it is net zero. It is not carbon neutrality. So there is a difference between carbon neutrality and net zero. So you are talking of net zero means carbon neutral up to the gate only. After that, whatever happens, you don't mind, right? So that kind of things we have to see. So I think in future there will be some incentives to refiners who will target the carbon mitigation. That is for sure. And some premium also maybe here like Europe they are SAF price is 3 times the price of ATF. So that kind of premium if you get, then manufacturer will be motivated to produce those kind of products.
Yeah, now it is open for all. You may have some doubts and clarity. Anybody? So if not, I just, of course, as a scientist, because from the HML and Panipod is also there, as a research institute, R&D institute, what we expect from us actually, which directions and what problems we here solve for you.
Sir, as a refiner, already I have shared in my presentation, one of the biggest issue what we are facing is the Indian technologies. Small technologies of India, we need to, especially in the utilization of waste. This is one of the challenge, like water treatment, whatever the bio refinery waste, how to utilize in different way. Because this type of area where we can utilize a small project, but this impact is very big because it directly impact the operation of the plant. So once is the operation of the plant, then definitely our other benefits will come. Thank you.
Water treatment. Now the water treatment will be a big problem in India because there is a lot of scarcity of this water. And any thoughts from this? What actually we can solve?
From our HML side, I already mentioned in our presentation also, if we can optimize our fuel efficiency, even a little bit, then we can save a lot of money from there. And that money we can, once the confidence will get up from the refinery side, okay, these R&D innovations, I am not not talking about the breakthrough innovations required, the breakthrough invention is required. We require innovations initially. Okay, small innovations can improve the profitability of the company, or maybe getting the confidence on the institute or maybe on the research side. Because this is maybe the bad image of the R&D in India, that the people are not much more get a confidence. Even in Indian, like Dr. Mehti has already mentioned, if anything develop in India, then they are also looking in the doubt form. Okay, it is working or not. Same in a European or US guy will say, then the people will more convinced. So there is a lacking, some confidence is getting there. So lot of innovations required. Maybe the breakthrough is not required immediately, but innovations in the fuel efficiency side or optimization of the existing process, that will give a lot of boost to the companies as well as the R&D. Make a trust between the R&D, academia and industry also.
Oh, in your presentation also, okay.
I would like to add one more point over here, that there is a gap between academics and industry. They both run parallelly. Now somewhere they have to meet. So my submission these days, if CSIR makes it compulsory for scientists to spend at least a year in the industry and get the experience of plant operation, they will have much more better understanding of the problems. Because sitting on the camel controlling goats is not going to be possible. So I urge that if you can have a mechanism instituted wherein scientists has to go to industry, spend 1 year, understand one plant only, not all plants, only one plant. Let us be focused. Go to a plant, understand entire operation, what the challenges are, how it operates, what are the challenges. You'll be in better position to offer solutions.
This is actually really fantastic idea, and our scientists should go and just see that how much operation.
Otherwise, they'll not be promoted.
Yeah, but no. This is not a problem for us. Can you assure, particularly that from the industry, can you assure that when scientists going and can you allow touch your
You just follow the plant operations. I'm not saying that if you operate the plant, you see the plant operation, how it operates, what are the challenges there, how the operating conditions are maintained, what are the products, what are the impacts on the product qualities with the operating conditions. Those things, once you get the feel of that, then only you'll be able to in better position to understand the problem of industry.
As we take refinery trainees, we can think of short training programs of our scientists to go to the units of their area. Like a person working in delayed coker, as Matthew is working on delayed cooking. So his team can go and visit some commercial delayed cookers. A person who is working on naphtha crackers, ethylene production, they can go to some refineries where naphtha cracker is working. Somebody who is working on FCC can go and just see how the real plants are working, how the utilities are generated, how much because in the lab level, scientists never bothered of the heating, how much heating he has to do, what kind of water is required. Nobody will bother because that amounts are so small. But in a real commercial plant, if you 1%, 2% increase in utility will entirely change the scenario whether your process is profitable or not. So that kind of impact it plays. So a view of the things, the work you are doing for implementation of some real units, how those units run, that kind of idea, if the scientists get, it will certainly improve the quality of research. That is good.
In this respect, I want to add, this is actually a novel idea. But CSR level, actually, it was started 5 years before also. Scientists go to this industry and spend at least 1 year, 6 months. It was there. But it is not actually utilized properly, or it is not materialized properly. So we can revive that angle once again.
The problem is, Avitas, is that it is only on paper. When there's a will, there's a way. The will has to be there. At the same time, but I know, back of the mind, scientists बोलते हैं, अरे मेरे को 1 साल रहने का वहाँ पे, family इधर रहेगा, मैं क्या करूँगा? अरे मेरे allowance नहीं मिलेगा, मैं क्या करूँगा? All these things are there at the back of the mind. But if you want to really serve the nation, we have to come out of all these problems. Otherwise, it is just going to be on paper. It is forced, and how it will be forced by Indian works under pressure. What I observed is that India works very well under pressure.
I request colleagues also to ask some questions if there. It's a good opportunity. Anybody can ask.
And if you make promotion policy linked to this training program, definitely scientists will go.
Actually, that will be that thrust. If there is any enhancement of the promotion. Yes.
Same way from CSIR to industry. So we have mobility scheme. CSIR scientists can go to industry, spend time there, but not only for seeing how plant operates, but get the skill imparted and get involved in the plant operations. It has to be that way. Yeah. So and this is not only on paper. In the case of NISCIR and NISTATS, we had done 2 mobility approval a few time back, maybe 5-6 years back. So that scheme is available.
The scheme is good, but maybe the government or PSU, I don't know, But the private, maybe the integrity is the one of the major challenge will come out, because if anything is because companies are normally in the closed loop and they will not disclose anything. If anybody is come out who is not on the payroll of the company, if he can any loose talk or anything they can do, it can be the this one. Some challenges there. Idea is very good. It should be there, but some more
This kind
will
of
be required.
mobility happens with the execution of confidentiality, that non-disclosure, MOU kind of a thing, so that everything is maintained confidential. So that is integral part.
Now, my friends, any questions? Any?
Hello. Hello, sir. Yeah, this is Dr. Senthil, sir. And sir, we are talking about the costings, like especially in terms of, fermentation plants to produce 2G ethanol. It depends on the feedstock to feedstock, where you will get a different type of hydrolysate and purity level. But, in the R&D level, whenever we interact with the industry, they talk about the production unit, like, for example, fermenter means 7 lakh liters scale. So that would be the, end where the production happens. But, we do not have that type of, interaction to make the cost estimation at the R&D level by comparing with the, the very high level. So is there any interface, the kind of people or marketing or some kind of people, where they make a cost estimation for the R&D scientist that would really bridge between the production to the R&D level linkage, especially the cost analysis?
Yeah, that actually link can do in the EILs, no? Yeah.
What what I suggest, that getting that cost, see, first level you have to establish your technology. You be confident on the technology. Don't forget about the cost. After that, then you have to do the detail costing. That cost analysis is very detail costing. जैसे EIL में होता है, we have the costing unit department. Type of information they need, you cannot provide. Once you have a detailed BDF, only you can supplement their informations. Otherwise you will be like that, some prorated, इस फिगर का इतना था, उसका complexity different है. इस type of मोटा मोटा cost जो होता है, that you can do. Normally people do as a thumb rule. So ये tricky questions है. You develop your things, then your organization will take care. As a that BDF portions and pre-TIP and BDF portions of analysis, वो तो that portions that your organization will take care.
अदरवाइज पॉइंट मैं जोड़ देता हूँ कि एक हमारे कंट्री में देयर इज वन ऑफ द प्रॉब्लम इज दैट we don't have sophisticated pilot facilities where we can do such kind of cost testing, because lab data is not sufficient to do proper costing. So pilot scale testing एक combined facility, maybe it should be a joint effort of all PSUs, private refineries and CSIR also as part of this. A big concerted facility where you have few pilot plants of good enough size where engineering companies will be comfortable to do all the costings, utility estimation, yield profiling, everything. So that is still lacking in India. We need somewhere a very concerted effort to get a facility where you have different pilot facilities of significant size, where you can do those kind of lab scale to pilot scale, and you should have a trained manpower to run those, because lab scales laboratories are not well equipped to run big pilot plants also. Each pilot, we are running a few pilot plants, we know how much manpower is needed, how much cost of running those pilot plants. So those kind of facility, if somewhere concerted, and anybody can come there on chargeable basis or whatever way, if they can do their proof of the big pilot scale data, that will increase the pace of commercialization of lot of technologies. I think we should think of that area.
We are also looking sometimes the pilot plant to testing our catalyst, new catalyst, or like catalyst companies are coming and they want to test their catalyst because as a new vendor. So we are also facing same type of problem to pilot plant. So industry should think about it. At a collaboration they can put on their
Very costly. Very costly. The similar concept of having a pilot facility where all the industries can take advantage. We had in Roha a CTP pilot plant because every company they discharge norms are different, and they believe on some consultant but they don't get the result. Yeah, especially bioaeration and those kind of work. So we made a pilot facility comprising of primary, secondary, tertiary, and we made all the industry to come, pay on per hour per day basis, and try different strains, try different biomasses, and see what they get out from those different composition of feed. So this is very well established mechanism, and people have started doing that in environmental science. But I think this is due also for this kind of work. Yes. Yeah.
No, basically the problem with refining industry is that if you look at technology in refining, the technology does not change once it's established. It will be there for at least 10 to 15 years. The technology will not change much. Whereas if you look at mobile industry or pharma industry, there is a competitiveness and the technologies are changing rapidly. In our case, the problem is that technology change is not so rapid. Like where we have done the investments for Euro PS6 fuel, it is for the next 15 years. It's not going to change much. So, yeah. Yeah, that's why the point is that nobody thought of putting up a pilot facility to, and also, yeah,
Yes, it is.
yeah.
See, if you are talking of one company, it will be a huge
Investment. And this will be possible only when there is a strong pressure from government to go for completely Atmanirbhar Bharat.
The penalizing something is the old methodology. Incentivizing somebody is more better. So like when you were saying that don't give promotion, I would say give them incentive or give them promotion because they have done that. Similarly, having a pilot plant which is managed by IOCL, BPCL, give them incentive to do that. Take the responsibility in their premises that you have pilot plant running and people are coming and they're taking the use of it. They are paying like the fee, whatever the charge is, even if it is modest.
No, in fact, CST will be the right forum. The CST can bring in all OMCs together, together, and we can note in this idea for common testing facility.
But then the problem is the approvals with CSIR. Like you need certain approvals, and then it's I've seen that there is a little bit of it will be more from the PSU side. So CST is the organization where all the PSU can actually they have money also. So we have CSIR has limited budget, so if you are thinking of a very good multi-pilot facility, it should be more than 1,000 crores. So that kind of investment in the PS will be the companies like IOCL. I wish I was here.
At the same time, there should be programs in lineup so that this facility is utilized. It should not happen that it is ideal.
And there should be a because once the plant will shut down, will be again
take the proposal from the companies and evaluate the necessity of it, the extent of it, and then the proposals may come.
Yeah, Dr. Ramesh.
Yeah, sir. Coming back to the crude to chemical, in terms of Indian refinery situation, what API limit is the best to convert the crude to chemical? Because in China region it is different, in US it is different, and in Singapore it is different, in Saudi Aramco it is different. But what you expect in Indian scenario, what should be the API ratio or range for the crude to chemical?
No, he is actually asking because as I told you that Hengli, for example, they are using 43. For example, Aramco, they are using the 47 and some things. So no, we are talking about the opportunity. Obviously, it will be the less than the 30. If it is possible. So what is your thoughts?
Actually, what I have shared also, basically the use of what range of API we can use a crude is basically depend upon the refinery configuration. Basically, the metallurgy, whatever the metallurgy, how MOC, what is the strength of my system. So, I think nobody is having the right answer of this question. Ki what is the correct? That depend upon the what type of crude we can plan, and then we can plan the refinery or our plant like that.
Umesh,
Yeah.
actually you should give the answer to this question, that what kind of APIs will be good for crude to chemicals, rather than asking the industry this question. This is our forte, so we need to study this and go to the refinery and tell them that we can give you a process where you can go to a API as low as 24, 25, but you can produce good amount of petrol.
Sir, but in that case, they will say that we are not able to get that type of crude at that time. So the whole exercise may affect. So that's why I am asking this question. Okay,
I'm
we are
saying go to
comfortable
the
with
lower
30,
API.
35.
The lower the API, the cheaper the crude. So everybody, he will say, give me 10 API crude. Will you be able to process that?
It is not possible.
So that question we have to give answer, and we are there to, we are working on this project. And sincerely, since I come from refining background, so I'm trying to give them the idea what refineries are looking at right now. So that kind of inputs I am also providing while discussing with the project. Matthew is our project leader for this crude to chemical project. So a lot of iterations, lot of info movements are happening, and we are going to come with a big project in a mission mode very soon, and we need good industrial support for that.
Actually, that is our main purpose, the industrial mission. We need actually good industrial support. Yes, Dr. Manoj.
Yeah. So good afternoon to all of you. This is Dr. Manoj Srivastava from IIP. I would like to just add in this forum. We have two real experiences. The first thing, we feel that there should be a close interaction between the refinery and any academia or CSIR labs, etc. The reason is that for that, when we understand the client or customer, we can understand how many streams are available which are low value, how we can add value to that. So the one story is that the Numaligarh refinery, where during the discussion, we found that they have delayed coker unit. They were processing MVGO and HVGO in the delayed coker unit. That is a paraffinic rich because it is a waxy crude. Assam crude is a waxy crude. So they were putting all these MVGO, HVGO into the delayed coking unit. So they were not getting proper yield and poor quality cokes. So during the interaction, we found that this is happening. So we suggested then can we recover the waxes, paraffin waxes from the MVGO, and remaining portion you can divert to the delayed coking unit. So based on that, we have done 3 projects, and finally IIP with the help of EIL, we have put a 50,000 tons per annum wax deoiling plant. So they are earning more and they are in the profit business. Second example was that in the HPCL Mumbai refinery, they have lube block as well as fuel block. They have 3 solvent extraction unit, where one solvent extraction unit was underutilized. Again, they were processing Bombay High crude. So in the FCC unit, their CLO was waxy in nature. Although it is rich in aromatics, but it contains sufficient amount of the waxes. So during discussion, we found that, and finally, we suggested that we will do some basic experiment. So we applied solvent extraction on their CLO and recovered 75 to 80% paraffinic rich portion and some aromatics 20%. So that 75% to 80% paraffinic rich raffinate, it was again recycled back to the FCC unit. So when this portion, so this was an additional feed to them. And with the investment of the 50 lakhs, by laying the line between the solvent extraction unit and FCC, they could earn 90 crores per annum profit. So these are the 2 examples which says that every person should deal with the customer. What is the configuration? Where are the available streams, low value streams? How we can do innovation, etc. So we can get maximum benefits and opportunity to process them. Because in the petrochemical scenario, crude to chemical, we have to see different refinery, what is the configuration. So how we can apply our knowledge and get more petrochemicals out of the crude. Thank you very much.
Okay, thank you. And yeah, we can hear you. Huh?
We were talking the issue of carbon dioxide, CO2, where we can put. My one simple suggestion, we can put in our car tires. In place of nitrogen, in place of air, if CO2 is filled, what may be? The number of
This work has been done. You will not put 0.1% of the total CO2 into the car tire. It's a very minuscule amount. With that, this calculation has been done already.
Okay.
And there are some corrosion issues also. Because if you get moisture, carbonic acid formation, and those kind of challenges are also there. But this amount is nothing in terms of the total CO2 emission we are doing.
No, number of tires are.
Yeah, that
millions.
calculation has been already been. You can calculate also.
Okay.
It is not big amount.
Now we can conclude here. Yeah. Yeah, already we have just past time. We can conclude here. Thank you everybody, and particularly all these panelists. And now we can proceed further in most probably vote of thanks.
Thank you, sir. Now coming to the end of the session, I would now like to call upon Dr. Sanat Kumar for his concluding remarks, followed by Dr. Umesh Kumar for his vote of thanks.
So, respected director sir, dignitaries from the industry, my fellow scientists from CSIR, different CSIR labs headquarters and IIP, and all students who are present here. As we come to the end of this very interesting and a very interactive one-day industry meet, I'll just like to briefly recap what has happened since morning, because lots have happened in this small period. So, to start with, in the welcome address, our director set the tone of the industry meet, where he emphasized the importance of this chemical industry in the India's growth and what is the prospect. There is a lot of growth potential for this industry. And he also discussed about some of novel technologies and initiatives that IIP has taken, which has been adopted by the industry. Our chief guest, Dr. B.P. Thaplia, touched upon a very different aspect of this whole whole industry, is that the paper and pulp industry and how their waste can be integrated with the petrochemicals and refineries. It's a very good initiative that we should work upon, and the potential of the economic impact of the paper and pulp industry as well as the social economic impact is quite substantial if we do this integration. Now, these were followed by about 7 presentations from the industries, mainly Indian Glycol, Godrej Chemicals, Flochem Pharma, BPCL, IOCL, HEML, and EIL, and 8 presentations from 5 CSR laboratories. Now, these industries, I would just like to summarize what the industry's perspective was. They gave us their activities, their vision, and what are the constraints and problems they are facing. I'll just summarize that something that will come out common to all of them is that we have to work towards sustainability and green chemistry. That is very important. The importance of new chemicals and new molecules. We have to keep pace with the changing global dynamics, also look upon the new molecules, how people are moving ahead. The importance of AI, the indigenous technologies for particular niche chemicals, and also valorization of low value products, the byproducts, the waste treatment. So these are some of the areas that the industry needs our help. Similarly, the CSIR labs gave a very good perspective of the type of work they are doing, particularly the biomass to chemicals, where a lot of labs are working and a lot of good breakthroughs have been made. CO2 utilization, new chemistries, plastic circularity, bio-based chemicals, and many of these have already been adopted by the industry. So if we compare the industry requirements and the expertise available with the CSIR labs, we can safely say that there are a lot of expertise available with CSIR, which even the present requirement of industries can be met by them. Now, this has definitely given the scientists a food of thought, how to restructure their R&D activities, how to maybe mold the existing knowledge that we have. And also industries have got a good glimpse, a good grasp of what CSR can do for them. So I'm sure both the industry and CSR have benefited by this, and surely there will be a lot of collaboration. Industry would like to use the expertise, we would like to work with them, and we hope that together we can definitely take this industry to new heights. And this follow-up interactive panel discussion, which was meant for crude to chemicals, definitely brought out the limitations and the prospects also. It is a very good concept, but then a lot of challenges needs to be addressed, both on the technical as well economic side. And then some initiatives like having a common pilot plant. It's a very good initiative because we at a CSI know the constraints we face using a pilot plant. The industry can fund it, but probably they cannot operate it, as we come to know from different structures. So a common ground is there to develop, maybe even in CSR campuses, that we can develop pilot plants which can be funded by industry, used by industry. And the mobility of CSI scientists to industry, has been a part of CSIR, but hasn't taken place in a great extent. So we would also request industry to consider this aspect to, enhance the skill, not the scientific skill, the practical skills of the CSR scientist. So I'd like to conclude with this, hoping that the collaboration, this will lead to a future collaborations and many more industry meets. Thank you.
Good evening, and eventually we came to the end of the session, the whole day program, and I really sense that it is a very good, and everyone has shared their thoughts very heartfully, and they are welcoming the scientists to come to their premises and have their experience at their premises also. So it's my privilege to express the vote of thanks for the community from the industry as well as the scientists from the CSIR. And first of all, I would like to thank our director, sir, for supporting tremendously in this program. And without your support, this cannot happen, sir. And I'm thankful to our chief guest. He has taken his time out from his busy schedule because he was at the Delhi, and once he was out of the station, and he immediately come to the Dehradun to attend this program. And he has also taken the program to the next level, where the pulp and paper industry can help, or we can help the pulp and paper industry towards their profitability. I am thankful to the industry, like our friends from the BPCL, HMEL, IOCL, our EIL, sir, and our Godrej, as well as our India Glycol. So thank you all for your time and support. And I am thankful to the all CSIR laboratory persons who came all across the India to participate in this event. Thank you. I am thankful to the CSR family member from the headquarters, Dr. Anuj. He also take the time from his schedule. And I express my gratitude to all the team members, especially who was working tirelessly to manage this program, arrange this program, from the primary committee as well as the secondary committee members, students, as well as our ESD members, ASD, our administration members, and as well as our PME and director office members. So thank you all. Without your support, this program cannot be a success. And with this, So all of you are invited for the high tea, and with this we can close this program. Thank you. Thank you very much.